Hello. Check one check. Hello.
It's mute.
Hello. Check. Hello. Check one check. Hello. Check. Hello. Check. Check. Hello. Check. Hello. Check. Hello. Check.
I think battery is on you.
Hello. Check. Hello. Check.
I will call it.
Hello. Check. Hello. Check one. Hello. Check. Hello. Check one. Check. Hello.
Okay.
Hello. Check.
Working there.
Check. Hello. Check.
This one working.
It's on.
Hello.
Hello, hello, hello. The light is not on.
Yes, it's a light.
Okay.
It's on.
So I switch it off?
Hi, good morning everybody. Good morning everybody. Awesome. We had an awesome day one yesterday. I hope you all have the same feeling. Before we start day 2 and the keynote for day 2, just some conf updates. We'll be having a panel discussion today, 2 to 3 in Audi 1. We have open spaces all around the day, so if you're not interested to attend any of the talks, you're free to propose a topic or attend any of the topics that are going on. These open spaces happen on the first floor and in Auditorium 3. There is one open space by Nolarity, so do check out the time and the place. It's in Audi 3. Apart from open spaces, we have lightning talks during the evening that starts at 4:45 till 5:30. It's a 5-minute flash talk. Any library, any cool project that you want to showcase, feel free to contact me or Chris, or just post it on the whiteboard outside this auditorium. Right? Beginning day 2, we have our first keynote speaker, Michael Ford. Michael is the creator of Python mock library. He's an author of the book Iron Python in Action. He's also the maintainer for unit test module and Python standard library. Currently he's working with Canonical on Juhu, which is a cloud automation tool. On Twitter he goes by the handle known as Void Space. So please welcome Michael Ford.
Can you all hear me now? Ah, wonderful. Hello everyone. Morning. It's wonderful to be here in India. My first time in India. I feel very privileged and honoured to be here and to be speaking to you. I've had a wonderful welcome, met lots of wonderful people. And it's clear from the real sense of community and the real sense of open source culture, but more than that, for the number of just smart and talented people, and particularly the number of young people. Makes me feel very old now. But it's very clear that India has a very bright future, and particularly if you keep pushing with the startups, keep innovating, and even more importantly, this culture of mentoring and teaching and bringing people into the open software movement, that's going to be a real powerhouse for the future. So that's a slightly old picture. I thought I'd tell you a little bit about my background and how I got into Python, got into programming, slightly unusual route. So I've been programming with Python since 2002, so about 12 years now. But the story happens way before that. I grew up in the era of 8-bit computers, computers like the BBC Model B, the ZX Spectrum, and the Commodore 64. Who remembers computers like that? I'm not the only old codger here, that's good to see. And those computers, you would switch them on, and they would boot pretty much instantly, because they booted from one. They would boot to a programming interface. If you didn't run a game or run some other software, the interface you had right in front of you was one for programming. So myself and hundreds of thousands, possibly millions of other kids, we learned to program on these machines, and I spent hours tinkering around with BBC Basic, as it was then, which, although it was a version of Basic, my code was full of go-tos, horrible code, but it did have subroutines and functions. So you could do some measure of structured programming. Then after that came the 16-bit machines. My favorite computer was the Amiga 500, made by Commodore. And Commodore completely screwed everything up. But despite that, they managed to build a wonderful machine. And it was the first preemptive multitasking operating system, way before Windows was doing that. But at the time, I didn't particularly want to go into computing. I wanted to be a lawyer. So I started doing a law degree at Cambridge University. I did about a year and a half of that, and then for various reasons, which is a whole other story, and if you want to hear that story, you have to buy me beer, I dropped out of university, and I went on to sell bricks. I became a salesman in a builder's merchant, selling building materials, timber, bricks, and so on. And I did that for 10 years, and I didn't really do anything with computers during that time, other than use them for email and so on. And I started playing this game, play-by-email game. I think some of them are still going. This one was called Atlantis. And what would happen is you had your armies and your castles, and every week you would email your orders into this central server using a specific format, and you would send your troops off to explore, fight battles, discover lands, build castles, and so on. And everyone else would do the same. And then the central server would process all of these orders, work out what had happened, battles had been fought and won and lost, new lands discovered, castles built, and so on. And it would email back a report to everyone. But because this happened just once a week, all the really interesting stuff happened in between during that week, and the diplomacy between the different players. And I was part of this alliance. And none of us had done any programming except, like myself, a few back in the dim and distant past. But we figured, as this report was computer generated, it followed a regular format, and we were getting it by email. Wouldn't it be great if we had a program that could read these reports and understand them and build up, combine them for us, so build up a map of all the territory we'd explore, and even issue a few commands for us, a bot that would help us play the game. And so we did a little bit of research on the internet, and we decided that we settled on Squeak as the language we were going to use, a Smalltalk variant. That would have been a fine language to choose, but at the very last minute, someone said to us, no, what you should do is you should use Python. Python is great for this. And we just said, yeah, okay, sure. So we started to learn Python. One of us, not myself, built a parser built on regular expressions that could understand the reports and build up a data structure from them. And on top of that, I built some code that would combine our reports, combine the maps, so that it would a persistent data structure of all the territory that we'd explored. And also, because it knew the terrain, if you gave it 2 different locations, it would work out the shortest path between them and issue the move orders for your armies to move towards that location you wanted to go to. And that was an implementation of Dijkstra's algorithm for pathfinding. Still, variants of that, A star, which adds heuristics to Dijkstra's algorithm, is still used in games programming today. I found that to be great fun. I was very proud of it. And what happened was I was bitten by the programming bug, I was bitten by the Python bug. I really enjoyed it, and long after I'd given up playing the game, I was still programming in Python and using it for various bits and pieces. And along with Python, I discovered the open source community, this whole world of people building stuff, doing stuff together online. I'd not met, even in the first few years of my programming, I lived out in the wilds of Northampton in the middle of England, not many computer programmers there. So for the first few years, I never met another Python programmer. But I got involved in this whole online community, and through IRC, and I started blogging regularly. I wrote some articles for magazines, and yeah, that was back in the day when magazines was still a thing. So I wrote articles on URL-lib2 and Unicode. Some of the stuff I'd done for URL-lib2 I contributed back to the Python documentation, and I got involved in all sorts of other projects, open source some of my own work. And after a few years of doing this, probably about 3 years, I decided I no longer really wanted to sell books. I wanted to become a programmer. And I thought, well, I've got no commercial experience, so I'll have to find an entry-level job somewhere. Horror of horrors, I might even have to do PHP for a while, because it seemed that's what most of the programming jobs of the time were. But thankfully, things didn't get as bad as that. I found a small company in London, a startup called Resolver Systems, and they were building a spreadsheet application that was going to take over the world, was going to replace Excel. It was designed to be programmable from the ground up, and it was written with IronPython. IronPython being an implementation of the Python programming language for the Microsoft .NET framework. And I went to interview with them, and they could, even though I had no commercial experience, they could see from the stuff that I'd contributed to open source, the articles I'd written, everything I'd done, my involvement in the Python community, my blogging and so on. They could, not just from the interview, but they could see the depth of my understanding of Python. And so I joined Resolver Systems, and I think at the time I was the first programmer there with any Python experience. They'd come to Python because they needed a scripting language for the spreadsheet that we were building, and they were doing test-driven development. And they found that IronPython not only is a good scripting language, but Python is so much easier to test than the statically typed languages that they were used to, and they thought, well, let's see how far we can get building the whole product in Python. So I worked with them for a few years. I started to attend Python conferences, and because we were the first company using IronPython commercially, I wrote the book IronPython in Action for Manning Publications. And at PyCon, I met up with all these the Python core developers that I've been interacting with on IRC and the issue tracker. Now, at the time, the Microsoft team who were building IronPython, they weren't allowed to contribute patches back to Python. And as I was involved in both the Python community and the IronPython community, I got Python commit rights, particularly to work on the standard library and to make fixes to make the Python standard library compatible with IronPython. So that was how I got into becoming a Python core developer. But because of my, I picked up a passion for testing with Resolver Systems, I'm still convinced that good testing, rigorous testing practices are essential for product and code quality, and also for developer sanity. So if you feel like your job is driving you mad, well, testing may be part of the answer. Good testing practices. And so that was how I got involved in unit test maintenance. Along the way, I released Unit Test 2, which is a backport of the features that we added to unit test in Python 2.7. That's been bundled with Django, which was very nice. I wrote the mock library that came out of some of the testing practices in Resolver Systems. And then fast forward, and now I'm working for Canonical. So that's a brief history of how I got involved in Python. There's some interesting things to take away from that, I think. The first being that certainly my experience, and not just my experience, but the experience of many other people that I've met from the Python community, is that being able to demonstrate the quality of your work and your ability to work with other people through your open source contributions, and through having effectively a portfolio of work that you've done, patches that have been accepted into other projects, projects that you've released as open source, is far more important than any qualifications that you may or may not get. And so if you're coming to Python, coming to programming, looking for work, the best way you can demonstrate to potential employers that you're someone who can work with other people, that can employ good development practices, and that you're a good coder, is through your contributions to open source work. And the other thing is about becoming a Python core developer. The first thing to say, I guess, is that it doesn't mean as much as you might think. Python is just another open source project like any other. So and it needs developers, it needs people to work on it. So we want volunteers, we want people to become core developers. It's not some exclusive club. And if you can demonstrate through working on the issue tracker, submitting patches, being responsive to changes, learning the development practices around how we do bug fixes, when it's acceptable to backport a bug fix to earlier versions of Python, and when something is a new feature really needs to go in newer versions of Python. If you can learn those practices, if you can work with us on the issue tracker and on IRC, then getting commit rights is really much easier than you think. And the other thing is that it doesn't require you to know C. I got commit rights to core Python, not through my amazing C abilities, which I don't have, but through working on the Python standard library, just in Python, and there's plenty to do. So I would recommend, if you're interested in contributing to Python, Kushal Das is a great person to talk to. He's very enthusiastic about getting people contributing to upstream. Okay, moving forwards, I'm now working for Canonical on a project called Juju, and it's slightly interesting to be here talking to a Python audience at a PyCon, as I'm no longer a Python programmer, or at least not professionally. I'm still involved with Python core development, obviously, but the project I work on, Juju, is written in a language called Go. Who has heard of Go? So easily half of you, maybe even more. Who's used Go? Quite a few of you. And who's actively developing something or working on something in Go? A few hands, a few hands. So even in this is a young language released by Google 3 years ago, I think, maybe even more recently. But you can see that Go is gaining mindshare very, very quickly. It's at least slightly ironic, given that one of my real passions for code quality is for testing. It's like, the irony being that Go is such a horrible language to test. Now that's partly because the tools are immature, so the tooling around testing is they're just not very good. But it's also the standard problems that you have testing a statically typed language. You wrestle with the compiler, mocking things is hard. Go interfaces help to quite a degree there. But if we compare and contrast Python a little bit with Go here, there's a lot to dislike about Go, not just the difficulty of testing it. Most of the problems come, as I said, Go is a young language. It's a very small language. They're being very conservative about adding features, which is very good. They're much more focused on performance and the runtime and making sure that what they add to the language really sort of suits the Go way of doing things. So some of these things may be addressed, but not necessarily very quickly. And one of the big things that hurts programming in Go is the lack of generics. What this means is you can't write a container that works with any kind of object, or if you do, you have to cast to an interface which is like Go's equivalent of objects, cast to an interface on the way in, and then cast on the way back out again. So you have to subvert the type system to do it. You can't work with the type system. You can't write a function that will take any type of parameter. So for example, you can't write a generic sort function. You write an int sort, a string sort, and so on. There's no operator overloading, so you can't write custom numeric types. You can't write custom containers that behave like the built-in slice or the built-in map. There's no method overloading, no optional parameters, and no keyword parameters. So if you want to write an API that's slightly flexible, in Python you would do that with adding, say, Boolean flags or extra parameters, but they would have a default value that you would make it optional to pass those in. Now it's something that's easy to use, but it's a useful way of creating a flexible API. What you do in Go is you either have these extra parameters, and then every caller of your function has to pass them in. So your code is littered with calls like sum function, parameter, true, false, true. And you have no idea what these additional parameters are doing. You can't even pass them in by keyword to make it clearer. Or alternatively, you write a separate function. You have to come up with different names, and your users have to remember all these names for every sort of permutation of the API. So if you have 3 optional parameters, that's 8 different functions you have to write. So all in all, this tends to make Go a more verbose language. You end up writing more code than you would with Python. And some of the problems with Go are definitely not going to be fixed in the future. They're kind of ideological positions from Rob Pike and the guys who are creating Go and the Go community itself. And the one that I think, and I hope none of my colleagues watch this because I'll be in trouble for saying it, but the thing about Go that is really just insane is that there are no exceptions. So every function typically returns a result and an error object. And then about a quarter of your code is then, if error not equal to nil, return nil comma error. And you're returning the error all the way back up the stack, and you're losing the stack trace in the process. So every large project then implements their own errors package. You can go out and see Facebook, who are using Google, have released one. We've got one. There are quite a few of them out there that allow you to wrap error objects and try and put back in some of this functionality that the language doesn't provide. But obviously, it's not all Go is not all terrible. Otherwise, nobody would use it. And there are a few places where Go really shines. And one of those comes because Go is a small language. It's extremely easy to learn. So now Juju that I've been working on, it's a huge project. I'm still very much learning Juju, learning the code base, learning the way we do things. But I felt comfortable reading Go and writing Go within my first week, and that really surprised me. I expect the on-ramp, the learning process to take longer than that. But really within the first week, I was comfortable with significant proportion of the language. That really surprised me, and I've certainly been enjoying doing new things despite my reservations about the Go language. Another place where Go shines, because it's a young community, there's this tool called Go Format, or Go Fmut, as you spell it, and that reformats your code with the indentation and the curly braces in the Go way. So there's no community arguments about how code should be formatted. Everyone just does it the Go Fmut way. And in fact, most people have set up to run this tool on their code on save in the editor. So you just bang out your code, you save it, and it gets reformatted the right way. And that's nice because the code is consistent. Everyone's code looks the same. So there's something less that you have to mentally adjust for as you read other people's code, and it just reduces those pointless, stupid flame wars about code formatting. But the real place where Go shines is for concurrency. And the basic model for concurrency is asynchronous Go routines with channels for communication. You call Go and then some function call, including just an inline anonymous function if you want, and that's run off on a separate Go routine, and you pass in channels for communication between Go routines or between your main program and the Go routine. That's a very powerful combination, and it's very easy to understand, very easy to read. And even better, the Go runtime can use all the cores on your CPU. You can happily saturate all of them at the same time. And this is something that Python can't do because of the global interpreter lock. And if you ask many projects why did they chose Go, the concurrency story is often a big part of the reason why Go is used. The Go runtime itself is capable enough that you can have easily tens of thousands of these Go routines in process at the same time. And that's something we make heavy use of in Juju, and it's why Go is a good fit for our project. There are no threads in sight. Obviously the threads are there, but they're under the hood with the scheduler, and this is the CSP model of concurrency, and it's a good paradigm to use for concurrency. Another place where Go shines is performance. So we say that Python is fast enough, and generally that's true, but Go is faster enough. And nobody objects to their code running faster. So you can see that the Go programming language, it's gaining mindshare. We are seeing some projects and some developers migrate away from Python to Go. That's not really something to be particularly worried about. Python these days is absolutely massive. Back when I started Python, way back in the dim and distant past, it was kind of this small language, had this small band of enthusiastic devotees, being used mainly for scripting, for automation. Some people were using it for web programming with this crazy thing called Zope. But it wasn't a very big language. But two things have really happened since then that have sort of exploded the usage of Python. And the first of that is just that computers have got faster. So the fact that Python is a dynamic language, and so it does a lot more work so that you don't have to, that matters a lot less than it used to. And this is one of the reasons why I'm not particularly worried about Python on mobile. The Python on mobile story is not very good. Not many people are using Python on mobile devices. And one of the reasons is they say Python is just too slow. But if you look at the performance of mobile devices, that's rocketing. So that particular argument will just fade, I think. But Python is used everywhere now. The second thing that happened was the web revolution. The use of computers really exploded, and the need for people to be able to develop rapidly became much more important than the need to be able to for the programs to run at sort of supercomputer speeds. And program, of course, is famous for developer productivity. But still, if we look at the future, there are these couple of places where Python is not at the forefront, and concurrency is one of them. That's not something that's looking like it will change in the very immediate future. And also, I mentioned Python on mobile. 6 times as many smartphones sold last year as PCs. The majority of computing devices already perhaps are non-traditional computers, ones that you carry in your pocket. So if you are concerned, or if in 10 years, 20 years' time you still want to be programming in Python, and you're thinking, well, as a community, what can we do? As an individual, what can I do to help ensure that happens? Obviously, supporting organizations like the PSF, the Python Software Foundation, and the PSSI, who are looking to help maintain and develop the community, help move Python forward. That's something that you can do. Get involved with projects like Kivy, that's Python on mobile devices. It is out there. It is possible to write apps for Android and iOS and get them into the various app stores using Python, but they need more users, they need feedback, and so on. So use Kivy, use Python 3, which is obviously the future of Python. And for Python concurrency, you can donate to Armin Rigo's work on software transactional memory in PyPy, which is one way that Python will be able to make use of multiple multi-core devices. So those are a few things you can do. But anyway, enough about Go. So the substance of my talk today is called To the Clouds. And so because we're talking about the clouds, you can expect a lot of buzzwords, a lot of jargon. But one of the things I'm hoping to do is rehabilitate the term the cloud. It's the most overhyped buzzword in software engineering of the last few years. And anyone here sick of hearing about the cloud? I'm very sorry. You're going to hear some more about it. But what I'm hoping to do is demonstrate how deploying software, services, applications, your scientific computing clusters, how deploying them to the cloud using the cloud model, how there's genuinely an interesting technology there, and why you should be doing it even if you don't want to. So we'll start this part of the talk with what I call my brief, potted, and mostly wrong history of the cloud. The picture here on the screen, this is one of the original servers used by Google from their early days. And at the time, they made the what was considered radical decision that they would build their system, so their cluster of servers, rather than on big iron mainframe servers or big servers, they would build it on cheap commodity hardware. And to cope with the fact that the individual machines were unreliable, or certainly less reliable than the servers being used by their competitors, they would build this fault-tolerant architecture that could cope with individual machines failing. They could take machines out, and the system would still keep running. But even more importantly, they could quickly and cheaply scale up, add new servers, and they could scale up much more rapidly and much more cheaply, much more cost-effectively than their competitors. And this, along, of course, with their search algorithm, was a big part of their early success. And eventually they released this platform as what we now call a platform as a service, as App Engine. Amazon took this to the next level with the infrastructure that they built to run their huge retail website. And they took a slightly different approach with their cluster of servers providing virtual machines as deployment targets, what we now call infrastructure as a service. Now, developers and DevOps tend to love this approach because the paradigm that it provides to you is just that you have a machine and we know what to do with machines. We're already deploying software to machines. So with IaaS, we can just do what we're doing, but do it in the cloud. And when Amazon made this available publicly, they became the dominant player in the cloud market. Other IaaS public clouds include Microsoft Azure, HP Cloud, and a whole host of clouds that are built on top of OpenStack, like Rackspace, for example. So some of the problems that deploying to the cloud solves, and then three that I'm going to particularly look at briefly here are resource underutilization and overutilization, dependency hell, and hardware management. Now the core way that the cloud solves these problems is by separating your deployment layer from your physical hardware. So when you deploy to the clouds, you deploy to these virtual machines, and you don't care which physical machine it's going to run on. And we'll look at the consequences of this as we go. So the first one, resource underutilization or overutilization, perhaps a situation you might be familiar with. You want to deploy a new public-facing website, public-facing service, or perhaps even internally you have some tools, Dev Wiki or Dev Issue Tracker that you want to deploy. And so you need a server. So you buy a server and you run the software on it, and you're using about 10% of its resources. Or alternatively, you work for a company where the processes around getting new hardware commissioned and put into the network are so slow and cumbersome. I've actually worked at a company where it took a month to get new hardware commissioned and put in. It wasn't just the slow processes around permissions, it was the whole sort of system administration of getting a new machine commissioned, getting it built into the network. It took a month to do that. It was horrible. And so the simple answer is just stick everything on the machines we've got, and everything starts running slower and slower. Well, with the cloud, first of all, if you're running on a public cloud, don't need any hardware at all, so that solves that problem. We can easily just get more virtual machines. But even not using a public cloud, we can fully utilize the resources of the machines we have by putting more virtual machines on them. And if we need more capacity, we can just add more machines to the cluster and let the cloud infrastructure take care of a lot of the administration processes. Much more straightforward. So dependency hell, perhaps even more painful. I don't know if you've ever been in this situation where you have two different applications that you're running, and they both use the same Python library, but they're both using slightly different versions of the Python library. One's an older application. You haven't ported it to the latest and greatest version. And what that means is you've got two applications, and they can't both be deployed on the same machine. You have to keep them separate. Or perhaps you make sure that both of your software, both of your applications or services, they're both running the same version, and then any time you want to upgrade version, you have to do everything in lockstep, upgrade everything together at the same time. Leading to situations sometimes where you're working on the new release of your software, you take advantage of some new feature in a library you're using, you've upgraded the version, you've fixed all the cases where deprecated functions that you were still using because you hadn't switched the warnings on and they've now been removed. You've fixed all of those places, you have your software ready to go, you deploy it, and you've forgotten that something else on the same machine is using the same library. You break it, and emergency rollback, get everything fixed again. Undo the database migrations. You are using migrations, aren't you? Otherwise, you've got to manually fix your database. I've actually been in the situation where we've deployed something, forgotten about something else, using the same dependency, and had to do an emergency rollback. Now, one way around solving that problem is to use virtualenv to provide isolated environments for each of your pieces of software. That works fine. But what you've just done is given yourself a security problem, because when there's some security vulnerability, perhaps it's in Django, you've now got on your server, you've got several copies of your library that all need to be upgraded urgently, and they're all in non-standard locations on the file system as well. So system administrators tend not to like that feature, and you can't use the support of the packaging system of your OS to do the upgrades for you. Another way of solving the problem of dependency hell is to have an isolated deployment environment for every application or service that you run, through having them all running on separate virtual machines. And finally, the last problem that the cloud solves, which we've already alluded to a great deal, hardware management. Where you're using the cloud technology, you can, if you have a machine that fails, or you need to take it out of the cluster, you want to upgrade it, you can do that without having to take down running services. And where we're over capacity, adding new capacity, adding extra capacity with new machines is a lot easier. This is dynamic server management. Now, of course, if you're already running and managing your own servers, you probably don't want to take your data and put it on the cloud and throw away the machines, fire all your system administrators. They're not going to be very happy about that. And it may be a more expensive and less secure solution for you. So instead, we can still take advantage of these benefits of the cloud. Which reminds me, something I forgot to mention, a big benefit of the cloud, not just the problems that we leave behind, but something that we get if alongside using the cloud, we have automated deployments, then we get the easy rollout, the easy deployment of new applications and services, and we get the ability to quickly scale out existing services. Again, I don't know what the processes are like where you work. How quickly can you deploy a new application? What are the processes you have to go through? How easy is it to scale out your existing services? This is something that the cloud gives us. But in order to take advantage of these benefits, we need to have automated deployment processes. So even if you're just running a few servers and a few services, we can still take advantage, we can still get these benefits that we get from the cloud by using a private cloud. We don't have to hand the keys of the kingdom over to some third-party cloud provider. And these days, if you're using a private cloud, that probably means OpenStack. Now, I know I'll be in trouble with Kushal if at this point I don't mention that there are alternative cloud technologies like Eucalyptus, for example, which Kushal is a fan of. But also there's other interesting technologies like Metal as a Service, which is another product from Canonical. And that provides you the dynamic server management advantages of the cloud, but working directly with bare metal servers. And that's a very interesting data center technology. Certainly worth looking at if you're managing a large amount of servers. You have your own systems, your own frameworks. You don't want to run something like OpenStack, or you can run OpenStack on top of Mars very easily, but you need to manage your bare metal. But certainly OpenStack is the leading private cloud framework, and it's all written in Python. And this is great news for us as Python developers, because what it means is there are a whole host of companies out there who want to pay you to work on OpenStack or with OpenStack. OpenStack is absolutely huge, massive in terms of lines of code, number of sub-projects, number of people using it, and the amount of functionality it provides. In my opinion, one of the biggest things happening in the Python world right now. So I mentioned that it's very important, if we're to get the full benefit of the cloud, that we have automated deployments. Now, an important principle for this is that we treat our servers like livestock and not like pets. What I mean by this is pets, they're unique. They have names. Anyone work at a place where you give each of your servers different names? I do, a few of you. Bad, stop doing it. Pets, they're unique, they're lovingly cared for, hand-reared, and when they get sick, where you spend a lot of money and time and effort to get them well again. Because if it dies, replacing it is going to be a real pain. You're going to have to find one that looks the same and lie to the kids about it. Livestock doesn't have names, they have numbers, and if they get sick, well, you probably take them out and shoot them and get another one. This is how we should treat our servers. We ought to be able to tear down our application servers with a single command. We ought to be able to provision our application servers with a single command. We ought to be able to scale out, add new units of our services with single commands, not having to care about all the intricate details of machine configuration and machine administration that only one person knows about, or even worse, that over the last 10 years, 4 people have worked on the configuration of this machine, and if it dies, we better hope the backup works. There's no person who knows how to put this thing back together so that everything runs. That's a terrible situation to be in. It makes scaling out, adding new services really difficult, and it makes it much harder to deploy new services. And this is where I refer to my notes. Okay, so I remember. So the reason DevOps and developers love the infrastructure as a server paradigm is that it just provides the you have a machine to deploy to model. So we get to leave a whole bunch of problems behind, but one of the problems we take with us is we still have to provision, administer, configure the machines in the cloud. And there are a whole host of tools that will help you do that will help you automate doing that, but it still means you have to do it. Some of those tools you're probably mostly familiar with, Chef, Puppet, Salt, Ansible. It's quite a common problem, quite a lot of people trying to solve it. And even Docker, which is the latest and greatest, the latest hot new thing. Really, that's about image-based workflows, but in as much as people are using Docker images as deployment targets, it's about machine provisioning. Let me show you a yet still more excellent way. As developers and as even as DevOps teams, we really don't want to think in terms of machine configuration and administration, or at least I don't want to. What I want to think about is the services I'm deploying and how they're related. My application needs a web server, it needs a load balancer and cache, it needs a message queue, a database, and those are all related. That's what I want to think about, the key parts of my infrastructure and how they're related, not individually what dependencies, what ports need to be open, firewall rules, all of these kinds of things. Those are details which ideally some tool would take care of for me. And this is something we call service orchestration. Canonical is something we've been talking about for a few years and that is kind of picking up in the industry. That what we want to do is orchestrate our services, think in terms of our services, not think in terms of machine provisioning and administration. This on the screen here, this is a view from the Juju GUI. Not necessarily something you'd use in production. You'd use the command line scripts and configuration that you can keep in version control. But it shows deployed services and how they're related. And even for production, it's a great way of seeing the health of your running systems. So some of the key advantages that Juju as an automated service deployment tool, and not just deployment, it manages the life cycles of your services. Some of the key benefits that Juju provides. We've mentioned service orchestration. Cloud independence is an important one. It works with Amazon EC2, Microsoft Azure, HP Cloud, Joyent, OpenStack, Metal as a service, and also LXC and KVM containers for local testing. That's great because you can take exactly the same configuration, exactly the same system that your production deployment, your prod stack uses, deploy it locally, check that everything still works, make changes, redeploy, destroy your environment, recreate it, check it still works. Even better, on your continuous integration server, you do have a continuous integration server, don't you? Running a barrage of automated tests against a system provisioned in exactly the same way as your production stack. Who does have that? Ooh. Now, some of you maybe are researchers and students, so you have excuses. For everyone else, the basic rule is if it's not tested, it doesn't work. You may not know why or how it doesn't work, but believe me, it doesn't work. If it's tested, it might work. But if it's not tested, it definitely doesn't. Even worse, you have people going through manual tests by hand. And that's terrible, and the basic reason is because people suck. They're bad at doing repetitive things. And computers, they love doing repetitive things. That's what they're there for. So if it can be automated, automate it. So LXC containers are a great tool for this. Again, another show of hands. Who's heard of and used LXC containers? So some of you. LXC containers are lightweight Linux containers. They can share the kernel of the running system, so you get native performance, but it's an isolated container, just like a virtual machine. So they're great for things like this, for local testing, for deploying as deployment targets for your continuous integration. They're also great for developing. If you're setting up a development environment is complex, requires installing a bunch of dependencies, maybe adding private PPAs, private repositories. Doing that on your system is a pain because you get it wrong, you screwed up your system, you have to reinstall everything. Instead, create an LXC container, LXC-create. It's slow the first time because it downloads the image, and then after that, creating a new LXC container, very lightweight. LXC start, SSH into it, and then you're just SSH'd into your Linux environment. Installing your development requirements there. You can either share the home drive or bind mount into it, and then you do your work inside the LXC container, and if you screw that up, blow it away and create another one. Very lightweight, very easy to do. Fantastic tool, well worth exploring, even if you're not interested in any of this, which of course you all are, I know. Okay, and certainly as Python programmers, one of the big advantages of Juju, Juju knows how to deploy services and applications through things called charms. And those charms, you can write them in any language, but the best language to write them in, and the language used for most of them, is Python. So you get to codify your deployment infrastructure in Python code. And that's the heart of DevOps, isn't it? We don't manually maintain our systems, we don't manually cowboy in changes that then no one can quite remember. We keep everything as scripts and configuration files that are completely automated that we can hand off to somebody else. This is DevOps, and with Juju you get to do it with Python. I think with some of the other popular deployment tools you get to do it with Ruby, and I assume that most of you are here because you like Python. And one of the best things is that for the key parts of your infrastructure that probably most of you are using some of, there's a whole host of charms already written. There's a community around. Ooh. So this is the pastebin application. It's running on my local system. The URL, which you probably can't see there, is a 10.0.3 URL, which is the IP address. That's a cloud IP address, but it's actually running in an LXC container. So just to demonstrate, if I run Juju status, it spits out a load of information about the running services on the system, and that IP address, if I look at we'll just scroll past, probably scroll past the Apache IP address. That's the public address of the 10.0.3.131. That's served by Apache, running through this this pipeline of services. It's not just a charm that's been deployed; it's a bundle. This is jujucharms.com, which is the charm store. If you search for dpaste there, you can find this bundle of services. Developed by my colleague Simon Davey. The charm store, this is actually a fake Juju GUI, so you can do a test deploy to the charm store just to see how the services look, configure units, and so on. But I've also, it doesn't actually do a deploy, I've actually installed the Juju GUI into my local Juju, so I can get a view of the running services. I'm not going to attempt to do the full deploy here now, partly because it takes time, but also because it's network heavy as it fetches the dependencies and so on, and I don't want to tempt the demo gods too much by relying on the network here. But what we've got in this bundle of services, we've got Apache, that's doing HTTPS termination. This is just the standard charm. We've then got HA proxy running in, working as a load balancer. This is configured to send the same URL to the next thing in the pipeline is Squid working as a cache, and HA proxy here is configured to send the same URL to the same unit of the cache. Obviously a cache only works if the unit that has that URL cached actually gets the request. Then the next thing in the pipeline is HA proxy doing standard unicorn, which I never know how to pronounce properly, so I'll just say it confidently and you'll all assume I'm saying it correctly. Unicorn is the whiskey runner for our dpaste app. We could have built that into the unicorn charm. It needs to run on the same unit as dpaste. But somebody else has already done the work of writing a unit using constraints of the CPU power, the CPU memory I want it to create. If this was going to Amazon, that would then create new virtual machine instances using the constraints we provided. And if I want to scale up dpaste and add new units, I can do it here. This would be the same as from the command line, juju, add units, dpaste, and then tell it to add 5 new units. So we can just scale out. I might actually try that and see what happens. This has been running locally on my system for several days now, so quite what the state it's in is anyone's guess. Scale out with these constraints, default CPU cores, 1 gig of memory each, which will be interesting as there's only 3 gig on this system anyway. So let's have a look. That's going. So that's now doing so you can see the bar has changed to yellow because only 1/5 of the units are actually up and running. And the other ones, they're now in the process. This is going to fail actually. It's going to fail because I have Wi-Fi turned off so I don't get any silly notifications. So provisioning those machines locally is going to fail. But the interesting thing is, because the charm defines a bunch of hooks that are run when things happen. And then a charm provides interfaces. The Postgres charm provides a Postgres interface, and the dpaste charm says, I know how to talk to a Postgres interface. So when we add a relationship, the charm hook runs. There's some Python code that runs, and it's told by Juju, the live Juju state server. It says, this relationship has now been joined. Postgres puts into the Juju configuration, it creates a username and password, so no need to hard code those in configuration if you don't want to. The Postgres charm can create those, put those into the configuration for the application. The application is told you've now the configuration has changed. You've now joined a relationship, and it can get that information from Juju. And so the dpaste charm runs, does the setup to provide the database connection, and the Postgres. The charm runs to make that information available. So this is service orchestration. The great thing is when we, because we've established this relationship here, as we scale out and add new units, Juju knows that, well, there's a relationship between dpaste and Postgres. So as I add new units, I need to add that relationship as well. If we added more Postgres units, the charm is clever enough that knows, right, now I'm running in replication mode, and there's some reconfiguration to happen. So when we're, with these charms properly in place, as we're defining our services, we don't need to think in terms of how to configure and set these up. That's the job of the charm, and it manages not just the configuration of the individual service, but it manages these relationships too. If I now, for pending units, we've got a little triangle telling us that something is wrong. And this is because it can't provision these machines. Something that, in fact, I didn't mention that is important from the point of view of cloud independence. Because the deployment target is separate from the description of your bundle of services, if you're a young startup, you're deploying to Amazon, then you get onto Reddit and Hacker News, and you're scaling up, it's getting more expensive. Your customers realize their information is on American servers, and they really don't want that. So you want to move to deploying to OpenStack, or deploying to your own servers. You put OpenStack on them, you just retarget your deployment, and exactly the same deployment and configuration, just run it against OpenStack, export your data, re-import it, and there you've you've moved over, nice and easy. So I only have a few minutes left. I keep mentioning these charms. Charms is just a directory structure on disk. We can fetch them from the charm store if it's an existing one. We can pass in some YAML configuration if it's a charm that needs configured. That we will keep under version control, obviously. But we can also have them locally. If for your own application, you will probably take an existing charm and fork that and configure that, set that up specifically for your application. That blue you really can't read, I'm sorry about that. This is the output of tree, or part of the output of a charm. We have a bunch of metadata in YAML files, and the hooks that I mentioned that are run when configuration changes, on install, when a relationship is joined or left. Here they're all symlinks to the same hooks.py file, and then we've got a charm helpers package that's bundled in the charm. Here's some of the Python code. This is the install hook, and surprise, surprise, that's installing a bunch of stuff. I mentioned that the services that you saw were from a bundle of services, and this is the configuration file used by the Juju deployer to deploy those. This is the first part of the YAML, the deploy YAML bundle. The configuration for the dpaste app. This is actually fetching, this is the Django framework charm. It's actually fetching the dpaste app from GitHub when you deploy it. So this is something you will probably not, well, it's likely that that's not how you will want to deploy in production. And then the other services and some of the configuration options for them. Just a text file. So actually getting Juju up and running, once you've got it installed, although the Juju deploys Ubuntu workloads, we're actively working on getting it deploying CentOS workloads and Windows workloads. We have a working prototype of deploying to Windows. So if you're in the unfortunate position of having to maintain a Windows network, Juju deploys SharePoint, Juju deploy SQL Server. Juju, but there are clients, even though it's for deploying Ubuntu workloads at the moment, there are clients for Windows and for the Mac. So we can deploy to OpenStack, but from Windows, from a Mac computer, if that's what you need to do. So once Juju is installed, we generate a config file. Then we do Juju switch local here. That tells Juju that we want to deploy locally. If I was deploying to OpenStack, I would source my .novarc, the standard OpenStack file that puts my credentials into the environment. Juju can just read those from the environment. So I'd just do Juju switch OpenStack. You can modify environments.yaml, define new environments, but there's no need to mess with it for the standard cases. Similarly, with Amazon, there's a couple of environment variables I can put in place to make my credentials available. And then Juju Bootstrap, and this creates the running state server that's going to manage the life cycle of the services using the provider API, so talking to Amazon, talking to Azure, when it creates virtual machines, making sure that only the required ports are open, when we upgrade the charm, managing that, and again, having this running state server that manages your services and knows what state they're in, checks they're still running and alive. This is a key difference between Juju and other automated deployment tools. And having done that, we can then call Juju status, and it will tell us what the state of our local Juju is. And there's the basic command, deploying something from the charm store, Juju deploy, Juju GUI. And then for deploying our whole bundle of services, I run Juju deployer on this configuration bundle. So that's a very whirlwind tour of Juju itself. Hopefully, I've demonstrated to you why the cloud is an interesting technology, how it's useful, even if you're managing your own servers and services. Thank you very much. Do we have any time for questions?
Thank you, Michael. We have time for 3 quick questions.
If you compare Juju with Chef, then what is it what are charms analogically similar to? Cookbooks or recipes?
I'm really sorry. Could you repeat the question?
If you compare Juju with Chef, then what are the charms similar to? Are they like cookbooks, or they are like standalone recipes which then can be combined together?
So how do the charms compare to Chef, and the hooks, are they standalone, and can you compare them?
As in, if at all you want to deploy say PostgreSQL or MySQL, then you have standalone recipes for them, standalone charms from them, right?
Right. Yeah.
So can charms combine with each other and form like a logical umbrella of this?
So do you mean, can I deploy different services to the same virtual machine?
Can you logically combine different charms into a single charm?
Well, you can, yes. You can simply have the charm do both.
Okay.
You would then create a new charm. But really, there's not a great deal of advantage to that, because you're then maintaining your own charm that does a lot more work than it needs to. And you lose this advantage of separate, isolated deployment environments. It's much easier just to use the 2 existing charms separately. If you want, if the root cause, so certainly you can combine them. If what you really want to do is to deploy services onto the same virtual machine, just to use less virtual machines, have denser deployments. One thing we're working on is allowing the use of LXC containers within virtual machines. We already have that for Metal as a service, so we achieve a higher density, full resource utilization by deploying 2 LXC on Mars. We're working on having the problem with having containers inside Amazon instances and Azure instances is container addressability, and we're working on the network model for that. But that's one way we'll solve the problem. But you can already say Juju deploy Juju GUI --2 machine 0 and have it installed on the same machine as the state server. So logically they're separate units, but they're combined, they're running on the same machine. So if that's what you're after, we can get it that way. Combining charms could also be done. As I mentioned with the dpaste, we have a separate Unicorn charm, which is a subordinate charm. A subordinate charm always runs on the same machine. That's one way of kind of combining charms. And we've done it that way rather than building the Unicorn runner into dpaste.
Yeah, so is Juju like a counterpart of, let's say, Red Hat's OpenShift origin or something like? Because
how does it compare to OpenShift?
Yeah.
So Red Hat OpenShift is a platform as a service, more competing with Heroku than the likes of Amazon and Azure. And OpenShift is a hosting technology rather than a deployment tech. Maybe it combines both. I'm not really very familiar with OpenShift. But something that's interesting in recent years is I think infrastructure as a service has largely beaten platform as a service in the market. There are a few big players. Heroku, Salesforce is huge in platform as a service, but maybe that's really software as a service. But Heroku may be huge, but if you look at how do they compare in size to Amazon, really their infrastructure as a service is much bigger. It seems to have beaten out platform as a service. And I think that's because, if you're targeting a specific platform, you're really locked into that. Whereas with infrastructure as a service, you're able to move provider much more easily, particularly if you're using a tool like Juju rather than directly hard coding your calls to the Amazon API. If you're working directly with the Amazon API, you're tied into Amazon. If you're using a deployment tool like Juju or some of the other tools that knows how to deploy to any of these IaaS, you're much less tied in. That's harder to achieve with platform as a service.
Hi. Sometimes back I used one of the tool that you created, RST to web. So I just curious to know what motivated, inspired you to create that static site generator?
I'm really sorry. Can you?
RST to web. I just so nowadays there are so many static site generators available. So what inspired or motivated you to create this static site generator?
Static type languages.
No.
Static site generator.
RST to web. So what he asking that what motivated you to write a static site generator, not really.
Oh, RST to web.
Yeah.
Oh my goodness. So nowadays there are so many static site generators. Why did I write RST to web? Well, the answer is when I wrote RST to web, there weren't so many static type site generators. I wrote this for my own website. 10 years ago. So I was way ahead of the curve. But you probably shouldn't use RST to web. The more modern ones are much better. The only reason I use it is because I'm a bit stuck with it. But there we go. Thank you. Okay, thank you very much.
Thank you, Michael. We now have a tea break. The sessions resume at 10:45. I also request all of you to please fill the feedback forms after the talk is done so that we collect a good sample of feedbacks that we have for all the talks. Thank you so much.
Test.
You will set the volume from there.
Okay. Tes, tes. Tes, tes. 1, 2, 3.
Welcome back, everyone. We have a speaker here, Vajraskai Kok. He will be giving a talk on async IO for dummies. He is a Python contributor and creator of wallpapers. Thank you.
Hello everyone. I'm super excited to be here. So today I'm going to talk about async IO, one of the most popular library models that comes with Python 3.4. Yeah, I know. Yesterday we already had 2 talks that cover the same theme, but now I'm going to focus on the async IO library itself. I am not going to talk about Tornado, Twisted Matrix, Gvan. So I'm going to talk how to program asynchronously, how to deal with many IO requests in a short time with async IO library modules. I just said that this async IO came with Python 3.4, and I know that most people don't use Python 3 in the real world yet. I mean, yesterday I talked to some people when I said, you still get stuck with Python 2? They all laugh at me. So, but bear with me. because the async IO still can be used with Python 2. It just you have to use differently. You don't use the special syntax yield from. I'm going to show you how to do that with Python 2. But before that, I'm going to explain something more important than the technical how-to. It's the fundamental idea behind async IO. And I'm going to explain it in a different way than they did yesterday. So let me convince you that writing is, don't be shy, you can approach me. I'm a friendly person. And I live in Jakarta. I have from Jakarta to come here. So I'm very excited to be here. I work in KMK Online. The company that is responsible for Liputan 6 is one of the biggest news websites in Indonesia. And in my spare time, I'm a regular contributor of Python core. And I found it as a rewarding experience. But I'm not a core developer yet. So I used to contribute to Django, Ruby core, but time has become expensive for me now. And other than that, yeah, I'm a sole developer of wallpapers. It's my first open source project that's built by Pythons, and it used by many people around the world. Basically, it's a wallpapers. It enables you to have different wallpapers for different workspaces on Unix desktops. Back then, like many years ago, I used GNOME, and I kinda envy of KDE desktop that can have different wallpapers for different workspaces. So I try to enable it. I try to enable it on GNOME by writing wallpapers. Okay, so let's get down to business. But first, if you want to contact me, you can use the first email if you want to work with me in Jakarta. Don't worry, it's a nice place. And use the second email for anything if you want to discuss the weather with me. Okay? So, let's talk about the problem which async IO is designed to solve. The problem here is that IO is slow. Okay, I know, everyone knows that. But the thing is, you cannot escape IO. IO is everywhere. As a Python programmers, you would have to deal with IO in one and another way. You may have to download the images from Amazon Bucket. You may have to request data from database. You may have to communicate with another Python process. So IO is everywhere. Unless, of course, if you are the kind of programmers who writes an applications which its purpose is to find the largest prime number under 2 billions, then you may you don't need to care about IO. The thing is, as a Python programmers, you have to deal with many IO requests in a short time. Otherwise, you will you will not get efficient program. So let's we go to the real world applications. So this is like a basic of web crawler. So recently I watched a YouTube video. I watched an advertisement on YouTube about a website that can help you find the cheapest price for flight tickets and hotel rooms. And they definitely use the web crawler. So I mean that people build business by writing web crawler. So here we build something similar. We create an application to get the web pages from 3 news websites, Spiegel, Guardian, and Le Monde. And as you can see here, the line that was highlighted with blue color is an IO blocking functions. It's going to get the web page, and it faithfully does until it gets the web page, or it gets killed by signal or timeout or an exception. And that is the problem. As you can see here, I download the web pages sequentially. So if you're going to build a business by writing this kind of code, you're going to be bankrupt. If you are an employee, you're going to get fired by writing this code. So, but before I'm going to explain you how to deal with this, how to improve this code, let's model this kind of solving problem. So, and we will get this graph. So here, the arrow represents the linear time. So the color boxes represent the time when we get the real data, when we get the real bytes from the server. And so in the blue color boxes represent the time when we get the real data from the Spiegel, and the yellow is for Guardian, and the red is for Le Monde. And the gap within the color boxes represent the time when we sit idly, when we wait for the next chunk of data. So as you can see here, the server doesn't send you the web page in one block data. They send you data chunk by chunk. And between those chunks, you will have to wait. And as you can see here, we have a long gap. And those gaps represent the time we waste. In business, time is money. So when you look at that gap, you can see the gap as a money that you lose. That's why why I said that if you wrote this kind of codes, you're going to lose money. So Async.io can help you to reduce the money that you lose. Okay, so but before we solve that using Async.io, I'm going to explain to you how to solve it with trading. The reason why I am explaining how to solve this problem with trading is because when we compare both approaches, you will understand Async.io better and faster. And there's a time when Async.io falls short and trading can trump. If you attended the talk yesterday about the transfer pipelines in Dreamwork, there's a situation when Async.io cannot help you, such as like listing directories, getting the m-time attributes of the files. So here, when we want to solve the problem of dealing with many I/O requests in a short time, so the common pattern is you create each thread for dealing with for one I/O operations. So here because we have to download the 3 web pages from 3 news websites. We have to download the web pages from 3 news websites. So we have 3 I/O operations. So we create 3 separate threads. So 1 thread for each website. So because this blue color box represents the thread, so we have 4 threads. The upper box represents the main thread. Now, if we model this kind of solving problem, we work this kind of graph. So here, as each I/O operations gets its own dedicated line. So for I/O operations of downloading the web page from Spiegel gets its own dedicated line. So when we get blocked while downloading the web page from Spiegel, while we are waiting the next chunk of data from Spiegel, the other I/O operations can still run. They don't have to wait for us. So as you can see here, while we get blocked for the first time while downloading the next chunk of data from Spiegel, the other threads can still get the data from Guardian and add another thread for Le Monde. And now here, how we are going to solve this problem with Async.io. So in Async.io, you only need 1 thread. So here we have 1 blue box. That is the only thread you need. So here, these coroutines you see are comparable to the threads that you saw just now. So because we have the 3 I/O operations, so the common pattern is to create 3 coroutines. Each coroutine is responsible for downloading the web page from 1 news website. But we have something different here. There's an event loop. So here, the event loop is like an intelligent machine that runs and executes the coroutines. So in async IO code, you don't execute the coroutines directly, just the way you do with threading. But you have to put this coroutine inside the event loop, and you start the event loop. So in this case, you can say that event loop is something like the operating system in the threading case. It's the schedule the task between them and schedule the priority between them. But please don't take that analogy too far, because they are kind of different. So if we model this way of solving the problem, we would get this graph. So here, it's same as naive model. The async IO shared it's all the IO operations share one line. But we have something different here. The color boxes are intertwined to each other. So here, if we get the data the next chunk of data from Spiegel, then we jump to the IO operation of downloading the web page from Guardian. Then we jump to the Spiegel again. Then we jump to Le Monde, jump to the Spiegel, and so on. We do it so to avoid the IO blocking time. So when we sense that for these IO operations, we will get blocks, we switch to another IO operations. That way we can reduce the gap. We will still get the gap between the color boxes in async IO code. It's just that we would have the shorter gaps. It means in business we lose lesser money. So here, if you could only remember one slide from this talk, let this one be. Everything is derived from here. Okay? So let's get down to the technical detail. So the common pattern, if you are dealing with many IO requests with threading, so you create as many threads you need, and you create a function that that inside these functions you are going to execute the IO blocking functions. Then you feed this function to the threads. Then later you start the threads, so on. So the lines that were highlighted with green color is the line where you create the threads, and the lines that was highlighted with blue colors represents the IO blocking functions. Now, technically speaking, print is a IO function, but for now you can ignore it. Now, for this sleep delay, you can see it as a representative of the IO blocking functions that you need in your daily life as a Python programmer. So it means like os.system, or in the previous example, URL lib request and the subprocess popen. Then later you communicate with this popen objects. Anything that you're going to get an IO and going to get an IO request and blocks. This is it. So you put this IO blocking function inside the function, then you feed to the threads. So for the technical details with async IO code, they are kind of different. So here, instead of creating function that is going to execute the IO blocking functions, you're going to create a coroutine. Basically, it's just a function that you decorate with a coroutine decorator, and inside this coroutine, you execute the IO functions with the special syntax yield from. But this yield forms is only valid if you use the async IO with Python 3.3 and Python 3.4. So it is true that Python 3.4 async IO comes with Python 3.4 in the standard library. But if you use Python 3.3, you can download the async IO from third-party provider. But they don't call it the async IO anymore. They call it Tulip. If you use Python 2.7, because the Python 2.7 doesn't support yield from, they change the way you interact with async IO. Later I'll show you it. you can download the async.io from the third-party provider if you use Python 2.7, but they don't call it async.io, they call it troll use. Okay, let's get back to the technical detail. So you're going to execute this IO functions inside the coroutine with the special syntax yield from. Then later these coroutines, you convert it to the task, you wrap it to the task, then later you run the event loop. Remember I said everything is executed inside the event loop. Here the loop object is the event loop. So now if you take notice, there's something different here. Here we use async.io sleep, but in the previous example we use time.sleep. Some of you may ask why we don't execute time.sleep inside the coroutine. Why must we use the async.io.sleep? And so there's two questions. Why do we need to use yield from, and why do we need to use async.io.sleep instead of time.sleep? So I'm going to explain the latter question first. Let's get back to the fundamental idea behind async.io. Remember when I show you this graph? So in async.io code, everything happens in one thread. So it means if you're going to execute a function that is going to block, so everything is going to get blocked. Every other coroutines will get blocked and the event loop will freeze. So that's why you have to avoid the normal IO blocking function when you write the async.io code. So it means when you are going to write async.io code, you cannot use the normal IO blocking function anymore. So it means if you are going to solve the earlier problem, you cannot use the URL lib request URL open to get the web page from the news websites if you are going to solve the problem with async.io code, because it will defeat the purpose of async.io. So you need something different here. Now here we have the async.io compatible functions. This function is going to execute the IO computations and it will not block. So here it will communicate with event loop. When it sense it will get blocked, it will tell the event loop that, hey, I'm going to get blocks. Why don't you switch to your attention to some other coroutine? So for all the IO blocking function that you need in your daily life as Python programmer, async.io library modules already provided the replacements. If it doesn't, most likely is the third party provider already provided it. In the case of AIO-HTTP, this AIO-HTTP is like a comparable to the URL lib request. Now, so the basic idea, if you are going to write async.io code with async.io library modules, you execute these IO functions, whether it's going to get the web page from the server, whether it's get the data from database, whether it's to get the results from the external process inside the coroutine, but you don't use the blocking function anymore. You use the async.io compatible function, and you execute it with the special syntax yield from. Then you get the result, and everything else is the same. So no more blocking function in your async.io code. So when you're going to execute the IO function, ask yourself, is this going to block? If it is yes, find the replacement. Most likely they are already replacements. So if we are going to solve the earlier problem with async.io, here's how we do it. First you get the request object with the special syntax yield from. This response objects is the object which you can inspect the final URL and so on. Then later you get the web page itself by calling yield from response rate. This way, when you download the web page and you get blocked like 5 times, this yield from response rate will tell the event loop to switch the tensions for like 5 times, so it will not get blocked. So it will intertwine to each other, the coroutines. So now I'm going to answer the first questions. Why do we need to use yield from? But let me get back to the story of yield without from and the idea behind generator. So in Python land, there are two kind of functions. The first one is the function of nothing or all. You're going to get all the results or nothing at all. It's either 0 or 1. It's either black or white. There's no gradient. There's no gray color. Either you get the full result or you don't. That's what we call the normal traditional I/O blocking functions. Either you get nothing at all or you get the full web page. But there's another kind of function which is a little bit special. We call it generator. These functions can let you to consume a part of the result. So you don't have to consume all the results. You can consume half of the results and stop it, and you can do other things first, maybe like printing hello world 500 times. Then you can resume the remaining part of the results. So here we can see that special function, we call it generator, that gen. All the results is 1 and 2, but we let the caller to consume a part of it. So we consume the caller of this generator, consume it by calling next, and we get the part of the results 1, and after that we can stop it, or we can do other things first before we resume the other half of result by calling next again. Now, remember when I told you when you write the async IO code, you use the async IO compatible functions. Imagine that async IO compatible functions is defined like this. So you get some data, you get the chunk of data, or you get the 10 kilobytes. Then you give this part of the results to the caller. Then you get the data more, get the part of the result, you send it back. So the caller can do other things between the results, between the full result of this async IO compatible functions. Now, so who is the caller of this async IO compatible functions? It's our coroutines. Technically speaking, the async IO compatible function is a coroutine itself. But for now, we differentiate them to make it easier for you to understand. So inside our coroutines that consume this async IO compatible functions, this async IO compatible function is like async IO sleep. Now we get the part of the results by calling next. But inside this coroutine, we cannot do something useful between the part of the result. I mean, so here, there's nothing I can do. There's nothing useful I can do between the part of the result, between the part of the web page. If I want to get the full web page, so I can continue to do something useful. So inside the coroutines, we want to get the full result. We don't care the part of the results. But while the coroutine doesn't care the part of the results, the event loop needs it. Why does the event loop needs the part of the result? Because the event loop wants to do something useful between the part of the results, between the chunk of data of the web page. What is that something useful? It's to execute another coroutines. So that's why we get this intertwined color boxes. That's the fundamental idea behind why we use the yield from and async IO compatible functions. We don't send the full result. We send the results part by part. So between this part of the results, we can do something else, like executing another coroutines that send the results part by part itself. So, but it doesn't answer why we must use yield from, because right now we just use yield. Now to understand why we use yield from instead of yield, you can see here this in the coroutines, we get this kind of boilerplate. So it's kind of wasteful of space inside our coroutine. So the non-blocking functions send the part of the results in our coroutine. We pass it back to the event loop, and the event loop may want to execute another coroutines, and that coroutines will consume another async IO compatible function. That async IO compatible function will send a part of the result of it. We have too much bureaucracy here. Our coroutines becomes obstacle of efficiency. So instead of becoming a middleman, why don't we let the non-blocking function communicate directly to the event loop? So here, that's why we use yield from. So I don't care about the part of the results. Why don't you communicate directly to the event loop? Once you get the full results, then tell me. Now, so if we will get this graph, if we use the yield from, so no more middleman, the non-blocking function can communicate directly to the event loop. Then event loop will do something useful between the part of the result. Now, here's the thing. There's a time when asynchronous code cannot be, there's a time when synchronous code cannot be made asynchronous. There is a time when async IO cannot help you. You may have IO blocking functions that doesn't have the async IO compatible version of it. In that case, you may execute it in the separate thread. So async IO modules provides you a convenient function to execute this IO blocking function. So it will not freeze the event loop. So here we use the IO blocking function, the URL lib request, URL open, and the request objects, and later we yield from the object. Then you can do something useful. So now I'm going to show you the final code of the downloader. So here, now you can see it right in the back. Okay, so in the threading, for each news websites, you're going to create a separate thread. Then later you feed this function to the thread. Inside these functions, you're going to execute the traditional IO blocking function, and it will get blocked. But it's okay because it gets blocked in the thread, and that's not our concern anymore. That's operating system concern. So here we start the thread. Then later we wait for them to finish. Now for the async IO, you get this coroutine. Inside this coroutine, you execute the IO functions. This is kind of special. This is like it will send the results part by part. But we don't care. We just want to get the full results. So that's why we use yield from. We tell the AIO HTTP request to send the part of the results to the event loop. Then once you get the full results, you go down one line. Here we need to get the full result before we can assign it to the body. But the response rate will send the results part by part. But we don't care inside the coroutines, so we use yield from to tell the response rate. Why don't you communicate with the event loop directly? After we get the full result, then we can do something interesting with body. Something interesting such as printing to the SD out. Then you get the event loop object. This is the event. This is the intelligent machine that I'm talking about. It's the one that's going to execute the coroutines. But before the coroutines gets executed, we need to convert it to the task. So here we convert it to the task, this coroutine. Once we got the task, we run the event loop to tell this event loop to execute this task. This async IO wait is something like thread join. You want to wait the task to be finished, then you close the event loop. So if we now, this is the client type of async IO code. It's like a web crawler. It's kind of interesting, but I'm going to explain to you how to write the server type of code using async IO. But first, why don't we run it? You know, because I saw a talk yesterday. They execute the code online. So here. So here, if we run it, oh, I don't have the internet connection. Never mind, we just continue to the server. Here, imagine that you have a process. Here we just printing the Mahatma Gandhi's quote to the STD out, and we will simulate the IO blocking time with the sleep 3 seconds. So we are going to write the caching server that will get the result of the Mahatma Gandhi's quote program. So there's nothing special here. It's just going to print Mahatma Gandhi's quote randomly after 3 seconds to the STD out. And so if we're going to solve this problem with threading, this is how we do it. So I'm going to create the Unix server with the Unix file socket. So I create the Unix servers that you create it as a subclass of the threading mixin and the socket Unix stream server. Then you tell this class we are going to use this file, and there's a proxy server. In this proxy server, you can imagine it's like a protocol. So this is our IO blocking functions, the traditional IO blocking functions, which will get blocked if you execute it. So here, this is the handle. Every client is going to get executed inside here. So this is the IO blocking functions. Then you send the result. Now, let's simulate the server. This many clients is just to simulate like a simultaneous clients, simultaneous access to the server. So there's like 4 clients that's going to access the server. They want to get the Mahatma Gandhi's quote. Okay, so with threading, we can solve this problem. We don't need 12 seconds to get the whole Mahatma Gandhi's quotes. We only need like 3 or 4 seconds. That's because the IO blocking functions, this IO blocking function, this one gets executed inside a trap, inside the separate traps. So it's okay to execute the traditional IO blocking function inside trap. So that's the idea behind solving many IO requests in a short time with threading. So let's take a look at how we handle this with async IO, and we will get something like this. First, you get the event loop. Then the event loop has like a convenient methods of creating many kind of servers that you're going to need. For example, like a Unix server, TCP server, datagram server. So other than the necessary details that the server needs, such as like the file that you're going to use as socket, we are going to send like a protocol. This is the protocol. It's defined how you are going to have a connection with the client. So here we have this connection method. It will get executed when there's a new connection from client. And here we have this coroutine. This is we use the yield from. We just execute this async IO create subprocess exec. Then we use yield from to get the status of the process. And this inside this connection made, this is the coroutine. We convert this coroutine to the task. Then it will get executed when there's a client accessing our server. So this is when it gets executed. So now we have something different here, the transport. The transports is the ones that represents the connection, that represents the IO computations. It represents our async IO server and the client. So with this transport, you can send, you can read, and for certain protocols such as like if you are going to communicate with the external process, this transport can give you the PID. But for the TCP, of course, it cannot give you the PID, because this PID is specific to the process communication protocol. So here, if we are going to execute it, now this is our 4 clients accessing the server. 1, 2, 3. Now, so we will not get blocked. Now, here the idea is, if you are going to write a server using async IO, you create the kind of server you want to use, such as Unix server or TCP server. Tell them what kind of protocol you want to use. But this is not the only way. You can send a normal coroutines with accept the 2 arguments. These 2 arguments represents the reader and writer. But for this case, we use the full-blown protocol. It has a connection made, the data receive, and the connection loss. But I'm not interested in the data receive and connection loss event. I'm just interested in the connection made event. So here we execute this like communicating to the external process, the process of producing the Mahatma Gandhi quote, and we convert it to the task. Then you execute it with then you run the server. And to handle the error code, to handle the error case in the async IO is kind of different. In the threading, you can use the normal. You can use the normal exception. You just use try catch. But inside the async IO, when we get the task, this is like a future. There's nothing interesting here. When we get this task object, you cannot get the results. You will get nothing useful. But this is a futures. It's a promise. It will get you results once the task is finished, then you must use callback. So this way I add a callback. Here that's where you can check whether we get the meaningful results. If not, you can say sorry. I cannot give you the Gandhi squad. So this is the way how you handle the error in the async IO code. Okay, so that's it. I'm thanking you for listening to me, and I want to thank to one of the Python core developers, Senthil Kumaran, who helped me polish this talk. And I hope you gain something useful from this talk. Thank you.
Thank you, Sky. Questions?
Hey, thank you for the interesting talk. I want to check, can we add tasks while the tasks are being executed? Like we start with 3 tasks and then can we add one more while the task is running if we have the reference to the object?
You mean, can I add the task?
Yes.
While executing another task?
Yes. So let's say I start with 3 tasks and then I add a couple more. Is it possible?
So you mean you want to create the task while the event loop is running?
Yes.
Of course you can.
Okay. Thank you.
Right? Is there a similar limitation with async IO that the loop that you started, once it stops, you cannot start it again?
Well, you can restart the event loop if you stop it, but you cannot restart the event loop if you close it. So there's a stop method, there's a close method. The close method is a final. It's that.
Yeah, in your server example, you're using both yield and return inside a function.
I'm sorry again?
Yeah, in your previous example that you were using. In your previous example that you were using, you had a get output function which had yield from and return. I mean, where does it return towards? Yeah.
Oh, you mean it depends on the coroutine itself. So if it's kind of the same of the yield case. You just return the what you want, whatever you want to return. Okay, I don't get it, but let me talk to you after this talk. Okay.
One more question. Is there a context manager that monkey patches all the default functions to use the async IO functions?
No.
Okay.
Thank you. There are a couple of announcements. Just.
So I can leave? Yeah. Okay.
Hi everyone. I hope you saw Arvi's slide put out in the morning. So one of the things that happens at every conference is a lot of people meet, interact and talk. So personally I went for a lot of conference for first of couple of years, went to the talk, listened to the talks and walked out. Eventually I realized that there's a lot more you can learn, you know, when there is not a talk happening. You can go meet other people and all. So this year I've been helping run the open spaces, where what we want to do is, you know, let you meet other people. So we are having a bunch of bobs and, you know, small discussions on the first floor. So we had like 3 or 4 yesterday. So I'm kind of having a tough time finding, you know, a lot more of few speakers coming up. So if you have an idea that you would like to, you know, talk to a bunch of people, it might not be like a talk, as if he said. It could be an open discussions where, you know, a new thing you've been playing around with, where you even want to find other people who are interested in it. So please find me outside. If you want to, you know, schedule an open space, you can find me and we can find a time slot and do it out. Make good use of this feature. So I hope you learn something beyond the talks too. Thanks a lot.
Sorry? Just check the mic. Check.
For that matter, we have just a few open spaces scheduled right now. For example, the person who talked about Shark queuing system is giving an open space at 11:30, like right now. So if you have like your own questions and want to learn something, you can go ask him. We have a talk on free and open source software and freedom redefined at 12:45. At 12 o'clock, we have a discussion on the DICOM protocol. If there is anybody in the audience who knows about DICOM, please go there. And at 4 to 5, we have a open discussion on all the available web frameworks. So please.
For the next talk, we have two speakers, Ben and Alex. They would be speaking on new scientific plotting in Python. Ben is the engineering director at Plotly. He works on Plotly Python, 3D visualizations, Plotly sharing platform, and backend Django infrastructure. Alex is an engineer at Plotly. He does front-end work and a lot of design and hardware-related work.
Take this.
Hi there. On when I'm ready. Awesome. Just gonna mirror the displays so we can see it on here. Yeah. All right, thank you for the introductions. My name is Ben, and up here with me is Alex Vados. He's also an engineer at Plotly, as well as on our design team. And we're going to give you a short demonstration today about a tool that we've been working on for a couple years now. We had financing last year, so in earnest for the last year. And as I'll explain in a little bit, Python is a really important part of Plotly. We have a lot of Python developers on our team, and so as we develop this tool, we've been thinking about the Python developer, having them in mind. We think our product and the visualizations that we do can offer a lot to the Python developer, so we're going to walk you through and see, so you can see how it can be useful to yourselves and hopefully get you started using it right away. But first off, I'd just like to thank everyone for being here. We traveled quite a ways to be here. And so for myself and the Plotly team, thank you so much for this opportunity. We arrived in India. It's my first time in India. We arrived on Friday, and wow, it's to be honest, it was mind-boggling. The amount of energy and action in the city, and also hospitality of the people. It's mind-boggling, but also very humbling for myself. It's the same thing I found at PyCon India here. Last summer, I went to PyCon Montreal, which is the North American PyCon event. And it's a very large event, a lot of people there, but the enthusiasm and the willingness to learn of people here is 10 times what I saw there. And so I'm really happy to be part of this event. And I'm really happy to see it so successful here. It's a really great story. So, as I was saying, Python's a really important part of Plotly. We're the core team, the original founders, we're ex-scientists who moved over into programming. And so Python was part of our daily workflow doing research. And it was out of that that we got the idea for creating this tool. And not only that, I mean, because we had experience with Python, we wrote our backend of Plotly is in Django. All our associated tooling is in Python. The very first library released was the Python library, and that definitely gets the most love out of all the rest of the libraries in the team. So I think that's good. We'll step the demo up here, and then we'll show you what that might look like. I'll reduce that a little bit. You can all see that? Yeah? Okay, so the library that we have, it's free, it's open source, it's on GitHub. You can, if there's any questions or you want to give us feedback on it, if you use it, we love contributions. It's part of the reason why we're here in PyCon India. So we want to give back to the Python community, but also reach outside of where we're from, come over and meet new people. I know you have great ideas, and there's a lot of talent here. So at the end, we can show you a little bit about how you can start to interact and check out the code. So the library itself, you import it like a standard Python module. You can install it with pip. So here we're importing the library. And then, so say I'm working on some data analysis or doing some research, or perhaps this is part of a web app. Here we want to create a data visualization. So we have some helper functions in Python that comes in the package. And so here we're going to create a histogram. I'm pulling in some data. This is data about like age of rocks, doing a bit of analysis. I create a second histogram. This one's from a different rock type. You can set various options. The tool itself, the plotting, the graph is highly configurable. You can look online. We'll show you a little bit about that later, about how to find all the different options you have available to you. And here we're going to do a bit of analysis. I'm going to take so we have a histogram. I'm going to make a fit a curve to it, like a normal distribution. So we could take that, and I'm going to send that as a trace object to Plotly. And here we have, I'll do a second fit for the other histogram. And then we put all the data together in a list, and we create a layout object. That's going to give you some of the global properties to set things like the title and the color. And then right here we create the figure object, and then send that figure object off to Plotly. So this is it's a web tool, so when you make a plot, it actually returns you a URL. And in our Python library, it'll actually automatically open up your browser and show you what that looks like. So say I'm working on this project, and I have a collaborator, could be in a research department or someone I'm working with at a company. We want to share these results. And the standard way in a lot of the workflows that we have now is you get some results after analysis, you make a PNG or turn it into a PDF, you ship that to them, and then if they want to interact with that, or they have some concerns, they want to look at the data, or they want to change some things in the figure itself, they're unable to. So they got to ask you again about, can you send me the code, or can you send me the data? And there's a lot of back and forth going on. So that's the problem domain that this tool is trying to solve. So let's run this. So the goal of this, I want to send these results to my collaborator here, Alex. All right, so we can see that opens up a browser window. And so it gives you the URL, but also, like I said, it'll open up the window. And so this opens up in Plotly, and here's the figure. And so all of these are interactive. It can show you the data points. You have access to the URL up at the top. And so let's copy this. We're going to ship this over to Alex here. Let's find him. We use HipChat at Plotly, so let's post him this. All right, so then we ship the URL to Alex, and he can take over and then start iterating on this work. Go ahead.
Cool. Can you guys hear me all right? Awesome. All right, so Ben's done all the hard work. I just come around now. He wants me to take a look at it, see if I have any concerns. So he sent this to me in whatever chat system you use. I can pull up this figure here in my own browser. As you can see, it's identified. Ben created this graph. His username is there. There's a unique identifier for this graph as well. So if we want to work on the same graph, we have a good starting point here. So I take a look at this. I'm a little bit more design oriented than Ben. I see it, the colors are a little bit weird. Maybe we should change that. So just head into the terminal here. So this here, let's make it a little smaller. So this here, what I'll be doing, again I import the Plotly library, so on my own system, new pip install Plotly. And I'm going to create a figure, but instead of actually creating the figure how Ben created it, I'm just going to grab his. So I can do py.getFigure, and I'll instead replace this identifier with the one that he sent me, which is at 13. So it's actually already set up. So some things I want to do, I mean the colors on this, not great. Maybe your boss wants it to match the branding, whatever they want, or you want to mess with the data. So here I just pull down the figure, py.getFigure, and that's going to return the entire graph object that Ben has created. Now if I want to go and change the bar colors, I can select the data, one of the data traces, go right to the marker, change the color, and assign whatever hex color I want, or RGB, or even just a string like blue or red. And we look at this, so we see, the fits, they could be a little nicer, we could see them a little clearer, so let's change that as well. Maybe change some of those line colors, the background color. So it's all pretty straightforward. It's very declarative. We have what's called a graph reference, so I'll give you a quick peek at that. So this, essentially all of our graphs, what we're trying to do is create a very generic object so people can collaborate. And our Plotly object is fully described in this reference. So we can always go in and see, okay, we're making a scatter. What do we need to include? So everything is all here, and that's basically what I've done. I've gone in and said, I want to change the line width. I want to change the color, the background color. It's no big deal. So we just quit there, and we can run that. So now this is grabbing all of Ben's stuff, running my changes on it, and pushing it back up to the same plot. So if we go here, you can see it's still Ben at 13. We're now working together, and now we have the PyCon India colors, and we're all good to go. So from a design perspective, much better than before. So this can also be done for data as well. You can actually pull down the data traces, maybe do some analysis and send it back up, all working together in tandem. Now one of the nice things about this is, let's say, for example, Ben works in Python. What if I use JavaScript, unfortunately? Well, I wouldn't necessarily have the time to learn Python syntax or a whole programming language. So what I can do is take this magic URL, put a .js, and here's that same plot in JavaScript. So now if I'm a JavaScript developer, Ben's made this in Python, I can pull down all the data, work on it, change it, using my own tool set, so something that I'm comfortable in, and push it back up. If you want to embed this in a blog, use our magic URL, hit .html, and this would be the iframe code you would use to embed it. Now if you can see, the source is Ben at 13, which means that any changes that we make will automatically show up. There's no more regenerating PNGs, SFTPing that over, putting it on your website, making sure it's all updated. It's all done for you while we edit the graphs together. All right, just a quick show of hands. How many of you guys use Matplotlib or have used Matplotlib? All right, so it's like 90% of the people here. That's great. So we love tools like Matplotlib, and we're not trying to replace Matplotlib. We think it's great. We love ggplot too. There's so many great tools out there, but the problem really is when Ben is working in Matplotlib and I'm working in Python or JavaScript, how do we collaborate? So let's just get another demo going here. So here we're pulling in Matplotlib. We're getting an evenly sampled line at 200 millisecond intervals, and we're going to plot that. So if you guys are familiar with Matplotlib, this is nothing new. This is Matplotlib right up to the last line. Now, what we're going to do is just run the Matplotlib code, so you see the output of that. And there's your output. It's pretty great. I mean, it's a good chart, but the thing is, what do I do now? I send this to my boss, it's in an email, maybe he doesn't like the colors, the spacing, the data, he wants to do some more work on it. He doesn't have access to what's behind it. So we can just go back into our script. Instead of doing plt.show, which is your matplotlib command, we're instead going to call and pass our figure object, our MATLAB figure object, directly to the Python, or rather the Plotly module. We're going to give it a name, so we'll run this. So now this is taking our matplotlib figure, changing it into a very generic graph object, and sending it to Plotly. Hopefully, there we go. So we're given another magic URL, and there's our interactive graph, complete with the matplotlib styling, but fully interactive. So the fun doesn't really end there, though, because like before, this was creating matplotlib, a very specific tool. We can still go in and see the underlying data. We can still manipulate this URL and turn a matplotlib figure into JS, or into MATLAB, or into R, or ggplot2, whatever you use. So it allows us a great deal of flexibility to collaborate. So yeah, that pretty much sums up my part. Ben has he's been building some great systems for real-time streaming, which we think, I mean, every time you speak about graphing nowadays, everyone's interested in real-time streaming, especially with the Internet of Things and just the accessibility of Internet all over. It's great. So without further ado, Ben will come back and show us some more stuff.
Thanks, Alex. Okay, so this is dependent of the Internet connections working. So let me just give this a shot. So also, Plotly spends a lot of time on the APIs for the different libraries and the cross-platform nature. So the underlying graph object is a JSON structure, and so it's more like a protocol. So that's how we can shift it around. It's not attached to any particular platform. So even if in the, let's go into the web app here. So if you have someone on the team that's not a programmer and just uses Excel, we have our core web app, which has spreadsheet-like functionality, so you can get the data in the spreadsheet, make edits there. And here, and sometimes I've had the problem when I was doing research where I would have some core code doing the analysis, and it's 200 lines long, and then to get the right plots for publication, they're about 800 lines of code. And so often I find it's nice to get your base plot up there and then bring it into another utility that's more focused on styling. And so we can bring what Alex and I have been working on into the web app itself, and there you have available to you a huge range of options to change any little feature about the plot that you want.
But all of these features are also available through the API, should you choose to do it all programmatically. So it's just a web interface for the same features.
And let's take a look, see if we can get this going. Yeah, all right, there it is. Okay, so one of the other things that we've been working on is expanding the core graphing library out to real-time data. It's a bit laggy. The Wi-Fi connection's a bit hit and miss right now. But so this reaches out to Arduinos, Raspberry Pis. We have a Python. You can run Python on the Raspberry Pi. Use that to stream data. The API for that's really easy. It's the same Python module or library, except you just call the stream API, and then it passes you out basically like a file object, and you just call write. And every time you write, it'll send that data point right to Plotly, which will add that. And you can embed this in your website, and as you stream up points to it, it's real time, so anyone else that's viewing that plot will see the same data scrolling by at the same time. So that's one thing that we've been working on, and another feature that we've just released recently, Let me open up the local host here. Is 3D. So at underneath most of the plots we're using SVG, so that's rendered by D3. And then for 3D work, we switched over to WebGL. And so that allows, there we go. So here's a 3D element. This is done inside the WebGL canvas. It does require that the user has a video card to view it, but it is offered the same sort of styling features that you would expect from the rest of the Plotly API. So it's this kind of tooling, the real-time streaming, the 3D API, and also able to collaborate between platforms that we're excited to bring to Python workflows as well as other workflows. So it gives really nice, high-quality the results and data visualization to your workflow, and it's, like I said, it's free to use. The graphing or the Python library is open source. It's on GitHub. We'd love you to come check it out and give us feedback. I know that there's better Python programmers than anyone on our team, so we'd really love you to take a look. And with that, are there any questions about? Yes. Okay, while we wait for questions, I just want to thank you again for you all being here. It's an honor to be in India. Thank you so much. I'm looking forward to coming back. Thank you.
Yeah, I think the mic is ready now. The thing is, exporting it to JSON is really amazing. So how is the support for Sage?
What was the support for?
Sage. So actually Sage, if you want to import the same graph into Sage, so are there any provisions for that, or should we have to again?
Yeah, we don't have any direct tie-ins with Sage yet. So some of for the platforms like Sage, Mathematica, we do not. For MATLAB we do, so that's something that is in the future. Our first set, we have about 6 platforms that we've targeted, but we're expanding that slowly, so that will be coming. Thank you.
Hi, this is Ray, and how does this work in 3D? It doesn't work and doesn't render in. Is it working? Yeah. So it doesn't render in other browsers, right? It renders only in Chrome. So it doesn't render in Firefox and other things, right? So how do you work with that?
No, the WebGL spec is actually supported now in Safari, Firefox, and Chrome. The more recent editions, I think for the last roughly about a year, it's been in Chrome, and Safari and Firefox have caught up. So the latest ones, it does work in those browsers.
How do you handle this on tablet or something?
Tablet's still getting there for the WebGL. Yeah, I mean, we're not in control of that. That's whenever they get that going, then it'll work.
Hi, Plotly. Plotly, I have a question to ask.
Oh.
I've been using Matplotlib and.
Sorry.
Yeah.
Sorry, 1 sec.
Yeah. I've been using Matplotlib and I have faced some problems using multiple axis plots. Like when you have a multiple axis plot and you zoom in, the structure of the plot, it gets disturbed. Have you handled that kind of things in your library, Plotly?
Yeah, so we have really strong support for multiple axes as well as what we call subplots. You can tie different axes together so that if a user zooms in on one plot, it'll zoom in on the other axes, or you can unhinge them as well so that they'll be unaffected. You have full control over that. So do we have an example we can show you here?
I'm not hitting local.
So these ones, these are subplots. It's very similar to the way that we handle multiple axes. So you can tie the y-axis of one plot to the other so that as you pan on one, the same data range will pan on the other. And if it's zoomed in, it'll pan slower. So it works as you would expect.
This is actually a subplot case.
Yeah.
Yeah. In multiple axes, you'll have more than 2 axes on a same subplot.
Yeah, we'll get that up here. So get the, I think just not the matplotlib docs, but the Python docs.
There's a few examples you can check out. Our documentation is pretty robust, so all of the examples on the right are the code that was used. On the left, the code was used to create the example on the right. So you can see it's very declarative, and the Plotly graphing library just takes care of all the heavy lifting for you.
Okay, that's good. I want to ask you one more thing.
Okay.
In some use cases, we have very large data sets, say around 20 lakh points or something. And we want to plot that, but plotting so many points on the screen doesn't make any sense.
Right.
So we need to decimate that. So do you have any decimation algorithms inbuilt in the library?
Okay, that's an interesting question. So yes, on the web app, when you try and plot 1,000,000 points and your screen's only so big, that's not going to give you any extra information. It's wasting points. It's also going to slow down the browser because it's making SVG elements. So in the browser itself, we do have a decimation algorithm that runs. And that's how we can get up to 1,000,000 points. Otherwise, it would bog down a lot lower than that. Past that, it becomes a problem of the network trying to send that much data into the browser. But what we're working on right now is we have a nice data visualization API. So what we're working on is doing the same for data. And so every user will have their own little database, and we're going to unlink the plots from the data. And this should allow you to have arbitrarily large data sets, and then the plot will just be a view on that. And then you can specify your own decimation algorithm. So like take a mean and only do like 1 in 10 points, so you can get a sample of a lot of data and just get the overview. And then as you zoom in, we'll provide more resolution, but it'll be a tighter range. So that's something that we're working on right now to address that problem. Thank you.
Yeah. So can we extend the visualization for dependency graphs, and we have like Neo4j graph databases and all. So can we extend this, or?
So the core Plotly.js library, which is similar to there's a lot of other JS graphing libraries out there. That one uses D3 under the hood, and if you're using that, I think it has requirements on D3 and jQuery. That's it. But the rest of the ecosystem, that's all built into the tooling already. So those. But for just the library itself in the browser, it's just got the dependencies of D3 and jQuery, and also video card if you're doing 3D plots.
Is there a way to integrate it into something that is not web browser or image based dependent? Like a simple Qt interface, because if I'm developing a desktop software, I don't want it to be browser dependent.
Yeah, so there's a few projects out there like Node WebKit, which have stripped out the WebKit from Chrome and then offer that as a desktop app platform. And so in that scenario,
that is still browser based dependency, just an interface to link it up.
Yeah, so that, I mean, that's, and you can't really get outside the browser. I mean, the core plotting is in JavaScript. We use the canvas for WebGL, so it's stuck in there. But if you want to send and
like if it's stuck with the canvas, then we can probably integrate it into some PyQt or Qt based interface.
Right. Could be possible. It's something you could talk to me about.
Not in Qt, so might
this is why we're here. Yeah.
Thank you.
Great. All right. Thank you.
Hey, this is Bala. So how long do you are the data up on the server? So how long when you push a graph up, and how long do people have access to the graph, and how do you store the data and all those stuff? How do you scale up to multiple people having that?
Right, so we store it in S3 on Amazon, so as long as Amazon's S3 is in business, then your data will be there.
And following up on that, so you have access control, right? So like this can be shared and accessed by only this site kind of people, and not anyone with the URL can access it, or how do you manage the data security?
Good point, I didn't cover that. We have public and private, so if you can mark at any time your graph is private, and then that URL will no longer be accessible except for anyone that's logged in as you, which is hopefully you.
Thank you.
Yeah.
And just to follow up on that, you can also specify collaborators. So similar to, let's say if you're on GitHub and there's a repository you want to work on, but they haven't specified you as a collaborator, you can always fork that repository and work on it on your own. You'd never be able to change that underlying code in the main repository. It's the same thing with Plotly. So if the graph is public, you can always pull it down, work on it on your own. But you can actually specify collaborators as well, which is like what Ben and I did, where you can actually work on the same data and push to the same graph.
Any questions?
All right, thank you again. Thanks so much. We'll be out in the booth. Come talk to us. Thank you.
Thank you, Ben and Alex.
Thanks.
Thanks being with us. And, yeah.
The next session for the day is Faster Data Processing in Python by Mr. Anand. He is the Chief Data Scientist at Grammarly. He explores data stories visually with Python and JavaScripts. Let us welcome him with a round of applause. Thank you.
Probably take me a couple of minutes anyway too. Hey, shouldn't it be green? Okay, that's pretty much it. Let me know when I can start, I'll start.
Just wait for 2 minutes. I don't think that audio.
Sure, 2 minutes. You're sure this is working?
Yeah.
Okay, fine.
You can turn it off for the time being, like 2 minutes.
No, I'll stay quiet. I just want to confirm that people can hear me. I speak somewhat softly, usually. So, fair, cool, not a problem, I just switch off. That's okay, don't worry. Thanks. Shall I start off? Okay, we're going to be talking about processing data faster using Python. Now, not that Python is particularly slow, but there are a number of things that one can do to make it a bit faster. And what I'm going to be talking about is a few of those techniques which will hopefully marginally improve your code. And the sort of reason why we discovered these techniques was a piece of work that we did fairly recently on the elections side. Before I go ahead, you will find the code for this, the entire talk, which is a bunch of IPython notebook slides on GitHub under my account, which is sanand0. I've also posted this link, or I will be posting this link. I've scheduled a tweet for 12:50 on my Twitter account. So either way, you should be getting the contents of it. See, the story actually started when a huge touchscreen monitor, 92-inch monitor, was installed at the CNN IBM office. And you would have probably caught up on this when Bhupendra Chaubey and Rajdeep Sardesai put together the CNN IBM Microsoft Elections Analytics Center. And we created the software behind it that was doing all of these visualizations. So for a period of 1 month, people were walking through the history of all previous elections, explaining what exactly was happening in each constituency, and on during the live elections, how the results were moving and so on. But some of you might be able to see a bearded figure in a red t-shirt at the right side, top right. So that's me making my first television appearance. I was obviously pretending to watch the monitors there very carefully, but what I was really doing was calling home and saying, turn to CNN IB and watch me. So it was a pretty interesting month, and during the course of that month, we were playing around with data like, for example, what was happening in each assembly election. So for example, one of the things we were playing around with is, which was the election that had the largest number of voters largest number of candidates that ever contested in an election. Our guess was that there were probably 100 candidates at most in an election, but even 100 candidates is a fairly large list, because when you look at the ballot sheet, it would, you'd have to flip through a few pages to find your candidate. So we were playing around with it. This, for instance, is the assembly constituencies in Tamil Nadu in 1967. Each circle is one constituency. So this, for example, is Vandavasi, this is Nellipakam, and so on. And the size of the constituency is the number of candidates that stood for election. So large circle, like for example, Perambalur, means that there were as many as 10 candidates standing for elections there, as opposed to something smaller like Tindivanam, where there were only 2 candidates standing for elections. Now this was in 1967. The circles are colored based on which party won. Yellow is ADMK, red is CPM, and so on. 1967, there weren't a large number of candidates in any constituency. 1971, picture hasn't changed much. 1977, there's a sudden spurt of people standing for elections. That's mainly because of the introduction of a new party, the ADMK, which came in, and therefore in practically every constituency you had at least one more candidate. A lot of independents came in as well. The next year, 1984, now there's one constituency, Maduranthakam, where there were as many as 90 candidates standing for elections. That's a pretty big number. 1989, sudden spurt across the entire state, but nothing stands out. However, in 1991, 2 places stand out. There's Pallipet with 264 candidates, and Avarakuruchi with 249 candidates. Now, at this point, you have a ballot booklet, not a ballot sheet. You have to flip through and find your name and all that. All of this pales in comparison, though, with Madakuruchi, which had 1,033 candidates standing for elections in 1996. Right, so this is a ballot book. In fact, this is probably the telephone directory of Madakuruchi. Now, if you look at the details, now it's obviously mostly independents. The party cannot field more than any candidate. But if you look at the names out here, for example, let's see. Okay, so there's Palanisamy D, Palanisamy K, Palanisamy K, Palanisamy K, Palanisamy K, Palanisamy K. I mean, how do you figure out which Palanisamy K you are if you want to vote for yourself, right? Which seems to have been a problem, because there were as many as 88 candidates that did not vote even for themselves. They got 0 votes. Probably because they didn't find their names or whatever. Now the thing is, when you're generating this, what we're doing is, as you click on each constituency, quickly extracting the list of people from that constituency, sorting it in descending order of votes, and displaying it. Now let's walk through how one goes about optimizing it. What I'm going to be doing is walking through various problems that we faced during the creation of this visual and a few other visuals, taking different examples, and talk about how we start optimizing it. Now, let's take this simple problem. I want to see all the people that contested in Bangalore South and sort their votes in descending order. Now the data looks like this. I'm sorry if some of you at the back can't see it, but it's a simple CSV file that has the state name, the year, the constituency, their name, the number of votes, and so on. And it's one massive file with about 4 lakh rows, which has the details of every assembly election that has been contested in. And I'll come to how we scraped it very briefly later. Now, how does one go about extracting the top candidates, the candidates that got the largest number of votes in Bangalore South, let's say historically? Now, this is a standard interview question for us, and a standard interview answer that we get for this question looks like this. What people do is, and I'll make this a little bigger so that hopefully you'll be able to see it, and obviously the code is also at the GitHub repository. What people do is loop through each line. They open the file, the assembly results, and they loop through each line. They skip the first row, which has the header, and then they split the line using commas, and then they check if Bangalore South or whatever is the constituency we're looking for is in the right column. If so, they get the name and the number of votes and put it into an array which contains tuples, and then use import operator and sort it by the first, by column number 1, which is effectively the second column. I have a feeling that the reason I'm putting this piece of code together is because this is sort of the composite of the most frequent answers that we get. I have a very strong suspicion that this import operator is a result of a Stack Overflow search. Let us say just, how do I sort by the nth column, and this would have been given as an answer, and it's just a copy paste, but heck, copy paste works beautifully. And this gives us the right result. But the question is, how long does it take? See, the trick to optimization is to first figure out if you really want to do it, right? And the first step to that is to time it and see if it's acceptable. Now, this particular thing can be timed on, all of this presentation is on an IPython notebook. On IPython, you would just say %time it and run the function that you want to time. In this particular case, I've created a function called most votes, which is exactly the same thing that you saw on the previous page. And this is taking 472 milliseconds, half a second. Not good enough in all probability. But do remember that that is a question you want to ask every time. I love quoting Calvin on this. So when Calvin has his homework that is quite tough, he says, I always like to break it up into pieces. So Hobbes asks, so does that mean you're going to start with the first chapter first? No, I ask myself the question, do I even care? Right? So do I even care about optimizing it? At half a second, it may be fast enough. In many cases, it is. In our particular use case, it wasn't. So we then ended up making it a bit faster. But never forget that first step. Is it even worth optimizing? Premature optimization is a big evil. Okay? Try not to do that. But let's see how we can go about optimizing this particular function. The first step is to figure out what is slow. Let's find the slowest part in this piece of code. Now, there is this lovely module called line underscore profiler, which you can do a pip install of. And when you do that, it tells you how long each function, each line in a piece of code is taking. So specifically on the IPython notebook, I've just got this piece of code. You say %loadExt line profiler. It takes a bit of setup. It's not trivial to set up, but it's not complicated either. And I've got a link where you can set it up. Once you do that and say %lpra, that's an IPython notebook magic. Let's see what it does. It's running it. Now this is a function that evaluates it for a long time, and finally at the bottom it gives me the result of the computation, which is a little difficult to see here, so I'm going to switch back to the presentation, and at the bottom you see the results. Each row in the function is defined, and against each function we have the total number of hits, which is the number of times that line was called, the total time taken by that, the per hit time, and the percentage of the total time. Now I usually only look at the percentage of total time. I'm simply interested in optimizing the slowest step. And there are a bunch of lines here, 5 of them, which seem to be taking anywhere between about a dozen, 12% to 30%-ish. So somewhere here is what I need to optimize. I will not bother optimizing that anything that already takes 0 time, obviously. Right? So which already means that we've cut down the zone of search to what is specifically to be optimized. Now, there's a fairly simple procedure by which one goes about optimizing, which is basically around picking your battles. First, if you see something that is obviously redundant, get rid of it. And there's no point having it. Second, look at what takes the most time. Now, to reduce something that takes a lot of time, there are 2 ways. One, reduce the number of times it is called, or every call reduce the amount of time that it takes. Now what we're going to do is apply these principles in sequence to this piece of code and try and see if we can get it to, maybe 20-30% faster, or how much ever faster we can. So let's start by eliminating what is obviously redundant. I'm going to go back to the code and zoom in a bit. One of the things that we're doing is every line we are checking if it is the first line or not, and then if it is not the first line, going to the next one. So this particular check, if row is greater than 1, is being called about 4 lakh times. So which is why you can see here that it's taking approximately 15% of the time. Let's get rid of that, and that's fairly easy to get rid of. All we have to do is, as soon as we open the file, skip the first line, and thereafter there's no need to do that check. Right? It just moves outside the for loop. If you're not doing something that really needs to be done multiple times, just do it once and be done with it. Now that has given us a 9.5% increase in speed, which is small, nothing great to start with. Let's move on. Now let's see, having done this, what takes the most time. We've again run LP run, and there are 3 lines that take a reasonable bit of time. The bulk of the time is being taken up by this line.split. So we're splitting by commas, and that is taking up about 45% of the time, so that's worth optimizing. Now, there are 2 ways of optimizing, like I said, reduce the number of times that it gets called, or reduce the amount of time that it takes. Let's start by reducing the number of times that it's called. It's being called 4 lakh times. Now, what are we doing here? We are merely listing the number of, we only want to extract the people from Bangalore South. I'm not interested in anything else. So if I can just check if the person is in Bangalore South without splitting by commas, that does my job. I only need to split by commas when the person is in Bangalore South to get the number of votes. So why don't we move the splitting of the commas after the check? So what we do here is first check if there is a match. If you find the assembly constituency name in the line, anywhere in the line, only then do you do a split. Now what this does is makes the code 83% faster. Now we're talking something. Now the reason why this has had a good effect is because it was already taking up about 45% of the time, and we are drastically reducing the number of times that it's getting called from approximately 4 lakh times to just 36 times, because there were only 36 people that contested in Bangalore South constituency elections. So now what is the bulk of the time going into? The bulk of the time is going into if line.find of AC name is greater than or equal to 0. In other words, in the line we are checking to see whether the string exists or not. Now, can we call this any fewer times? Probably not. I mean, there probably are smart ways of getting around it, but nothing obvious strikes me. So let's go for the second technique. Is there a way of making something as simple as a string find faster? Right? See, let's do a bit of disassembly here and see what exactly goes on behind this function. There is an interesting module called DIS, right, which is a disassembler, and when you run this module on any piece of code, it tells you what is the exact Python bytecode that runs behind it. So we've created a function here called check. What this check function does is simply takes a line, finds the assembly constituency name, and checks whether it's greater than or equal to 0 and returns the value. When you import this and you disassemble the functions .func_, you get the following result. Now before I show you the result, I think this func_ code is worth spending a few seconds on. See, you would be surprised at the level of access that you have to functions internals. For every function, in fact, let me just show you what this looks like. Let's say we have this, there's this function. Give me, not able to close it for some reason. Let's take a function, yeah, this one, okay. Most votes check first. Now, if I take a function like most votes check first, or just most votes, and let's look at its methods. There's a dot, every function has a dot func_closure, func_code, func_defaults, this, that, etc. And this func_code is somewhat interesting, but leaving that aside, you can get the function's name from the function itself. If you have the function object, you can figure out that its name is func_votes. You can figure out that it has the following variables as global variables. So it is in what context is it being evaluated in. You can figure out what else. You can figure out how many arguments it takes and so on. Now, which lends itself to a bunch of interesting use cases. Supposing you have a function which is passed a function. Now you don't know whether this particular function takes 1 argument or 2 arguments or 3 arguments. You can figure that out. So depending on the type of function that comes in, you can inspect whether it returns a value, whether it is part of some module, whether it has access to a certain global variable, and based on that perform different operations, which lends itself therefore to fairly powerful polymorphism. But this talk is not about that. I just want to mention that func code is funky and move on. Now what this does is, out here, first loads a variable called line. That's the first thing that we're looking at. Then gets the attribute find of that line, which is a string, and then loads a variable called AC name, and then it calls a function, which is effectively calling the line.find on AC name. Then it loads a constant 0, compares the result against 0, and returns the value. Now that's a reasonable number of steps. Can we reduce the number of steps that are happening here? Well, yes, we can. All we have to do is say AC name in line, right? Now, which does exactly the same thing. It is effectively the same code as the line operator, but when you disassemble it, that's a lot less of code. And if you look at how long it takes, this ends up being about 61% faster, so almost 62% faster than the previous piece of code. So the point is, it's probably a way of getting stuff to run faster in almost every case. It's largely a matter of exploring, but we have learned at least a couple of principles here. One, that you find what takes the most time and focus your effort on that. There's no point focusing your effort on anything else. And it seems that the operator, a reasonably good way of doing that is use the line profiler function. There are many other profilers and it's worth exploring those. And secondly, when you're stuck with optimizing a relatively small piece of code, then the disassembler can come in handy, if only to let you see what the internals of that function are and perhaps think of alternatives. In general, a rule of thumb is that operators are faster than functions in Python, not necessarily in many other languages. Just keep that in mind. So overall, we started off with something that took about half a second and got it down by reducing a redundant line, removing reducing the number of times the split function is called, and then using an operator instead of a function, and gotten to a 3.2 times speed up, which is effectively 320%, which is not great, but not bad either. Now, the other question that will come to your mind is, look, you're doing all of this in Python. If you were to do this in C, it would be so much faster, right? Why don't you use a library like Pandas or NumPy, which is blazing fast? Let's do that. So this is the code in Pandas. We read the CSV file, and we read the CSV file. We check for the assembly name to see if it contains AC name, and then sort it by descending number of votes. This takes 1.1 seconds. In other words, it's about 87 times slower than the piece of code that we had. What's going wrong here? It's not that the Pandas code is slow. Pandas is inherently very fast. It's not that it has been implemented in a bad way. This is about as fast as you can do. The thing is, a library like Pandas encapsulates a lot of things. Now, what we did was we did not actually load the CSV file into memory. We just looped through the lines. We did not even split each line into commas unless really required. We only split it when absolutely required. And with that kind of optimization, even a library written in C is not going to be able to compete. Remember, libraries are good. Your brain's better. Just if you focus on optimizing, you will get to stuff that's much faster than anything. Just reject dogmas, measure it. If it's faster, use it. Now, which begs the question then, look, I do want to go to the fastest format. So can you give me a suggestion on what is the fastest format? Now, I've been playing around with a lot of structured, semi-structured data, at least in file formats. And here's the summary of the result. If you're looking for a fast file format, then among the ones that I've tried, if you're using a dictionary, if you're using CSV files, loading using csv.dictreader is a little slow. Okay, pickle.load is a bit faster if you're storing it in a pickle format, but it's not necessarily as portable as you would like it to be. JSON is a bit faster than CSV depending on how you store it. You can either store a CSV file or tabular data as an array of dictionaries or as an array of arrays. If you store it as an array of arrays, it's quite faster. Now, a CSV file can be read faster as just csv.reader. csv.dictreader does impose a fairly heavy penalty, even though it makes the reading much easier in the future. So think carefully about it. But if you're using data as CSV files, there's no doubt that Pandas is the fastest. Okay, and it's fairly heavily optimized. So CSV is a pretty good format. But the format that beats it all is HDF5. It was built for speed. If you have large-scale tabular data and you do want to optimize it, don't bother looking further. HDF5. If you do want it to be portable, then your trade-offs are largely between CSV, JSON, and heaven forbid XML. The choice on that is reasonably obvious. Go for CSV. It's faster than most other formats. Have I tried using CSV.reader with a name tuple? Yes, I have, and that is faster than CSV.dictreader. But yeah, which would definitely work better than CSV.dictreader. Having said that, I've always gone for pandas because it's just faster than anything else anyway, and switching over to HDF5 quite actively. Right, I'm missing something. Okay, let's go on to a different topic, which is scraping the data. So now we were pulling this data from the ECI website, and the main problem here was from the ECI website, not that the calculations were running slow, we were just parsing the HTML. It was not even that the network was slow. The main problem was that the network was unreliable, so it would fail in the middle, and then in that case we're stuck, we have to just start the whole thing again. So which means that making a program restartable is fairly relevant, and not just for scraping. In any case where you have computations that take a long time, if for any reason either the computation or the program itself has to stop, or you want to split it across multiple systems, then you do want it to be restartable. And let's take one simple way, or not one simple way, one simple example of how we can go about making something restartable. See, you have typically in scraping a list of URLs, and you loop through all of the URLs and you parse the URL. That's broadly it, and it's the parsing that takes the bulk of the time, and not because the parsing computation is slow, but because the network request is slow. So if I wanted to cache this, then the way we would do it is write a function like this, which say gets a URL. What this function would do is store the contents in a file name, so some sample.file.name. If the file does not exist, then it would retrieve it and save it there. If the file does exist, it would just open it and return the handle. So which means that the first time that I run this piece of code, it's taking about 4.5 seconds, but the second time that I run it, it's only about 339 microseconds, not milli. So that's more than 1,000 times faster, and you'd say, yeah, obviously, because heck, network is slow and you're not doing much of calculation anyway. So fair point. But the thing is, given that we are caching this, we can't quite arbitrarily cache the URL into a single file, right? The next time I need it, I have to have a different file name. I need a mapping between file names and the URLs. So one way is just to say, look, let the URL be the file name, which runs into a problem when you have special characters, question mark, colon, all of those. So you say, fine, let me get rid of the question marks and colons, which would work fine until you realize that sometimes you do actually need those. So question mark x is equal to 1 is different from /x1, and by just stripping those, you get rid of it. So then you say, fine, let me take a hashing function, and Python's filled with a lot of cryptographic hashes. The hashlib library has a whole bunch of those. Fine, let's evaluate them for speed. Now, if you go through the algorithms in the hashlib module, here's how long each of these take. MD5 takes to hash 1 million occurrences of a string, about 1.9 seconds all the way up to 2.83 seconds for SHA 512. You notice that firstly it's a relatively narrow range. It doesn't really matter too much which hashing function you use. On the other hand, however, it's not too slow. For 1 million hashes, if it's taking about 2 seconds, that's kind of fine. Normally, I just leave it at this. But what I noticed was, why are we looking at a cryptographic hash to find a unique alternate value? The purpose of a cryptographic hash is to make hackers slow. You don't want it to be fast, you want it to be as slow as possible, and that's how they're designed. We want the exact opposite. We just want a regular non-cryptographic hash. And turns out that Python has a built-in function called hash that does exactly that. It takes any object that you can put as a key to a dictionary, and the result is a long, which you can straight away use as a file name or use in any way, and it is over 10 times as fast as any one of these. So my standard workflow for saving a file is to simply compute its hash, convert from a signed long to an unsigned long, and use that as a file name or some variant thereof. Not because the hashing was a slow step, but there's no point going to a cryptographic hash when you don't need one. Moving on to another topic, So one of the visuals that we created had the full history of India's assembly results. So what you see here is in every single state, the party that was in power and for how long. So for example, Congress was in power in Himachal Pradesh for a fairly long time and then switched over to Janata National Party and then Congress again, then BJP and so on. So for every state, the party that's in power from a certain duration to a certain duration is the one we're looking at. Now to get this data, we had to parse the dates of the elections, and the dates of the elections were available in every row of the data. Now this turned out to be a surprisingly slow step. To give you an example, I'm going to create some sample random dates here. So here's a file that we have created that contains dates potentially in the format year, month, day, month, year, and the month could be in alphanumeric or alphabetical or numeric, or day space, month space, year, and so on. And typically you have multiple file formats, multiple date formats. Why do you have multiple date formats? I'll tell you why. Because somebody in the US would have created this file in the month day format, sent it to someone in India. When they open it in Excel in India, the date format switches. So half the dates get converted to day, month, year, half the dates remain as month, day, year, and it's a huge mess. If the dates are less than or equal to the 12th of the month, you're in trouble. You never really know whether it's a day, month, year format or the month, day, year format. You just hope and pray for the best. So, which is why it's good to stick to alphabetical at least for the month if possible, or go to something like year, day, month. But really the data that you get is never clean. So you have to factor in multiple date formats. Now let's see how long it takes to parse 1 lakh dates like this. On my system, it takes about 6 seconds to go through 100,000 dates and parse these. Now that's slow. Okay, just to load the file, and that's 1/4 of the file. Takes 6 seconds. So 24 seconds to load the file. No way. That's. Now, what do you think is the problem? Passing through it. Yeah, seems logical, right? Let's test out and see how big a problem that is. So if you run LP learn on this, 99.3% of the time is spent in parsing. So absolutely no doubt whatsoever that is the only thing that you would optimize. But do not forget to do this step, because no matter how reasonably sure you are, you could be wrong. And in this particular case, we are fine. So we'll take the optimization of parse. Now let's look at other ways of parsing. So one possibility is you say, look, maybe the parsing is slow because I'm calling it so many times. Maybe the function call is slow. Let's go for pandas or numpy or whatever. We take it as a vector, we just call the function once and it does the job. So pandas has a 2-date-time function. You load this as a series. So in this case, what I've done is taken just one date, the 31st of January 2012, and repeated it 1 lakh times and said, convert it to date time. That takes 6 seconds. That's even slower than before. We were only doing it 5.4 seconds. Now, I'm giving you examples where pandas is slow. I by no means believe that is the case. It's actually a bloody fast library. Okay, I'll show you more examples later on. Let's do something else. Let's take dateutil. Now, dateutil is a pretty nifty library that lets you parse various kinds of date formats. So you don't have to worry about whether it's in day, month, year, month, day, whatever. And you can loop through as list comprehension and get all of these results. That's about 5.25 seconds, slightly faster than before, but not quite good enough. What if I say, look, I will only take, I know that this is in the month, day, year format, or whichever format it is. So why don't I just take this string, this string, this string, split it, and, or better yet, sorry, use strip time. Date times strip time is written in C, so that ought to be pretty fast, and it is. It takes only about 1.78 seconds. But you can go even further and say, look, I'm not going to take the overhead of strip time also. I know the format, so I'm going to take the year, which is from characters 6 to 10, the month, which is from 0 to 2, and the date, which is from 3 to 5. And that brings it down to a whopping 236 milliseconds. So which means that we have traded off flexibility for speed. From 6 seconds down to 200 milliseconds, great, but I no longer can parse all of these. Is there a way to break that compromise? Well, let's recognize that the only reason this is being, the problem is that it's being called so many times. What if I could cache it? Meaning, once I've parsed a date, I don't need to reparse it. What if we have a function like this, a lookup function where you say, I take all of the unique dates. Sorry if you can't see it from the back, I'll just read it out. You take all the unique dates, loop through only the unique dates, and convert it into a dictionary. So for this unique date, I parse it and store the result, and then return the Then I go through all of the dates and look up this dictionary. Dictionary lookups are faster than date parsing. Now this takes 13.9 milliseconds, down from 6 milliseconds on the same data set. And if the dates are varied, it's still dramatically fast. So the thing is, you also need to understand the nature of the data. If there's a lot of repetition, there's a fair bit of potential for caching. You cannot arbitrarily apply what is normally a fast function to data that has completely different characteristics and expect it to still work fast, or assume that it cannot work faster. Speaking of which, see, I started using list comprehensions in the last couple of examples. Let's look at how fast loops are, which can be replaced by list comprehensions. Let's take the simple process of an array and squaring all the values in an array. So I've defined a function square that simply squares a value, and you out here loop through all the values in a data set, compute the square, and append it to a result, append it to a list, and return that list. So we are just looping through every element in the array, squaring it and returning it. This takes 28 milliseconds. Okay. Now there are two things we are doing here: calling a function squared, and we are looping through in a for loop. Let's see what happens if you inline this, basically remove the function call. All we've done is taken the value times value, which was originally in a function, and put it inline. Now that gives us a 70% improvement. In Python, functions are slow. Custom functions, not necessarily C functions. If you're calling a function, it incurs an overhead. If you're calling a function many times, like inside a for loop, that is slow. Try and inline functions if you can. That comes at a loss of flexibility, and we'll talk about how we can break that compromise also. But if you're programming in pure Python, try and avoid pure Python functions if you can. Let's take loops. Now, if instead of, sorry, I'm going to skip this. If instead of putting this in a for loop, I put it into a list comprehension, value times value for value in data. Now, firstly, the code is smaller, potentially more readable. All of those benefits exist, but this is 90% faster. Which means that for loops as well, you incur an overhead. Like with functions, which you ideally would want to replace with operators, loops are ideally replaced with list comprehensions, and these apply to most programs. But there's another way of applying this, which is thinking in vectors. So library like NumPy or Pandas would, well, and NumPy really, which is what Pandas is built on, lets you do the following. You can define the data as an NumPy array or a Pandas series, and then just say I want to square it by saying data times data. Now that's just one straight operation. This takes 420 microseconds. Okay. That's about 16 times, not 16%, 16 times faster than the code that we had. So clearly there is a huge benefit to using these libraries. They're statically typed, they use C internally. If possible, push it into a NumPy array and do the processing there, rather than you ever doing a loop. Loops are slow, functions are slow. Right. This can be applied in a wide variety. Okay, now I'm going to skip this example. Skip this. Let's take another example. Now, one problem that we often face is, supposing I have an array of numbers and I want to see how many numbers are between some two values A and B, okay, where A and B are any two arbitrary numbers. One way of doing that is to loop through all of the values in the list. If the value is in the range A to B, then increment the count by 1. Now that's taking us 284 milliseconds. So reasonably slow. Let's use vector operations. If I took the same thing, the values are in a vector, and I say all the values that are greater than or equal to 0.25 and all the values that are less than or equal to 0.75, whatever my range is, sum it. This one line expression is 7,629% faster. In other words, 76 times faster. Total no-brainer, right? So if you're getting a 76 times optimization in something like this, you'd say, wait, that's crazy. And now we're at 3.67 milliseconds per loop, which is perfectly acceptable. You'd normally stop there, and I would advise that as well. But do not ever make the mistake of assuming that that is the fastest, because see here you can remember that if I sorted an array, then it becomes very easy to find out how many numbers are between A and B. You just see where A occurs and you can do a binary search for that. You can see where B occurs and do a binary search for that. And this can be done in a vectorized way using a function called NumPy search sorted. So you sort the values, and if it is a sorted result, you just search for where 0.75 would occur, search for where 0.25 would occur, and find the result. And that's 5 microseconds. In other words, 73,332% faster than the previous one. So what was already 76 times faster has further been optimized by 733 times. So now I can't do the math that fast, but we're like, a few tens of thousands of times faster than before. The best optimizer is not the library, it is what resides between your ears. The better algorithm invariably wins over a more optimized execution. Okay. But having said that, it would be useful to see how one can go about writing these things in C. Now, if you're like me, you would rather not have to learn or relearn C. Python is fairly easy to learn and you'd rather keep it that way. So the question is, can I write Python code and somehow get the benefits of C? And the answer is yes, and there are many ways of doing that. Cython is one such project. What Cython does is lets you sort of compile in C. Now, you have to install Cython. There are many ways of installing it, but the easiest way is to pick a scientific Python distribution like Anaconda or Canopy or Enthought or Python XY or whatever. And in that case, you automatically get a C compiler on any platform, including Windows, which is what I'm running it on, and I have my reasons for that. So out here, for example, if you say in an IPython notebook, load the extension Cython Magic, any cell that has %Cython automatically gets compiled into C. Now, what I've done is taken a function that adds up numbers from 0 to n-1. So you loop through from 0 to n-1 and increment the counter and return the value. It's a simple sum function, which in Python is defined. And the same thing, the only thing that I've done is change the function name, put this in a %Cython cell magic, and said A is defined as an integer, I is defined as an integer. So we're just doing static typing on top of this. Let's compare the two. 6.6 milliseconds, 68.4 microseconds. So now we're talking 100 times faster. Same code, same algorithm. We've just added static typing and said run it, and that's 100x. And this is something that you could do to every single one of your functions. It's sort of like free optimization. You do need to know what the types are though. This does not work universally. Let's take the count, counting the numbers between a range that we had earlier, right? Same function where in an array of values, you're looking for how many are between A and B, right? Now here, we define this as an integer, define this as a float. Now this function is unfortunately only approximately twice as fast. You've come down from about 279 to 147. Twice as fast is still good, but not the 100x that we saw earlier. Let's take another project, Numba, I don't know how to pronounce it. I'm going to say Numba. This is better for a couple of reasons. The first is that you don't need to worry about the types. It does it automatically for you. You just install it and then say from numba.decorators import JIT. That stands for just-in-time compilation. And then you say @JIT any function. So I'm taking the same total function, which was the identical code that I'd written in Python, not modified it in any way other than to change the function name. And now let's time it. Python is in milliseconds. Cython is in microseconds. Numba is in nanoseconds. So, and I'm not even going to bother doing the computation, but it's more than few tens of thousands of times faster than the original Python. Closest piece of my code you'd move on. But this is sort of like a free lunch. Take it. Let's look at how it optimizes the other piece of code which Cython struggled with. So out here, we are doing the count function, exactly the same code as in Python, but with a @JIT prefixed. And now it's gone down from 283 milliseconds to 2.91 milliseconds, almost a factor of 100 improvement here. So in other words, Numba doesn't need you to know the types, it figures it out by itself, nor does it, and it's faster as well. So increasingly, it's replacing Cython as the way of optimizing code. Now, what have we seen so far? If I were to do a summary of what we've looked at. Firstly, check if you really need to optimize something. If it's fast enough, don't bother. Just stop there and move on to whatever is a slow step. If it is not fast enough, then just find out what the slowest step is and focus only on that. At any point, optimize only one piece of code. And in order to do this, you will need to have solid unit tests, because no refactoring works fine. You never know when you have screwed up on the functionality. Make sure that you have solid unit tests running. There are two ways of reducing the total time that it takes. One is reduce the number of times a piece of code is executing, reduce the number of hits. This is obviously a better way of optimizing, because if you get it down to 0, you've just completely done away with the whole thing, right? So that way it helps. Now there are many ways of doing it apart from algorithmic changes. One, if you can cache the result and memory is not a constraint, that gives you one boost of speed. Secondly, make sure that your operations are executed only when required. Like we moved the if condition outside where we split it. We split only if the constituency was Bangalore South. Like that, try and minimize the number of computations that you're doing. The next way is to make the slow operations faster. There are many ways of doing it. Firstly, try and see if you can replace functions with operators. See if you can replace for loops with list comprehensions. Try using Numba or Cython if you want to go in for something that's C based. Most importantly, see if you can change the algorithm. This has the second biggest impact of any method. The biggest impact obviously comes from completely eliminating that code base. See, remember, code is a liability. It is a functionality that is an asset. If you reduce the lines of code or eliminate the code completely and still achieve the same functionality, that's great, right? You have what effectively sort of negative infinite productivity or something like that. Get rid of as much of the code as you can. That in itself will reduce the number of opcodes and therefore the total piece of code. Okay. Hope that was helpful. Open to questions. Thank you.
So why are you really trying to optimize the parsing part? So how many times you want to run it?
Sorry, come again.
Why are you really trying to optimize the parsing part? I think parsing is typically done one, you pre-parse the data and then put it in some form and then you reuse it again, right?
True. There are two reasons why parsing had to be optimized. In a lot of cases, we take the data, process it once and move on to the next step, effectively batch processing. Secondly, in this particular case, 20 seconds was not too bad because it's a one-time setup. But when debugging, we run it so many times that every time a startup of overhead of 20 seconds is way too much.
Okay.
How does Numba compare with PyPy?
How does Numba compare with PyPy? I haven't done the benchmarks yet. My problem is I cannot go to PyPy because I use pandas. So this is a constraint. I have never evaluated PyPy, nor am I, for those who are not aware, PyPy is Python in Python and it's pretty fast. I have never been able to use it because I need NumPy too much. And NumPy uses C.
The thing I found interesting is that this has been my barrier with PyPy as well. There's always going to be some random library that has not been properly tested, doesn't work. And what this sounds like is I have a free ticket here. PyPy kind of speed without using PyPy. And that sounds a little too good to be true. So I'm just wondering what the quirks are.
I'm also a little scared to use it in production. Give me a few months, I'll share notes. No, the reason I'm scared to use it in production is simply because we haven't tried it enough. Numba is this fast fairly recently, and I haven't found a negative overhead. And even if it's easy enough to sort of benchmark and see which functions you apply Numba to or not. From an environment and distribution perspective, given that Anaconda and other distributions exist, it doesn't seem to be a problem. So I'm going to start using this in production from pretty much a couple of weeks from now. See where it goes. But it's got to the point where I'm comfortable enough talking about it and deploying it at a client side.
Yes. When you were optimizing parser, there could have been a step where you enumerate the counts, because anyway count is a one line that always comes up all the time when you are counting through the loop. So does enumerate help out? Does enumerate help out? Well, firstly, without taking my answer as a given, try it out. Okay, it's easy enough. Yeah. The thing is, now what does enumerate entail? It creates a generator. Now a generator has a number of additional useful properties. Like in the middle of the generation, you can change, you can mutate things, you can stop the generation, you can throw an exception, all kinds of things. In a C loop, you can't throw exceptions. You can't mutate, you're fairly constrained. Now Python provides a lot of flexibility with iterators and generators, and with that flexibility comes loss of speed. As a rough rule of thumb, I always avoid generators, and wherever I have a generator, I replace it with a NumPy array. This is only when you're processing large scale data. There are enormous benefits of using it in other cases.
Let's assume you have a large number of elements, let's say 1 million elements or 10 million elements. How will you advise speeding up a lookup operation?
how will I, okay, if you have 10 million elements and it fits in memory, dictionary lookups are reasonably fast. If it doesn't fit in memory, an external dictionary lookup is fairly fast. Now what does an external dictionary lookup mean? Any key value store. React if it doesn't fit on memory, Redis if it fits in memory, memcache if it's dynamic. Any of these would be pretty fast.
And how will dictionary lookup will compare against a set lookup?
A dictionary lookup and set lookup have pretty much the same speed. Set lookup tells you whether it's present or not. A dictionary lookup also gives you an associated value. If you are only checking for presence, set lookup is always faster. However, if you are looking for something that only needs to be approximately right, you can do a lot better by using something called a Bloom filter. Just check that out. It gives you a good chance that the item is there. And then what you've done is use a very fast operation to test like 99% it's going to be there or not. And then to reconfirm, you can do a slow operation, which will overall speed up your process a lot.
Also, how much space does it take for dictionary and set? I mean, which one is better at space?
Dictionary takes more space than a set because you have to store the value as well.
Yeah.
Set takes more space than a Bloom filter because Bloom filter is approximate.
Oh, thanks.
I have a question. We using the NumPy array, and sometime I have found on doing operations, there's sometimes the list operation on the listing is fast enough than the using of the NumPy array, and sometimes the NumPy array fast. Can you resolve this confusion? When to better to use NumPy array than of listing, or when to use better to use list?
If we take a specific example, I will be able to explain it better, but let me give you my general observations. Whenever a NumPy array is used like a list, it tends to be a little slower. So if you create a NumPy array and do a for loop on it, it is invariably slower. Now, NumPy array is meant to, so when you have a NumPy array and you have a for loop in the same piece of code, then something is really going wrong. You never use, or not necessarily a for loop, any kind of loop. You do the whole purpose of, or one of the purposes of using a vector operation is to avoid iteration. So that is a clear giveaway that would be slower. Beyond that, there are very, very few operations where NumPy would actually be slower than a list. Let me give you one such. Supposing you are calling a function. So if you say numpy.apply of x times x. Now what you're doing is squaring it, and in order to square it, you're creating a lambda function. Functions are slow. So what NumPy does is loops through fast, but has the overhead of calling functions. The same thing, if you were to write as a list comprehension, you have no overhead of a for loop. You have no overhead of a function call because it's just x times x, it's an operator. And that can potentially be faster than NumPy. So if there's a function call or a for loop, those are giveaways that NumPy may not be able to, I mean, it's not structured well.
The functions are slower, right? In that case, is it possible for us to, in case of Python, generate a local scope for the function, or have the function object and then using it? How much it actually go along with other things?
Okay. See, if I have understood your question, and I may not have, it is the compiling aspect slow? Meaning, can I just pre-compile it? The objects are pre-compiled. The problem is not that it's not converted to C. It is converted into, well, bytecode, which is pretty fast. The problem is that Python offers a hell of a lot of flexibility. It allows you to, for example, raise an exception inside a function. In order to raise an exception, that has to be trapped and parsed in a certain way. There is a lot of type conversion that happens automatically. So as soon as you enter a function, the first thing that it does is looks at all the arguments that are coming in, looks at their types, sees if it needs to be converted. Likewise, at every step in every line, it does all of these things. So it is the reason why Python functions are slow is by design. Okay, unlike JavaScript, which was sort of not quite designed, and people managed to optimize their way around it dramatically. That is less easy in Python because it's designed to give a certain amount of flexibility that one cannot step away from. So it is compiled. You're saying let us create a function object dynamically and do it. Try it, you will find that that is not the main problem. The problem is really that if it is a Python function object, then it works fine. What Numba does is says, I'm not going to give you that flexibility. If it raises an exception in the 10th step, I'm just going to give up completely and not let you handle it the way you normally would. So it actually works by stripping down functionality, and that functionality can be used on a case-to-case basis, not if you were really, let's say, processing, or let's say you were scraping, you do need that exception in the middle of the for loop, right? So, but do try it out. I suspect that you will find that no matter how a function is created, it is slower than not having a function.
Hi. Regarding your suggestion to use hash instead of a cryptographic algorithm, isn't hash calculated at runtime, so it's not the same hash you will get if you restart the program?
No, it is the same algorithm, and if you restart and run, okay.
I thought hash is the memory location in which it is.
Right, but if you give a string, which is all I've ever given it, it is always the same. Yeah, it uses ID. Yeah, everything that I know tells me that it should be the same.
Is it? Okay.
Recheck once again.
Fine, thank you.
Regarding the earlier example of election data that you were going through, right? Some sort of where you are trying to search through different constituencies, right? And let us assume that the file is much larger, and processing is always going to take a few seconds to read out that file and data. Then a user would not wait for a few minutes to see what the data update is. Then is there a way to parallelly update your display and again keep processing the data in the background?
Absolutely. See, that gets into the realm.
Easiest example for that, but another faster way.
No, you don't need threading for this. So the question is, supposing the users made a search and you want to display something in the middle. Display something in the middle. So a number of libraries support it. So if you take Tornado, for example, you can have an async operation, and as it feeds the results, display them one by one. But even better, you don't even have to do that. You can put in any random junk. The good part about users is that no matter what you show them, they'll try and read it. So put some dummy results or some other interesting things while we are waiting, etc., and that will be a distraction. And then as the results start coming, you don't need to wait for it to end. You can put it up there. You can also recognize that people are often searching for the same thing. So once you get a certain result often enough, you start caching that. Further, you can start partitioning it. You say, like dictionary lookups, why should I have to search through the whole thing? If I'm searching for something that begins with B, maybe I could just split the data into things that start with A, things that start with B, and so on, and only search within B. And then if you take that concept further, well, more like creating an index. And then when you take it to its logical end, you will have a database index. At which point, so it depends on how far you want to go to speed it up. And the ability to serve something in parallel is independent of data processing. It's independent of speeding up data processing. It's sort of a way around it, which is a perfectly valid and useful one.
I think we've done with questions, so we'll take more questions offline. Thank you so much, Anand, for the talk. We now break for lunch, and at 2 p.m. we'll be having panel discussion. The topic for panel discussion is web frameworks. So we have 3 web frameworks that will be discussed by the panel: Django, Flask, and Web.py. So be here for an interesting and amazing panel discussion. Thank you.
can you guys please shut down your hotspots, please? Wi-Fi hotspots, please.
He called me.
Guys, do a quick mic check since we've had some mic trouble in the conference. Can you guys in the back hear me? Just raise your hand if you can. No? Can't hear? They can't hear in the back. Check, check, check. In the back. Not yet. Upstairs, can you hear? Guys, upstairs, you can? Yes? Okay. Upstairs is fine. Guys in the back, down here, can't hear. Not yet, right? No. They can't hear. Guys in the back are unable to hear. Any better? Any better? Yes. Yes. Better. Good. Good. Yeah. Good. Good. Everybody good? Okay. Okay. Another quick mic check. I think this is louder. All good. Much better. This one's good. All right. Hello. Hello.
Okay, does this work? Hello? Okay, it seems to work. This should be much better, right?
Hello? This thing just...
Okay, yeah, now.
Hello? Yeah.
What is the middle state?
Mute.
Mute. Okay.
It's very confusing. Guys in the back, you can hear me, right? Okay, sounds like you can.
Yeah. Guys up on the...
Bit louder?
Yes.
Yes. This is better. Okay.
Upper one goes straight, lower one goes... No, it's not working.
Check. Hello.
everybody. How you guys doing? Good, nice, big lunch. How's the food? Good? Food's been amazing, right?
I'm stuffed.
Should have a little aerobics routine before we start this, just to get people to shake up a little bit. Where is Harris? People who saw him dance yesterday would vouch for that.
Yeah.
So he's coming, good. So just a quick poll here. How many people here have heard of or are familiar with Flask, Django, Web.py? Excellent. This is great. So we've got a large group here of people who are into web. So hopefully we'll have a very exciting discussion here, passionate discussion. One thing I want to mention is, since we only have 45 minutes, we've also blocked out time in the open space on the first floor for 4 to 5. So after we finish this discussion, we'll still have time in the open space to sort of dig into more details or even talk about other frameworks and anything else that we'd like to cover off, which may not happen in this 45 minutes. So let's just give it another minute. It's almost 2, and then we'll get started. Alright, it's 2 o'clock. I think we're good to get started. So guys, let me quickly give you a bit of background about this panel. Last year I gave a talk on Flask. Arun out here gave a talk on Django. We both had a number of questions around Flask and Django and choosing the frameworks and choices. And we thought it'd be interesting to have a healthy debate discussing a few of these frameworks and to understand some of the different trade-offs that are involved. Now, many of us are passionate about these frameworks in different ways. Although ultimately a tool is a tool, it's good to understand the nuances a little better. So we have structured this discussion in a debate format. And I'd like to introduce the 3 panelists that I have here with me. First here, this is Kiran, who's well known around here. Kiran spoke earlier yesterday. Kiran is going to be representing and evangelizing Flask. Kiran at HasGeek has been using Flask for the last several years now and catering to a fairly large user base. He's also been having a bit of a midlife crisis with Flask. So he's going to be sort of bringing up a few points where he's not as happy with Flask as well. So you'll hear a bit of that as well today. And then there's Arun, who's all about Django. He's Mr. Django. He spoke about Django last year. He spoke about Django advanced patterns this year. And he's an industry recognized expert in Django. He's coming out with a book which is going to be published soon on Django advanced patterns. So we're again fortunate to have him here representing Django on this panel. And finally we have Arun Anand. Anand is representing Web.py. Some of you who were here yesterday evening might have attended the video on Aaron Schwartz, the story of his life. So Web.py's roots, and I'll let Anand, I don't want to steal his thunder here, but Anand is a co-author of Web.py and he's collaborated from the early days with Aaron Schwartz. So here's a story I think we'll hear from someone who's been there from the early part as a co-author of Web.py and currently being a maintainer as well of Web.py. He collaborated with Aaron Schwartz on the Infogamy and Open Library. So that's a bit about the 3 of them. I'm Arvi, I'll be moderating the discussion. And with the format, we'll go through a series of 3 rounds of discussion which will hopefully cater to beginners, intermediate and advanced users. And like I mentioned earlier, beyond that, we'll take some discussions over to cover them off in the open space. So 3 frameworks, 3 evangelists, 3 rounds of debate, and we'll accommodate time for about 3 audience questions, maybe a little more time permitting. And I'd encourage you, if possible, to send in questions via the #PyCon India Twitter hashtag, if you can. If not, there's Grace and Konarak. The 2 of them here have coordinated to set up paper slips over here. I think there's some paper slips here, and Grace, are there? Where else are they kept? All the paper slips are kept here. So if any of you would like to just put down some questions in the interest of time, just put them down on the paper slips. Grace and Konarak will pick them up and then read out some of the questions toward the ends during the Q&A. So don't hesitate to just come up, grab a slip anytime during the discussions and put them down there. So with that, and just one last little thing, we're going to do a round of voting at the end, just a little fun session of voting via Missed-Call voting app. You'll see a bit more of that at the end. So the first round of discussion is going to be around this question that I often hear from beginners, which is, I'm a beginner, which framework should I start off with? Which framework should I pick to start off my project? I have a new project or a new thing that I'm trying to take up. Which one should I choose? So I'm going to start off here by asking Anand, why would you endorse web.py as being the framework that someone should choose for starting off if they're building a new app?
Can I ask you? Okay.
Yeah, I think web.py is good for beginners because it's the learning curve is very simple. It's not difficult to learn web.py. So web.py is a simple Python library. I would say any micro framework is good for beginners. Okay. So and I think web.py is pretty good because you can also develop database applications pretty easily using web.py.
So Kiran, we hear the same answer that Anand just told us about web.py, about Flask all the time.
Yes.
So what's the difference here?
Both of them are fairly good to start with. I would put Flask as slightly better than web.py for this, although this may have changed recently. Earlier, web.py would be much easier to work with. You simply import web, and then you declare your routes, and you declare your functions, and you're pretty much done. Now, I've had concerns with that approach because it basically treats the web module as a global for the application. I believe that's been fixed. It's you now create an application context, which is also what you do with Flask. The thing that I think Flask has slightly better going for it to start with is a decorator-based approach to declaring routes. In WebPy, you create an array of your routes and the regexes that handle these routes and so on, and that can be a little confusing once you go beyond the 3 or 4 that the example gives you. The point you get to the 5th or 6th one, it's a little unclear how you're supposed to be doing this. Flask, wisely enough, does not use regexes for routings. It basically uses slash separators, so it's able to actually sort them no matter what order you declare them in. It'll internally sort them to find the appropriate order.
And so Anand, what do you have to say to this?
So I think when you look at WebPy, you understand what's going on completely. Okay, but with Flask, decorators people kind of get confused, especially for beginners. They see that like some kind of magic. You just have to put that and it works. Okay, that's something I really don't like very much about that. Okay, and I really like decorators and now they're being used. It's a very nice API, but especially for beginners, it's a bit confusing.
Although I would say that for beginners, lots of things tend to be confusing. What's important is that you have a consistent API. That you know that this is exactly what it happens when you do this, and that there is no magic involved in it doing something else unexpected all of a sudden. And once you get past that point of comfort, then you can start digging under the hood to see how did that actually work. Flask routing is not trivial at all once you get under the hood. It's the URL map that it uses is fairly complex. I've been doing Flask for about 4 or 5 years now and I still don't understand how it works. And I can tell you this because I have a bug report of something broken that admin has not been able to fix. And it's been 2 years since I reported it.
Nice.
So Arun, do you want to jump in here? How does Django fit in this world where you have micro frameworks around you?
Django is like the elephant in the room right now. Staggering to compare that. I think Django wins in a lot of areas. Documentation, it's like the most well-documented web framework out there.
So qualify that, because everyone here is going to say, yeah, we've got the best documentation.
Let me qualify that. So it's going to have, in terms of a very good tutorial. So most of the time when you ask, okay, I want to learn X, Y, Z, where do you go to? For Django, the answer is very easy. Just go to the official tutorial and you'll learn it. Initially it was just 4 parts and I think now it's 5 parts including test-driven design and all that. So I think it's very beginner friendly and the community is great. In fact, if you ask any
question, if you just type it on Google, you'll probably get the answer on Stack Overflow or anywhere else. There are about 30 odd books on Django. They tend to get outdated very fast, so that's a bit of a problem, but people are writing new books all the time, including me, of course. And there is, I would say I'd throw this in, I mean, there are a lot of opportunities for people who learn Django in terms of jobs and stuff. That has been increasing over the years, and I think there is a clear trend for greater and greater jobs. So if you're a beginner and you want to focus on something, probably that's one criteria you can think about.
Yeah. It's interesting. Someone on Twitter, Arunatma, has said, same site goal by Kiran and debate, goal for web.py. So any comments that you want to quickly chime in on with respect to Django?
Please repeat the question.
Someone on Twitter, Arunatma, has said, same site goal by Kiran and debate, goal for web.py.
Oh yeah, he basically means that I'm bitching about Flask already. There's plenty of bitching about Flask coming up. Okay,
so I would like to add one thing as well. Is back in 2006 or 2007, I was really desperately looking to learn web frame programming.
Hold it vertical.
Using Python. Okay, so I went and attended a training session on Zope and Plone, and I sat through 3 days and I couldn't get anything out of it. Okay.
I can understand.
And then I looked at what else I can do. When I looked at Django, I started trying to learn Django. I mean, it takes so long time to actually get started on something. Okay. And it was that time when Aaron George released web.py, and I tried writing a program and said, that's so simple to use. Okay. That's how I got hooked into web.py.
Great. So what do you guys think? Little confused? Well, it felt like they were saying the same things on a few points but differing a little on different points, right? But so let's just step on a little more and see how things get a little more interesting for people who have been using some of these frameworks for a little bit. Your code base evolved, it's kind of nice, you've got a small micro framework, things get harder, and things are not opinionated, it gets a little more complex. So let's say it's someone who's built slightly complex sites or backends, right? And they want to know, how do you architect and design your apps as they get more complex, and why is your framework best suited for someone whose app is either gaining complexity or someone who's trying to build a new app which is slightly complex? And I'm going to start here with Kiran.
Okay, so one of the things that Flask acquired slightly more recently is this concept called a blueprint, where you separate out part of your functionality into something that's not quite an app but behaves a lot like an app. And you can plug it into an app and you can reuse it across modules and so on. I've been using that quite a bit to restructure a lot of my apps into multi-component pieces, where you can optionally turn off a component that you don't want at runtime, and just say, just don't import that if you don't want it. So if you guys have been looking at the last user code since yesterday's talk, it's basically built as a collection of 3 blueprints. I like the approach. It makes it really easy to modularize your code. And the other thing is that Flask is fairly hands-off when it comes to telling you how to structure your code. So you evolve your own conventions after a while. I have now a skeleton that I use across all my projects, and that's something that is a skeleton I've evolved after realizing that this works for me and for the kind of apps that I write. But this is not a skeleton that Flask gives you. It's not like Django where you make a project and the project then has an outline ready-made for you. In this case, you do it yourself, and you get all the flexibility you want when you're doing something like this.
Yeah, regarding blueprints, we have been having that in Django for a couple of years now, so we call it apps. So I'm glad that the Flask is catching up. And to the second point, I would like to say that it's good that you have evolved your own style, but how about handing it over to another developer? I mean, when it comes to Django projects, it's very easy to find out. For example, there is an exception at accounts.views.something, and immediately a Django developer understands that, okay, accounts is the app, views is the model view controller view, and there is no need to really explain what it is. So when you roll your own, that comes with the problems of understanding what your design decisions were.
Yes, and when somebody rolls it for you, then you have no control over it, and that's even more problematic.
Okay. No, I think that's a trade-off we are talking about here. So when you start a Django project, it's already built for scale. So it's like you're already talking about models being separated from views, being separated from templates. I mean, I built a Twitter clone in Bottle, And I thought it was great until I started writing hundreds and hundreds of lines of code, and it's like a nightmare to organize it. But it's not really a problem when it comes to Django, because you know where things go. It's like a kitchen shelf where everything is neatly labeled, and you just have to put things in the right place. That's all you have to worry about.
Alright, so Anand, do you want to throw the kitchen sink at this?
Yeah. So WebPy is not a framework; it's a library. Okay, so it doesn't ask you how, it doesn't tell you how you should do things. Okay, it tells you these are the tools that you want to that you can use in writing a web application. Okay, so one thing about Django and also slightly Flask is they kind of there are ways of doing things. You should do, this is the way to do X and this is the way to do Y, okay. But with WebPy, there's just a set of tools that you can use to build your stuff, okay. So when you're building slightly large applications, it's all about your discipline, how you want to organize stuff.
Any thoughts on that you'd like to add, Kiran?
Yeah, it's more about what kind of application you're building. If it's like a web server embedded inside your huge application, then probably you don't need to worry too much about, the model view, controller separation and stuff like that. So I'll call them toy examples, if you like to say it. I mean, it's more like a simple thing which can fit in a couple of lines. So in the Ruby on Rails world, they have this thing called Sinatra, which it's very easy to read. In fact, even the HTML code, the CSS, everything is a part of one file. And if you are really having a web application that just fits 2 screens or 3 screens, then you probably would like to go for a library approach. You don't really require a framework.
Yeah, so I'm not saying WebPy doesn't give you anything. Okay, so it has a database module. You can keep your database thing separately. It has templating engine. Okay, so you have all these things. Okay, but it doesn't enforce you that you have a view.py, you have notice.py, you have something, and that's the way you structure your code. Okay, but you still can structure your code in all those ways, and it has tools for doing it.
And Anand, do you want to comment about ORMs? I think this is a very opinionated topic.
Yeah. So I should go first before this. So I used to use web.py before Flask, and I still have production software running on web.py. I stopped using it because of the ORM, or the lack of one. So
okay. So so I've tried to use SQL Alchemy so many times and then failed. Okay, it's so hard to get something started. At least probably I'm not smart enough to get it, but
modesty there.
So really, I mean, I've tried so many times and then gave up. Okay, so I find it very hard. One thing. The second thing is with WebPy, you write SQL. Okay, you talk to database in the database language. With SQL Alchemy, you talk to database in SQL Alchemy language. Okay, and
that's true, man. You can write SQL in SQL Alchemy. It's perfectly happy to accept it.
So, so again, very hard for me to. I updated the SQL Alchemy version and then started filing. Okay, because it's many-to-many mapping or something. They have changed something. Yeah. So well, what I want to say is when something fails in SQL Alchemy, SQL Alchemy stack trace. You don't know what's wrong with your query. It's very hard to fix.
I'd like to pitch into that. Probably SQL Alchemy is the best ORM among the three. I mean, it can handle multiple databases very well, legacy databases very well, but it's damn hard to use, right? I mean,
it's a tank.
Yeah, it's a tank, right? So Django ORM goes for the middle approach. I mean, it doesn't try to do everything for you. You'll have to step down to SQL when it comes to complex queries. But for those 80-20 principle people, it's the 80% use cases which are handled by the Django ORM very well. And for 20% of cases, you always have SQL. You can step down to raw SQL.
So on that, here's a question from Twitter. A couple of people have asked, which is, how does Django play with NoSQL databases? Because it's often perceived to not play well. A couple of you guys have asked that. Why don't you answer that, Arun?
Yeah, I mean, it's not one of its strengths. But see, the way Django is designed is that it has to have a database built in, specified in the settings. So you can't use a NoSQL database there. You have to go with something. But having said that, there are a lot of Django projects which uses Redis, MongoDB, or even the Google Bigtable and things like that. So it's not impossible. It's just a matter of not being the philosophy with which it was built for.
So it was built then for relational databases.
Yeah, I would say.
And how's its performance with relational databases? What would you say about that?
I mean, again, it was built specifically for PostgreSQL, right? So that's where the best performance you'll extract out of it. And coming to the specific question of performance, it has powered one of the largest sites. It is the backend behind Discuss, which is a real-time commenting engine. It is the backend behind Instagram. So I don't think you will reach a point where you'll be suffocated by the performance issues.
And do you guys want to chime in, Anand and Kiran, about performance of your
I'm not sure that's entirely true, because Jacob Kaplan-Meier is known to use SQL Alchemy when Django ORM doesn't work for him. And he's the guy who created Django ORM, and he admits this publicly. Right. So if the creator of Django ORM says it's not good enough for him, it certainly is not good enough for the rest of the world.
Come on.
Well, I would say ORM is not good enough for anybody.
Yeah, so I mean, ORM is a leaky abstraction, right? There is no perfect ORM which can replicate every SQL scenario. At the end of the day, there will be some 10% scenario where you have to step down to SQL.
Yeah, so this is the part where I really like working with SQL Alchemy, because it's not a framework, it's a library, to use a cliche. SQL Alchemy lets you work at the high level. You want to use the ORM, use it. You want to draw a SQL, use it. You want to use SQL constructs as functions and basically build a query out of it, you use that. And the best part is that internally everything works the same way. If you talk to the high-level API, internally it talks to the low-level API. So you can bypass the high-level API, talk to the low-level API, and you get back a result object exactly as you would if you talk to the high-level API. And that's beautiful, because it basically means that I do not have to worry about saying I'm going to actually ignore all of this and go talk raw database and then deal with raw data coming back from the database. You don't have to worry about that. It comes back the way you expect it to, even if you had used a high-level API. And that's an advantage that I've not seen in any other library. This is basically what makes SQL Alchemy's learning curve so high, because there are a lot of times you'll find yourself saying that you want to step down into something a little deeper, and you'll have to figure out how to get to the deeper part, because SQL Alchemy's documentation is endless. I've never ever had to look at SQL Alchemy's source code to figure out how anything works. Everything that you want to know is in the documentation. If it's not in the documentation, go to Stack Overflow. Michael Bayer himself will come and answer your question for you. And that's remarkable. I've never seen a project owner that open to answering any kind of question that anybody throws him at any public forum. And in general, there is always an answer with SQL Alchemy.
Anand, you've been waiting to say something here, so I should take over.
And that works
in theory but not in practice. So the issue is you have to define your table schema.
It's gone off.
It's on.
Yeah.
It works in theory but not in practice.
Can you change his mic?
Yeah, I'm saying it works in theory but not in practice because you have to define your table schema. So I recently started with the SQL Alchemy project and decided I want to add a JSON type. So since it loads, when you do select something on a table, it tries to get everything, okay? So it fails somewhere else because it doesn't know how to convert JSON to something else.
You can fix the problem.
So I'm saying you can fix it, okay? So the thing is, the problem is not with SQL. Okay, so I really want to fail. If I fail, I want to fail in SQL and I can fix my query.
So
okay.
You can fix it as a part of the standard API, because this is one of the things that most people stumble upon the first time they use SQL Alchemy. If you do not want to load a column, you simply declare it.
So that's
okay. Would you really say it's beginner friendly? I mean,
it's not. It's most certainly not beginner friendly. That's for sure.
So one problem with SQL Alchemy is it makes me feel stupid. Every time I get something, it makes me feel stupid because I get in some trouble or other every time. Also, have you ever tried caching SQL, work with caching in SQL Alchemy?
Yeah.
How hard it is?
It's documented.
See, it's again making me feel stupid. So I wrote a small caching library for an app that I built. Okay, it took me 40 lines of code. It cached everything, all the database results. Now I'm building the app again. I thought, let me try using Flask and SQL Alchemy. Okay. Now I have no clue how hard it's to build caching for it.
So it's not obvious how to do this, because this is the part where you start to get intimately familiar with SQL Alchemy's internals. Mind you, without ever reading the SQL Alchemy source code. I've never done that. There was only one point where I had a moment of weakness and trying to figure out something that's not in the API, but I wanted to know how it works. So I went to look at the code, and I came away enlightened for that, and now I use that pattern in my code as well. But in general, I found an answer to any kind of problem I've ever had in SQL Alchemy by just looking at the documentation. It's all there. It's just so intense. It's like a book.
Yeah, it is.
Just to quickly move on to a couple of the questions that are coming on Twitter. A few people have asked about how your frameworks deal with enabling people to build REST-based backends. And yeah, why don't you jump in quickly?
Yeah, I think Django REST framework is considered to be a gold standard when it comes to how well it models a problem domain, which is like models, and it maps very correctly to the API. So at the end of the day, we are all talking about SQL and all that, but I think we should talk about Pythonic code. And when it comes to Django, they are trying to create as simple Python objects as possible, I mean Python syntax as possible. There was a branch called removing the magic, in which they removed all the magic from Django. So I would consider Rails to have a lot of magic, but Django is very simple, straightforward Python code. If you create a Python class which declares declaratively specifies your database schema, you're good. You can actually create REST APIs out of it. You can create forms out of it. You can create generic views out of it.
Great. So you're saying Django provides much better support for people building REST APIs. It's opinionated in some ways, but things are well documented.
It's very Pythonic.
Very Pythonic.
Benevolent dictator for life has blessed Django. So among the web frameworks, I don't know if his opinion still holds good. He said about 3 years back that Django is the preferred. Guido prefers Django as the web framework.
So Anand, what about web.py and REST? How is it?
So one of the testimonials of web.py is with Django you write web application in Django, with web.py you write in Python. Okay, so it doesn't come on your way at all, just a library. Just like you import any other Python library, you import OSS, you import web and start working. Okay, it feels as natural as that.
Yeah, but what about building larger applications? How does that scale?
I think I've been building pretty large website to prepare. I don't think I have any issues in that sense.
Okay. Because that is one thing I want to talk about in the first round. There are a lot of beginners out there who think that it's great to learn a micro framework and start writing code and understand the entire flow. So I understand in Django it's not very easy to understand where the flow of control flows, since it's spread out over a lot of files. But it actually helps you all the way till the end. Building a production site. For example, I have struggled a lot with SQL injection problems and all sorts of security problems because I didn't know what the hell I was doing when I was simply getting user input, and I was just trying to put it in a database by using SQL. But it so happens that doing that is a very, very bad thing. You should not use user input directly into your database or into your templates, so on and so forth. So all those good stuff is already baked inside, so you don't make those mistakes.
So guys, tell me one thing. So with something like Django, which has been around for a while, appears to have a sizable community. When you're growing your app and you start to have a large team around it, there's the argument that with Django it's easier to find new developers, bring them into a project at any point, plus there's an existing batteries included platform you're working with, whereas with micro frameworks like Flask or web.py, where in your case, Kiran, you build up a lot of boilerplate on top of that to support a bunch of things, then you get a bunch of new people into your team and they have no idea because things are different. How do you deal with that with a micro framework or even a library like you call web.py?
So in general, no matter what you do, you will have an onboarding process for anybody who comes on board, and I don't think any of us has a corporate environment where it's onboarding free. You have to onboard a new person, not just for the framework but for your own code. The code that you have may be IP, may be not public, which is the case for most of us, and therefore you don't even have an option to show them the code and how it works until they come on board. You can't do this before they join.
Arun, what do you have to say about that?
I think Django really wins on this because it's very easy to get people who are trained on Django as well as understand the source code. Unfortunately, there was a lacuna when it came to large projects which are implemented in Django. But python.org, the official Python website, is open source now and it's a Django project. So anybody who wants to see how a large Django project is implemented can just go and see that. So you will find that it's very comparable to the initial Django project that you create and the large Django projects which are out there.
And Anand, in this context, we're talking about a library here, so much more boilerplate on top. With a large team, how would you manage that?
I don't have an answer for this because I've not worked with any large team with web.py.
Alright, I'll treat that as a white flag being raised there. So. Cool, so with this, I just want to step forward to look at the future. Like few questions that people in the audience have asked is, what about Pyramid? What about other frameworks that are out there? So I just want to step forward. I mean, these are the guys out there who are saying, no, I'm too cool for these kids using Django and Flask. I'm on Pyramid or I'm on Tornado or Twisted. You guys are out there. I've seen the tweets. I know it. So for you guys out here, I want to sort of just look at the future for a minute here. And I'd like you guys to talk through, and you don't need to support just your framework. Feel free to talk about what you think the future might be. Which frameworks do you think have the most promising future, given the direction of Python, async, REST, WebSockets, other things that are happening out there? And what else do you see that's out there that's emerging that people might need to start to look out for or watch out for?
Inside of Python?
Inside of Python.
So with Python, I think if you look at the cleanest architecture of any framework, it's Pyramid. It's a pity that not enough people use Pyramid. And one of the reasons Pyramid is so good and so complicated is that it's like SQL alchemy. It gives you everything. It's up to you to decide which parts you actually want to use, and that's a little too overwhelming for a lot of people, to start with. But Pyramid is a lot more loosely coupled than Django is. In Django, you get a lot of things that you may or may not want to use. For instance, Django templates for a very long time were known to be really poor at performance, and Jinja 2 was created by someone very upset at Django templates performance, and it's been a while until Jinja 2 became the standard templating system in Django. If I'm right, that's what it is now.
No, it's not.
It's not yet. It's an optional.
You can
module.
replace it. Yeah.
Exactly. So it's one of the things you deal with when Django is you get all of these parts and you do not always want them. And then it's a lot of work taking them out of Django and saying, I don't want to use this particular part of it. Pyramid, on the other hand, is very nicely designed. It's also, and this is one of the advantages that Pyramid has, is that the person maintaining it, Chris McDonough, does this full-time for a living. With Flask, on the other hand, Armin is not a Flask developer full-time. He works at a game development studio. His life passion at this point is making games, not maintaining Flask. And this shows in the maintenance quality of Flask that it may be beautifully designed, but it's got a maintainer who basically is interested in doing this on his weekends, not as a day job.
Probably you should say that it was started as an April Fool's joke. So
yes. So for something that started as an April Fool's joke, it is remarkably solid. Yeah. It's simply got a maintainer problem.
People took it seriously. Yeah.
So, what do you think, Anand?
Coming back to the problems of Django. So there is a real effort to remove all the non-essential parts out of Django. So comments have been removed. A lot of things which are not essential to Django, or if you know Django, it's called contrib. So a lot of things will be removed in the future as well. The maintainer has explicitly stated that, hopefully not admin, which is considered to be a USP, but a lot of things which are non-essential will be removed as external libraries which you can optionally use. And the future of Django is more in terms of how people define it. I actually wrote an article about, I was totally wowed by Meteor and JavaScript, so I thought async is going to be the future of web development, right? So everything is going the async way. But and Python has this real problem of WSGI, which is underlying for all three of us right here, right? So WSGI is the underlying thing which works in the bottom, and WSGI is not really designed for async programming. But Guido is working really hard on that. He is trying to create, even Python 3 is effort towards that direction. So I believe Python web frameworks in general need to start thinking in terms of asynchronous programming. Of course, for the majority of the sites you get to build, they are not the cool sites, right? I mean, there are the CRUD sites which are the majority of the work we do, and they actually require some kind of synchronous programming just to keep yourself sane. You know, asynchronous programming can get really complex to fit in your brain. But most of the time you find that there is a real-time application need for every application, for every use case you build. Even a social network like Facebook, suddenly when a pop comes up, a notification comes up, that makes the experience so much richer.
Right.
And everybody can do that.
So on this, do you see more people moving away from necessarily using the delayed worker architecture, which we currently use, the Celery or RQ,
Yeah.
to maybe using, there's this other assembly language of the web-based framework, which lets you do everything async?
Right.
Is it likely we'll...
I think
move more-
WebSockets and technologies like that changed everything. So earlier it was a polling-based technology, and everything was synchronous actually behind the hood. But now we have real async. So like you rightly pointed out, Celery is an asynchronous queue, but it's not really happening in the request response cycle, right? So there needs to be a real rethink from ground up how we can handle the request response cycle bidirectionally, especially when it's coming back when you actually send something.
Yeah, I'd actually be interested in seeing approaches like Celery and RQ given less priority than they have right now, because Celery and RQ can bring in their own idiosyncrasies to your project that can catch you by surprise, because you're not affected by them until you're in production, and then it becomes much harder to figure out what just happened and why did this thing stop working. It'll be nicer to have async within a request response cycle instead of pushing it outside, because that puts it in a place where it's much easier to debug when something goes wrong.
And is it easier to debug? Because if you look at the other side of the world, outside of Python, where these guys are running these apps in that assembly language of the web thing, they constantly have to restart the servers because of all those issues they have running everything in the request cycle.
Yeah, so I would say more than that, it's to put processes to deal with the various aspects of this process, and that just makes it harder for me to work, because I'm constantly tempted to say, if I need to fix something and I'm right now not in my development environment, then I'm going to not bother running all the 4 servers to make sure that the patch I made just works. I'm just going to assume that I know how to write without writing a typo and push it straight to production and let production deal with the breakdown.
Basically, too many moving parts.
Too many moving parts, exactly. And occasionally production breaks down because I did make a mistake.
So just one last question. If you guys had to place a bet on a framework for the future, which one would it be? It doesn't need to be any of the ones that you're endorsing. If you had to pick one, or is it something which you think has not yet emerged?
So
I'll let Anand go first. Anand?
I don't think I have an opinion on that, so let Karen go on that.
So I'm going to put this between as a race between Pyramid and Flask. Flask wins because it has much cleaner documentation, much easier for anyone to figure out how to do things. Pyramid wins simply because it has better maintainers.
How about you, Anand?
I would put it on Django, obviously, because not because I'm talking about it, but because of the community. Because if you look at what is the success behind Python, Python is by no means the best programming language in the world, but I believe it has one of the best programming language communities.
Yeah.
So I think that is a strength behind Django as well. So a lot of criticism, I didn't address that directly, is directed at what comes with Django. But Pyramid goes for the best of breeds approach, and Django comes with batteries included approach.
As well.
But it's not necessarily true, right? You can remove some of the batteries and put in whatever you like. It's incredibly flexible that way. In fact, at DjangoCon, they did that. So,
Anand, you're about to add something?
Yeah. So it's nice thing when the good thing about Python is community, but also is one more, it's incremental. I mean, you can start learning with the basics and then you can go dive deep as long as you want. Okay. And I think that's true again with web.py, but not other frameworks. So it's pretty hard to get a grip of what actually happening inside with other frameworks. But WebPy is very simple to understand what's happening inside.
And I have to just add in here that I ended up looking at some code, the code behind Python Express, which all you guys are familiar with. Anand is a vision, is an initiative which he's pushed along. I ended up looking at it to push a little, I sent in a pull request with a little fix. It took me very little time to figure out Anand's code using web.py and jump in there. So guys, impressed yet? Yes? No? Yeah? So ultimately, right, one thing we want to bring out here is the whole objective of this thing here is to show you that frameworks are ultimately a tool and to bring out the nuances of the choices. And there's no right answer one way or the other. I do want to sort of open this out now, however, for audience voting. And these are the 3 numbers that you can call. And hopefully my network is going to hold out and we can see something live here. Hang on, sorry, just a second. Whoops, there you go. So I'll just read out the numbers as well, just so you guys can hear me.
I mean, just clarifying the question.
Yeah, and I hope the networks. All right. Okay. So voting's done. We'll do one thing. I'll just quickly open up to Chris to bring up Q&A quickly. Meanwhile, you guys can continue to vote. Chris, do you want to just bring up questions meanwhile and I'll try to fix the network? No questions specifically? Cool. Yes.
How do speeds and overheads compare for the three frameworks? The speed of rendering the
Sure. Go ahead.
Yeah, when you say speed rendering, definitely like Kiran said, there are certain template libraries which are faster than Django's default template library like Jinja. But at the end of the day, and when it comes to ORMs, it's usually
overheads.
Yeah, I'm talking about the ORM overhead. So it's not necessarily a big overhead in that. But what is generally seen, or what we generally advise to people is the web framework overhead is very minimal. It's usually the I/O part which is more intensive. Every web application is more I/O intensive, and that's usually the slowest part. And the overhead that a framework gives is much minimal. That's why you can build large sites with a complete framework like Django.
So to add to that point, I would say that the overheads you deal with are one, your ORM, how quickly can it load from the database, and this comes down to basically your database architecture. The cleaner it is, the faster it's going to load, and sometimes a clean architecture in your database is not a clean URL, because I for one, for instance, never primary keys in the URLs, because I think primary keys are internal data, they should never be put out in the public. But if you're having something else, then that something else has to be looked up in the database, and that could be an overhead. So there's a design problem that affects your overhead, one. Second, there's a security problem. You want to make sure this person is supposed to see what he's supposed to be seeing, or supposed to perform an action. Now, how you design your security architecture could be an overhead, and this is not a framework thing. Now, this comes down to how you want to do it. Okay? And the third thing is your template rendering language, in which case Flask clearly wins. It just got the better one. Yeah.
It's a full URL.
Your mic's not on.
Give it to me.
Yes.
And yet I have found that in the case of Flask extensions, they are quite opinionated.
Yeah.
And as well, and also some Flask extensions require another extension for it to work correctly.
Yes.
In case of say Flask SQL Alchemy, it kind of wraps the API of SQL Alchemy and tries to make it very close to what Django.
Yeah, but you don't have to use that.
Yeah, of course, that's optional.
Okay, so let's be clear about this. It does not wrap the API of SQL Alchemy in any way. All it does is links it to the session request, so that when the request starts in Flask, a session is opened in SQL Alchemy. That's all it does.
And it also proxies all the, you don't need to import anything from SQL Alchemy.
That's just an import. That's an import shortcut. It does not do anything to actually affect how the way SQL Alchemy itself works. Yeah, so that extension does not bother me as much as something like the WT Forms extension does, which is not only opinionated, it also changes API without warning. Okay, so I've had enough pain with that I've stopped using that one. Okay, but the Flask SQL Alchemy on the other hand is very, very nice because it solves one very specific problem, which is opening a database connection when the request opens, closing it when the request closes, and nothing else. It gets out of the way for everything else.
Okay, just moving on to the last couple of questions from Twitter. I've been able to thank you guys for posting questions via Twitter. I think I was able to weave in most of those questions into the discussion, which is great. I'm just going to quickly cover off the results. Unfortunately, the net's down, but here are the final numbers that I have. We have in third place is web.py with 13 votes, 1-3. So guys, please give a hand.
13 people going to try.
So I'm sure you guys are waiting to know Flask versus Django. Sorry?
Raise hands.
So so maybe more. So Flask came in at 29 votes. Django 48. So guys, just the last couple of questions. We've handled most of the questions that came in via Twitter. There's just a last few up here that I'm going to quickly bring up. So Kushal was asking, just using the Django ORM will do too many queries. Is it true?
Well, again, there's no right answer to that. It depends on how you design your queries. In case you find that you're resulting in too many queries, I didn't understand the question because one function actually results in a one.
When I'm using a normal simple just hello world kind of application or wiki,
right.
I use the Django ORM
right.
compared to SQL Alchemy.
Right.
SQL Alchemy will make like 3 or 4 queries
right.
to the database, and Django ORM, and if you just have a Django debug toolbar on, you find it might do like 100 queries.
No, that is because there are a lot of things which comes built into Django, right? Sessions or users and things like that. That adds to the additional database calls. Otherwise, sorry?
User error.
Yeah, I mean, just yeah, just eliminate that. I mean, it's not necessary that you have to.
What I'm asking is basically maybe a handgun, and you are saying along with the handgun, if you press the trigger, you'll just fire a couple of nukes also.
Well, you have a powerful weapon, don't blow your leg off.
Yeah, that's exactly why you use SQL Alchemy. I know exactly what it's doing.
Another thing I would say, that's the reason why I use WebPy database, because exactly how many database called making.
Okay. How many times are you going to do SQL injection attack checking in WebPy? Because it's not
all the inputs that we passed to it.
Guys, clearly these guys could go on and on, right? now, I was just want to mention, we're going to continue this, okay? To dive into this a little more and talk about other frameworks, maybe we'll talk a bit about PHP too, we'll see. But we'll talk a little more about pyramids with other frameworks, 4 to 4:45 in the open space up on the first floor. So those of you interested, if you love this, please stop by at 4. Thank you so much, Kiran, who got volunteered in a little bit, Arun and Anand. Amazing discussion. Please give them a big hand. Thank you guys so much.
So, if any of you guys are interested, I'd like to show you a code sample, and I want to see how you would do this in either Django ORM or Web.py. Let's see if you can replicate it.
Yeah, sure.
Thank you.
The next session for the day is Python, Arduino and Connected Objects by Ankit. Ankit is an interaction designer, creative technologies and there's an open space starting at 3:30.
Is there any good apps in Django for integrating the Jinja?
Hello? Can everybody hear me? Okay. Okay. I'll put it here.
2 minutes. So this is your desktop. Fine.
This is
text it.
Okay. Okay, 1 second. And alright, I think I can handle it from here.
Just plug it off for the time being.
Sorry for the delay in beginning. Okay, I'm Ankit, and okay, it's just running away from me. All right. So first of all, I'd like to know who of you are familiar with Arduino. Like, can you see a show of hands? So you've already done some kind of Arduino programming before. Any other hardware? Any other platform? All right. And who's not done anything at all and wants to know how to get started? Oh, brilliant. Awesome. All right. So what I'm going to talk about today is a little bit about how you can use Arduino and Python and mash it together to make fun connected objects. So for those who have not worked with the Arduino before, the Arduino has a bunch of functionality. So you can basically read and write analog and digital signals. Essentially anything that is a continuously varying or a binary varying physical quantity gets converted to an electrical signal. You read it, so you can do both analog and digital. You can also set up networks of devices. You could set up, so there are a few communication protocols which I will come to. You can also use it for timing or counting signals. So the functionality that I will be using mostly in the first half is the serial data. Serial data, there are quite a few different protocols, quite a few ways of sending data one after the other. Some of them I have listed them. There is UART, which is basically communication between two peers. So it can only allow two devices to communicate with each other. The pins are RX and TX. So you basically cross wire them and they keep on sending and receiving data. The other protocol is SPI, which lets you have a whole network of devices. So let's say that you have one master and 4 slaves, and you use certain hardware lines to select which device to talk to, and then you can basically exchange data, and that's full duplex, which means that you can send and receive data at the same time. The third one is I2C, which is a lot like SPI, lesser wires, but with addresses, but we don't want to get too much into the detail. And then there's hardware, which means you manually generate the signals. You basically, the signals that you see, all of that, or the first 3 are handled by the Arduino itself, but the 4th one, you can also take it up to you to generate it yourself. So you can write your own protocol if that works for you. Okay, so the format I'm going to follow is I'm going to tell you one way to use it, then I'm going to walk you through an application and show you the code to do it. The first one is the simplest. It's basically using PySerial. It's a library built to communicate to Arduino over serial. It lets you send and receive data from your computer. So if you see here, for all our purposes, there will always be 2 sections. One is code which runs on an Arduino, and the other which is Python. So first of all, this section run in here, the Python code runs on a computer and not on an embedded device. Alright, so on the left, if you want to start a serial communication, all you really need to do is say serial.begin with the speed of communication, and your communication channel has already been set up. Now, it communicates to the computer over USB. On your Python side, you just write import serial. You create a serial object like this. You select which port, which you need to find out from your device manager, and the speed of communication. So your communication protocol has already been set. Here, if you want to send some data from your computer to your Arduino. So I'll give you an example, right? Let's say that you have a NFC reader or something which has some data stored on it, and you want to send it to the cloud or process it offline. A lot of times your device might not be able to do it on board the device itself, or for security purposes you might choose not to. So what you could do is, let's say you have an NFC reader, you read it on your Arduino using an NFC shield. It sends the encrypted data to your computer. You upload it to the internet, or you decrypt. First you decrypt it, you process the data, and then you encrypt it again and send it back. So this would be an application of what you could do with just this basic code. So basically you say serial.println, that sends data from the Python to Arduino. On here you say serial.readline, and almost similar the other way around. The only difference here is in Python you need to say serial.available. Oh, this is the other way around, is it? No, this is fine. So on the Arduino you need to say serial, yeah, it's flipped over, but you need to say serial.available because a hardware device is dumb, right? Not as compared to a computer, it's dumb. So it does not know when to stop listening to data or when to start listening. You need to specify that. So here you just say if data is available then read it, otherwise it's just going to wait forever. Alright, that was one example. The other one I'm going to show you a demo first. There's no sound for it, so what I have connected is basically a sensor, and I have used matplotlib, which is a plotting library in Python, and I just run a simple invocation and that creates a graph. This is a simple light dependent resistor, something that detects if light around it is changing or not. So you could use this to debug your sensor data. So when you just move your hands around, you will see that the graph changes. So you could use this for visualizing data real time, like monitoring temperature, humidity, whatever you need to. Let me go back to the presentation. Alright, so how you achieve this is fairly simple. On your Arduino side, you are going to be sending just the sensor data. So you say serial.println and the value of your sensor, and that's all you need to do. You just send this one line of data, it keeps on sending the data whenever it has it from the sensor. On Python you need to do a little bit more. You need to create a figure object in matplotlib. You need to specify the axes and the limits. So here we have chosen to use 100 data points. So you will create, you'll set the limits of the x-axis as 0 to 100, which is basically time. And the y-axis basically is the value that your sensor gives out. So you plot that. Here we are using this animation object basically to create a moving sequence out of a series of images. So what this does is basically smooths it over by calling a function again and again. This line of code converts a simple image. So every time you'll have a snapshot of 100 values, right? So it just smooths it over and converts it into a transition. That is done. Alright, the third way is PyFormata. So what happened was, if you have an Arduino and you have code written for it, you can't see too much unless you've connected a motor or lights or a screen. A lot of times you might not actually need to control it physically. You might actually want to control it via a computer. You might want to remotely unlock or lock or start or stop something. And how do you do that? So Formata was basically written with the idea that there should be a computer interface to control the Arduino or any other microcontroller based system. So how this system works is there is standard code running on an Arduino, which basically you can modify as well, but it's already established. For different purposes there are different versions of that code. So if you just in your Arduino, I'm not sure if I have Arduino installed on this machine, but if you just go to examples, you will see this. You can just directly upload it. In Python, you need to do this. You just say you need the PyFormata library. You import the Arduino. You create the board on this connection. So you say that on dev tty acm0 my Arduino is located. Now, after this, the job is supremely easy. You just have to say board.digital. So you select the pin number 13, which is what I want to trigger, and I just say write. So I can either write a high or a low, a 0 or a 1, and I have that working. The same with a read. If you want to do analog though, it's slightly tricky. You have so what happens is the wave formatter handles an analog read. It continuously reports value, and you need to specify when to start and stop. So you just say enable reporting and read, but that can easily be handled as well. We will now move on to the more fun part of the talk, the one which involves the internet. So the UN is a relatively new Arduino board which has a Linux processor on board. So other than having a standard microcontroller, it also has a processor which can run a modified version of Linux, which means you don't really need to have a computer connected. The first half that we saw, you can eliminate that. So some of the features that you could use are an Ethernet port, a USB cable. It has Wi-Fi connectivity. It can also act as a wireless hotspot, and it also has SD card support. So how it makes your life easier is essentially that we use the serial library to be sending data from an Arduino to the computer and back. Here there is this library called the bridge library, this one here. This handles the communication in between the two sections on the UN. So if I want to send data, all I have to say is bridge.begin and then .send, and it will just send that data to the Python side, I mean to the Linux side. On the Linux side, all I have to say is print line. Like in Python, I just say print line, or I say in C, I say cout. And whatever is printed there can be read directly without any additional effort on your side. So let me give you an example. So one thing you could do is, for example, set up a data logger which basically logs all your data to Dropbox. So how that system works, basically that there is this Linux controller, the AR9331, which is running Python. I've written a script for that. I will walk you through the code. This one, the microcontroller gets data from the sensor. It sends it to the AR9331. This performs two functions. The first one is it saves it into a log file so that we have offline data in case we need it. And since we are using the file API in Dropbox and not the data store, what we are doing is we are taking this file and every time we're just uploading it to Dropbox and using it in replace mode. So we are not appending data, we will just replace the file every time because we do have a new file. Let me show you a demo. Okay, I don't have a demo for that, I have code for that. So there are two parts again. One is basically the Python sketch which runs on an SD card or a USB drive, and the other is the code which runs on a Linux, which runs on the Arduino. The Arduino code you upload via USB, and the Python code you need to plug in a USB drive, so you can either SSH into it or you can just put it on a pen drive and then make it run. Let me open this. Can everybody see this? Is the text visible? Alright, so there are a few parts to the Dropbox API. The first one is you need to authenticate yourself. You need to get a token. After you have the token, you can just use it to continuously upload the file. You don't need to do anything else after that. So we are saving the file. We are saving the authorization in a config file. We're using the config parser library for that, the module. So I have this file. Called Dropbox_auth.cfg in this location. So this location is where my USB drive or my SD card will be mounted, which you need to set yourself or figure out. Now I've written a simple Dropbox logger class which needs an app key, an app secret, an access token, file name. So when it is created, it tries to fetch the configuration. Let me zoom out a little. So it tries to fetch the config file with the authorization. If it does not exist, it creates it. If it does exist, it checks whether there is valid authentication or not. Once it finds that, it's really simple. This is all basically code to create a config, fetch the config, get the access token. So one trick with using Dropbox or Facebook or even Gmail is that you need OAuth authorization, and you can't do that without having a browser window. It's really tricky. So what you need to do is, the first time that you run this, you need to have connected to a computer, and on the console it prints out this link. You need to go to that link, authorize the app, and after that you're good to go. So there is this simple upload file function which basically opens the file and it says put file. The Dropbox already has a Python SDK, so it handles everything, and we've put it in overwrite mode. The next application is PyDweet. This is much simpler and a lot less complicated than Dropbox even. You can so if you've heard of the Internet of Things, or if you're very interested in it, you can implement this without literally any effort. So Dweet is basically this messaging sort of layer which lets you create an address on the internet, and using get and post requests, actually just get requests, you can send and receive data. So how this would work is, you have a sensor, you want to send data, so you just write Python code to post it to Dweet, or you can fetch it on your computer, your mobile app, so you can pretty much connect as many devices as you want to it without much effort. So how you would call this is, you could actually test it yourself right now if you like. So you just go to dweet.io, dweet for, and then you use your own UI. You can say, my Dreamland server, and then you pass on a JSON string, right, where you give the two parameters, the key value pairs. It will return a response which says it succeeded. Then if you want to fetch it, it's exactly as simple. It says get latest Dweet for and my dream server, and it will fetch that. This is not secured, of course, so if somebody knows what your UID is, then they can mess around with you, but you can secure it. They do have a paid service. Let me walk you through the code for that. This is a very simple wrapper actually. It just uses requests. It's okay. Alright, so the invocation for this is also like this, right? If you can use on your computer or on your own, it doesn't matter. You say Python dweet.py, you put in your own unique ID, and you say get, and it will get the response. If you want to send data, you say Python dweet.py, your UID, post, you give it a JSON formatted string, and it will post the data. This is literally how much code it is. That's really it. Get Dweet and post Dweet. So you use the requests library, makes your life a lot simpler, a lot less effort. You also need to write code for your Arduino, of course, to trigger the script. Okay. Let me fire up Arduino. Alright, so there is a library called the process library. You say hash include process.h. You have two sensors, A0, A1. You start the communication between the Linux and the microcontroller. While there is no connection, do nothing. Now you just read the sensor value using analog read. You build up your query string and you send the data. Now let me show you how sending the data works. You create a process called tweet. So all of this is highly abstracted. It has already been handled by most of the libraries in C and Python written on both sides of the Arduino Yun. So you create a process, you say run shell command. So it's basically an invocation on the command line. You run it, and if there is data available, print it out. You have the data already on the Yun side. The same with get. You run the shell command. If there is any data, you just do a print, and that prints out the data on your console. It passes on back to the microcontroller. Okay. All right. You could also, for example, use the Google Calendar API and have something like a desk, a smart connected calendar lying on your desk, which you can have a small screen with, which will remind you of your next meeting. You could further extend it to beep, and you could even extend it to allowing, you know, somebody to set alarms for you. So, you know, if your friend wants, he can actually bug you and say, hey, you know what, you need to get out because we have a meeting. So all of this, of course, you need to give them access, but it's possible. Let me walk you through the code for that. So here we are using the Google Calendar API. We have again built an SDK around it. I cannot share the client secrets because this is being recorded. But, all right. So the invocation for this is really simple. I've just said Python sample.py. So I don't really need any parameters because I know what I'm doing here. I just want to fetch the latest calendar data, get the next one event, and display it. So every time there's a new event, what we are going to do is we are going to connect to the Google Calendar API, download the list of calendars that you have, choose the calendar that you want. So there might be a work calendar, home calendar. You might have a lot of different calendars. You use the one that you want. You select the event. You select the next event that is going to happen. So you specify the current time as a parameter and fetch the events. The next event is what you want to display. So that will be saved in a text file offline. So in case there is no connectivity the next time, you still have accurate enough data. So these are a bunch of imports. We pass arguments. So these are the URLs that we're going to use: googleapis.com auth calendar. Okay. All of this is handled by, this is actually, most of it is example code for the Google Calendar API. So you can just grab this, and here is where most of the work happens. Get event file, load events. So what we are doing here is we are checking if the time delay. So what we are doing is we have a 900-second delay. So every 15 minutes I want to go and check if there is new events or not. You can change it as much as you want. So you could make it 9,000 if you want to check every 150 minutes. If the time duration has passed and the data is old enough, then you list all the events. So basically that gets a list of events from the Google Calendar API. Then you save it in a file. Also this list, out of that you fetch the first element and you save it in next event, and then you just print it out. If you see here, this line here, right, this is basically all you really need to do to send data to the microcontroller. So if you just say print, it of course displays on your standard shell, and that can be acquired directly from the microcontroller. This is a bunch of authorization stuff. So list calendars, again, this part of the code handles the calendars that you have created. This part supplies the time zone, the starting time, and a few other things. And it returns, if you see here, events.get. This is basically what you need, this and another one. We are saving the events to the file here, save events using pickle. So you save and load events from a text file using that. let me show you a demo of how this works. So here it's just waiting. Right, you just go to your, just for testing, you go to your Gmail, you create an event, specify the time, and it shows up on your desk. So you can do that. Coming back to the presentation, what you can also do is use the Facebook API. Again, Facebook has a Python SDK, so you can use the Facebook API, connect to your pages, read your inbox, fetch your page likes, manage your pages even. So you could probably connect a bunch of sensors or physical controls and let people interact with your web page. I unfortunately lost the Python code for that. I do have the Arduino code. So we're using a TFT library here, the TFT screen here, the screen that you see in here, this is the TFT screen. So this is slightly different from the normal 16:2 standard screens that you get. So what we're going to do here is, there is a library for that, of course. This library is for everything. You set the so this is a bunch of setup stuff. So you set the background as black, you set the color of the text as white, you set the text size as 2, you set the first text in the starting of the screen. So if you see the 0, 0, that specifies the x and y coordinates of the text. In the loop, we just create a process where we trigger this Python script, and if it is running, then do nothing. After it's done, this one will return true. Wi-Fi check.available will return true. So if there is any data, then get all the data. This is basically the results that Facebook returned for you, right? This is what we printed out. And after that, we just convert it into a character array and set the right position, set the right colors, and print it out. If you see here, tft.text, it just prints out the value, right? That is that. All right, and I'm going to put up this talk on this URL, so you can just download the code for that as well. So the code, the GitHub, and the presentation will be here. This was my presentation. If you guys have questions, we can take them now. Was it that easy? 9-year-olds can do it for sure, but not there.
You told about that Formata library, right? For Python. So, what's the limitation of that?
So, one big limitation is it's really, really slow. The way that it's been written, there's a lot of delay in between. So how this Formata library works is that there's a protocol which has already been established, the standard way of communicating. So if you say that digital write, like turn this pin on or off, then there is a sequence of characters which the Arduino is going to send, or the Python side is going to send. Now the way that this has been written, it's very, very slow. So there's a lot of delay in between, so it does not really respond as well as you'd like. So for real-time applications, you need to tweak it a lot.
Okay, how about you can connect more than one serial device to Arduino actually. You know that, right?
I didn't get you. You can connect more than one serial
device to Arduino.
Yes, you can connect it in many different protocols.
Yeah, suppose I'm using software serial. So will it support, like if I want to connect GSM to Arduino? It works on
yes, you can do that. So Formata basically is standard in the sense that there is code running on your computer and running on your microcontroller. So if you want to use software serial, you can do that as well.
Okay.
So if you need to use serial to get data from the Arduino.
Yeah,
After that, to send it to the GSM shield, you can always use software serial.
Okay, from Python code I can access that software serial
so
pins.
how you would go about doing this is you have Python code running on your computer. When you run that code sends serial data. Now the only way you can send data from a computer to your Arduino is via serial, like serial.write, serial.read. And
I can get that. What I'm saying is usually while using software serial, I'll be importing the software serial library into my Arduino or IDE or whatever Arduino code. So
after that, you can communicate with the GSM shield with that.
Okay.
So you need to use serial in the first part of getting data from the computer, but the second part of connecting to your peripherals, you can use software serial.
Okay. Okay, thank you.
Any more questions?
Any questions?
Yeah, there.
Can you shed some light on ATtiny processor microcontrollers?
That's not exactly relevant. The ATtiny is basically a different set of microcontrollers. So a lot of microcontrollers are made for different reasons. Some are meant for cheaper cost, some are meant for lower number of pins, for higher number of pins, for specific, like for example, if you want more PWM, less PWM. So these really depend on what they are made for. So that's not exactly relevant to it, but you can of course create your own kind of Arduino compatible board around the ATtiny and then use it along with the same code that we wrote.
And also I have been using PySerial for this kind of communication.
Okay.
So sometimes I get error like pipe broken kind
So
of.
that generally happens when you have like terminated, so you've unplugged it.
Okay.
Right, so from one end the connection is closed, but the other side has not gotten the communication.
Actually, it was showing in the the ID, the board was showing, but the connection was not happening. What used to happen was when I used to send data to PySerial and get the response back from the Python code. So that time it used to break that connection.
Yeah, so that would happen because if your OS re-evaluates the port, maybe it is unplugged, replugged, reset or something, the port on which it is there changes. The OS, the Python does not really know if that happened. So it's like saying that the connection broke in between while communication was happening, but the notification did not reach the microcontroller, the Python part.
Does the baud rate affect this time?
No, not really.
Okay, thanks.
Yeah, him.
So we have Linux running on the other microprocessor, right?
Yeah.
Can I directly address the pins on the Arduino through the Python code?
Yes, you can. Not via Python, but there is a GET request and POST request API again. So if you just on your microcontroller, if you say GET and then you put in the URL and you say pin and digital and A0, A1, digital D1, D2, it will get it directly without you having to run any code even.
So it's like a small code that is running on the Arduino.
Yes, there are quite a few. So because it's Linux, there are quite a few scripts running in the background which are ready to respond back with data.
Is there any simulation library
for
Arduino? Can we simulate
in Python?
In any?
So I mean, there are quite a lot of people who offer simulation tools. So for example, there's Simulink. If you use that, I'm not sure if BinPy supports that yet, but there are quite a few simulation libraries for that. Yeah.
All right.
All right.
Thank you, Ankit.
Yeah.
Thanks for your wonderful delivery. We have 30 minutes break, so we'll meet here at 4 o'clock. Yeah. Tea break.
We've lost a camera by one of the attendees, so if anybody finds that, can you just drop it in the first row to the session volunteers? Thank you.
Hello? Okay, so that's working. This is not coming yet. Yeah. Pull it out. Let's reduce the. Okay. Let's go.
She will introduce you.
Yeah. Okay. Yeah, another 5 minutes. From Hyderabad.
Welcome back. Now we have a session regarding which messaging layer should you use if you want to build a loosely coupled distributed Python app by Mr. Narahari. He is a developer who loves building large-scale messaging and low-latency applications using Java and Python. He is going to talk about messaging layer and which one to use to build a loosely coupled distributed Python app. Thank you.
Thank you very much. I hope everybody is able to hear me clearly. My name is Hari, and you might have noticed that in that one single line there are a lot of big words, messaging, loosely coupled, distributed, and all that. Don't worry about that. I would say this is the single most heavy piece of this PPT. After this it will be very light. Don't worry. It will not be very confusing or anything. So briefly about myself, I am a Python enthusiast. I am learning web development in Python. Learning as in I've built a website which works, and I keep on adding features into that and expanding my knowledge. On my job I work with messaging systems, so anything server-side messaging, putting it across a bunch of worker nodes, worker queues is what interests me, hence this talk. So this one, we'll have this talk for about 25 to 30 minutes if everything goes according to plan. It will be mostly talk. I don't have any code examples here, but I'll try to give as many examples as possible from my work every day, and something which you might find it easy to understand, and at the end of it we'll see if you have questions on messaging or anything in Python which we use for messaging. So with that, let's get started. So what is messaging? So when I say messaging, we could think of it in various ways, but the messaging which I'm going to talk about now is between applications. So all of us work in various software companies, and we have a lot of internal systems. Some of them are large, big, monolithic systems which we built over a period of years. So there will be one big application which is doing everything. Or we'll have a bunch of applications, we'll do some work in one system, we'll pass it on to the other system in some way. So if you want to make all these applications to speak with each other, communicate and collaborate in some way, then you need a sort of messaging in between. Similarly, if you have a big organization which has one big application and it is not scaling up the requirements, and all of a sudden it's going very slow, then one of the ideas is to break it into pieces, each piece doing a manageable part of work, and then running it in one instance. Then you would find that these 4 pieces act with one another and they work faster than what a single system can do. So the first slide here is an example of a system, or an example of an architecture where maybe there was some organization, maybe it was a web outfit, maybe it was some sort of a corporate entity which had various in-house systems, and they had to communicate with each other. And everybody built a simple ad hoc system. So the payroll system needs a list of all the employees. So the HR said, we'll just make a CSV file out of it. We'll FTP the file to you, read it in. Each month 15 people join, they make the file again, they send it again, something like that, very rudimentary. Maybe another application required something else, they built a file interface. Maybe somebody said, we'll build HTTP interface, something. Each system has its own interface. It exposes an interface for a particular functionality. Everybody calls that. Everybody calls everybody else. So you have a lot of calls going across the system, and it maybe sort of works, but it's a mess. Everybody talks to everybody. Suddenly if there's a problem, you don't know if it's because of the HR system calling the payroll which is wrong, or payroll calling something else which is wrong. There is nothing which will help you find out what the hell is going on there. So if you apply a little bit of logic on this and apply the principles of messaging, then you would end up with an architecture which looks something like this. Here, we still have all those systems in the company, or we still have all those parts of the application. They want to speak to one another, and they speak through a common message queue. You all must have heard words like RabbitMQ, Redis, or any other AMQP broker. And all these are messaging brokers, messaging queues which are available. They have APIs in various languages, including Python. Very simple to use, very simple for integrating into your applications. So if you build a proper messaging system, this is how it will look. Now, this is only one of the ways in which you can build a messaging system. This is a scenario where there are a large number of applications in your organization which want to speak with one another. That's the case which is being solved here. But I also mentioned another case where you have an application which is not able to scale, and you want to put some work, you want to remove some work from that main processing thread, put it on the side, work on it asynchronously. You can think of anything like you upload a video to YouTube. The moment the file is uploaded, you get a message saying your video is being processed, please come back after some time. Then you come back after half an hour or something, your video is processed and it's now available. That's like an asynchronous processing. Same thing happens with any large application. So if you build something like that, then it would look like this. So you would have the main master application, which was doing all this work. It wants to offload the work so that it can be picked up by the workers. So it will create individual items. So I upload a picture, you upload a picture, you upload a video. Each of them, instead of being processed one after the other in the same application, you would put them in a separate queue. And then you will have a bunch of worker processes which come and pick off from there. So they work on that, they finish it. And sometimes once a worker is finished, it will have a bunch of results which it has to share back to the application. Or in case of a website, let's say you upload a picture onto Facebook, the picture gets uploaded, it gets appropriately resized or something, then it has to be put onto the feed for all your friends. There is no result there, just that it will find out who are your friends, put a task on a queue, it will get picked up, and that particular friend will start seeing an item in his news feed, so and so upload a picture. So somebody can come and like your picture. So these are the ways you would see an application if you built a proper messaging application. This can be done in any language, and we're going to talk about a few message brokers which you can use in Python. Now before we do that, what was the main point of this? You have an application which is in a big single block or very highly coupled with all the various parts, and you want to build a loosely coupled app. So why do you want to do that? Like I mentioned, you either want to make it fast or you want to make it very easy to manage. You want to be able to put and remove parts from the application easily. Like you want to change how you process the pictures in your web application without impacting your entire application itself and all that. So you will have a bunch of reasons where you feel it will help your application. And once you know that, the obvious thing is you just go and write some code and your application is ready. But once you have figured out that this is what you want to do, and before you go and write the code, you need to make a bunch of choices. Because if you just pick some messaging library and you just write some code onto that, it might not work for you. You might not get all the results which you were expecting. So like in the morning, in one of the sessions, Anand was saying that they processed something with pure Python code, and then they used a library, but it became 80 times slower than what was originally working, or maybe 80% slower than what they did in Python. So if you want your application to work faster or work properly, then you need to make a bunch of choices. So next few slides, about 5 or 6 of them, we will go through what you would need to think about, how you make a choice, and then once you made the choice, you can go and write your code, right? So the basics. Will the application benefit at all? So let's say I have an application, web app, I am running it in Flask or Django, and the user uploads a picture. If within the user session I try to see if the picture is under 5 MB, resize it to a thumbnail size, put the thumbnail somewhere, upload the picture to the backend and everything, then by the time the user hits upload and until he gets back a response, he'll get bored. He'll stop using your website. You will not be able to sell your website to people, you won't get users and all that. So that is something which is obvious. You should not process a large image in the same thread where the user session is being managed. So you need to move it out. Maybe there is something else, like you need to send an email. As soon as the user signs up, you need to send him an email, login, for activating his login. Now, that does not make sense to put in a separate thread. You could just send the email, finish. It will go in half a minute. So you need to think of your use case and does that really benefit, and where to split it. So now you've already made a choice that you want to split it off. You need to now think on where to split it. Which part? Which part can live as its own container? Which part has to be part of the application? Maybe you made 4 parts of your application. Both of them need to access the same IDMS objects, same row, same table, whatever you call that. Then there's no point in making them separate. Those kind of things. So that's the second point. What are the components and how are they related with each other? Do we need more than one instance? So if you're building a very popular website, some components of your website will require more processing, more throughput. People upload more pictures, maybe people send more messages to each other. So you would find that in order to make your application handle the extra load, you'll need to have multiple instances. So if you're running a website, you're getting 1 million page views or more per day, obviously you won't be able to run with one instance of your web server. Similarly, if you have something like this, which is being hit more, and you're separating it out into a completely independent process, then you need more instances of that. And then sometimes when you make something into multiple pieces, you suddenly come up with new use cases which you didn't have before. So now I have an application which has let's say one logic dealing with photo uploads, one logic with sending some message to the user once the photo is processed and everything. So now if I have split it up, now while it was a single application, this would finish, this would make a function call here, it would work. Nothing can go wrong. Both of them are running in the same process runtime. No way it can miss. But now I'm made into 2 separate processes. So user uploaded the picture, you processed it, you put a message on messaging system saying send him an email, but that message got lost. He never gets the email. He doesn't know if the photo is uploaded or not. He can come back and check, but that's not what we want to do. So now you have another use case that there should be something, maybe a monitoring script, which looks at this queue and sees if there is a pending messages being processed or not, messages being lost, and all that. So you get a new use case there. So these are the basic things which you should think about first. This will help you draw that box diagram where you have A, B, C, D, lines between them, and you know that this is my flow. Yes, this looks good. That is something your architect will probably sign off on. Yes, write the code for it now. So that's the first thing you need to do. Now, then you'll have the patterns. Now, whenever you talk about messaging, you have things like one kind of messaging, you make a request, you put a message on a queue, and then it will get picked up. The other kind of thing is, you make a request, you put a message on a queue, but you wait until you get back a response. Request, reply. The first one was queuing, you just put on a queue. Second one was request, reply. That is almost synchronous, but the only advantage is you're moving the processing out of your main thread. And the third one is publish, subscribe. You just publish a message to all the interested parties. They will subscribe. You don't have to worry about whether they got the message or not. Your job is to send. User logged in. Publish the message. All the other components will pick up user logged in, log him into the chat, log him into the newsfeed or whatever you call that. So you need to identify which one suits your application. For most of them, the queuing mechanism works, because if you have a transactional system, like you uploaded something, you want it to finish, you don't want it to get lost. Then you put it in queue, that message will wait, worker will pick it up, work on it, finish it. Let's say you published, nobody was there on the other end, your message is lost. So most of the systems require a queuing system. Some go for request response depending on how critical it is. I work in a bank. I cannot go for a publish and subscribe for all the systems. Most of my work is based on queuing. Some I can do publish subscribe. Then you have messages of various kinds. Sometimes, let's say you upload 100,000 photos, everything is sitting on a queue. One of the photo is corrupted. So your worker thread picked it up, trying to process it, hung. If it is not moving. So one option is to restart the worker. But again, it will pick up the same photo again. So it will fail again. So if you had some sort of control message that you put another message on the queue and you bounce the worker comes up, looks at the control message which has a higher priority, looks at it and say, okay, I need to ignore this picture. Ignore that, continue with everything else. So you might have to have some sort of command and control messages and your own application messages. That's something which you need to worry about. Then the basic things like whether you should send a message in a particular format. You can send a JSON which can have any fields it wants, or if your message was very specific to your line of business, you might have a XML format, maybe a what do you call it? I think it's called electronic interchange or something, EDI, something like that. PDI formats, you could send in that, basic things. And sometimes you'll have some components which talk a lot. So this component sends a lot of messages into the system compared to one of the other components. So maybe you want to separate them out so that one of them does not flood the other and both of them are able to work and manage. So you need to identify those things. Latency, routing and priority. So I've been working for many years in this, and not even once I've heard anyone say that I've published a message but I don't care what happens to that. Everybody says we need that message. So once a message is published, it has to get to the other end. Whether it gets in 5 minutes or whether it gets in 15 minutes or whether it gets in 50 milliseconds. That is a problem which you're trying to solve. So once you've taken your application and built it into components A and B, then you need to worry about how fast messages are getting from A and B. If A is the publisher, you need to see if B is able to keep up with it or not. So those are the things you need to do it. Sometimes you get a message saying so and so event happened, but that is valid only for 1 hour. So after 1 hour there is no meaning processing that. Or for example, you get a message saying user logged in, but you have not been able to process it for half an hour. User logged off in 5 minutes. What's the point of processing that message? So you might need to put some things like, if I send a message, this is valid only for the next 15 minutes. After that, if you get the message, please don't worry about processing it, ignore it, or something like that. And like I was saying in the previous case, some messages require highest priority. These are like control messages. You have to tell your worker that please stop. I am going to perform a software update and restart all the workers. So you send a message, worker sees the message, it will not pick up anything from the queue. You finish your software update, bounce all the workers, then they start working again. Those kind of things. These are use cases which you would see only when you have multiple moving parts in your application. One big application, you will never see this because it's very simple. Not many problems there. Build, manage and support. So all of us are programmers. We write code, we put it into production and we let users use it. But then somebody has to support it. Some of us do support work also. Some of us have a bunch of people doing the support work. And if the application is so bad that it fails every few hours, then the support people will call us and shout at us. They won't let you sleep at night. So you have to build an application which is easy to manage. So it should have very good monitoring. It should be easy to provision and manage. As in, let's say one of the components fails, it should be very simple to bring it up again, restart it. There should be no problem with, before restarting it, this was working on something else. Now it has been restarted, but it has no clue what to do. It's just waiting there. What do I do now? It should not do anything like that. There should be guaranteed message delivery. This is applicable to transactional systems. Crash recovery, like I was saying, let's say you are processing something and you failed in between. When you start back up, you should be able to pick up from where you left. So when you write your code for a messaging system, I was saying that writing code is easy, but you need to make the proper important decisions. So you are processing on something, you failed. Now you need to restart. What do? You need to record that this component was processing this particular message. So some of the messaging systems which you will see provide a means of making an acknowledgement back to the queue. So until you make the acknowledgement, the message will be on the queue. So even if you fail, restart and come back, you will find the message there. But if that is not the case, your code has to handle this. So in Python, you can do it in various ways. To quote the session from morning again, Anand was saying that by caching the page, they were able to do it faster, write it into a file. Something like that. You could just write it into a file. And the same thing applies to the last one, which is in case of issues, how do you clean up and recover from wherever you were. So these are the things. So the last few slides, the basics, patterns, and this is for how you write the code. And this is for whether you suffer for your code or not. If you write your code properly, if you have handled all this, you will have less issues and you can concentrate on the core business of building users, making money, whatever it is. So what are the few options you have? So now in Python, these are the options which I find most useful. In my job, I use a lot of other things. I can't use them with Python, but these are the options which I have used in Python. RabbitMQ. This is a full-fledged AMQP message broker. As in, there is a centralized message broker which is responsible for routing messages from the publishers to the subscribers, provide guarantees in between. This follows the AMQP format, so you have exchanges, fan in, fan out, routing, queues and everything. Full-fledged messaging system. So if you have something where you need all the guarantees, you don't want to write your code to do all these things, and you want something which is rock solid and you can trust, you should go for something like this. Next one is ZeroMQ. This one is similar to RabbitMQ, as in this is something which was forked off from AMQP, I think in version 0.8 or 0.9, I don't remember exactly. This does not have any message broker. So each client starts an instance of ZeroMQ and it publishes on that. It's like raw socket connection with some extra functionality on that. So you would not have a broker. So the publisher would have to publish, it would have to instantiate ZeroMQ and publish. There would be a subscriber which would instantiate ZeroMQ and subscribe, and they would work without a central coordinating mechanism. This is also good. This also provides all the messaging semantics like queues, pub/sub, request reply and everything. The next one is Redis. Redis is not a messaging system at all. It's just a key value pair. So I mentioned about a queue. What is a queue? It's just putting something in a list. So within a Python standard library, if you're using the multiprocessing or the threading libraries, there's a class called queue which works in memory, and you can pass messages between two threads using that. So one thread takes a queue, puts a message on that, it will appear in the other thread and it will process that. So if you think about it on a big scale, in Redis you can create a list which can act like a queue. So one process goes and puts a message in that, the other process holds that, picks it up. That also works. Redis actually has a pub/sub mechanism as well. It internally simulates publish, subscribe in a way. So you could publish messages onto that and it will be available. So your publisher puts messages into Redis, gets stored in Redis key value pair, Redis crashes or you restart it, it's maintained based on how you configure it, then the subscriber comes up, it will find the message. That also works. Now these three are ones which have some form of messaging built into them. Next one, it says you can use RDBMS as messaging. That's possible because you create a simple model which can contain message ID and message, and you put your messages in that. Message ID, message, process, yes or no. Put messages inside, simple insert statements, publisher only inserts here, and the subscriber does select from messages where processed equal to no. It will get a bunch of messages, work through them, mark them as processed, yes, finished, go and run the SQL again. That also works fine, but you would have to write a lot of code for yourself. There are a few libraries, like if you have ever used Celery, that has an underlying messaging library which actually supports this. So you can use that. That's a separate project now, so you can use it. The third one is RPC, remote procedure call. This is when you say, I don't trust any of these, I will build my own messaging system. You build your own message broker, you build your own means of queuing and everything. If you are so confident that that's the only way to solve your problem, you can. We have built this in a few cases, but we have never used it for mission critical things because we don't trust things will work. Because for all the other things, if something goes wrong, there will be a community, documentation, help, support and everything. But if you build something on your own and it fails in a big critical situation, not a very good position, right? So you need to watch out for that. So these are the few options which I have used and they work well. Haven't had any major issues with it, and things are okay there. Now, future growth. So there is a little story I want to tell about that picture. Tokyo Metro. I used to live there a few years ago, and that line is the biggest and most popular line. Lots of people get onto that to get from one end to the other end of Tokyo very fast. Every day the line gets so full near midnight that you cannot get into the train, and people push you into that. You get into the train, people have pushed you, you stand like that, you get to your station, people push you out, you get out, right? Now the reason I put it there is each train, which is for let's say 100 people, for 1 or 2 hours every day, it will accommodate 150 plus people, each compartment. So it's able to handle that load and then come back without any accident. So when you're building a system, one of the things you have to consider is future growth. You have 100 million messages today. What if it becomes 150 million tomorrow because you have the most popular website on the internet? You need to worry about it. So what if there is a sudden spike of 15%? Will you be able to handle it? What if your business grows very well and until you can buy a new server and put your stuff there, you need to handle this load for 24 hours. Can your code handle that? Or more like, when you write your code, what can you put there so that you can handle this load and come out safe? Obviously that comes with other things like storage cost, where do you put all the messages, where do you persist them, logs and everything. And last but not the least, let's say you started with RabbitMQ and RabbitMQ is not working for you. You need to move to something else, which is also an AMQP broker. How easy is it? If you have coded everything according to the API, according to the spec, and it's just easy to replace a config URL for RabbitMQ with a config URL for something else. it should work. Those kind of things. So those are the things which you would need to worry about. And once you have considered all these things, then you can go and write some code. Now you have answered all the questions which you would face once your application goes live in production. Now you write your code considering all this. The chances are that you will get the performance which you are looking for. Your system will be stable and it will work without causing any problems. Right? So that's all I had. Any questions?
I have two questions. The broker, does it keep open connections with the publisher and subscriber always, or whenever the message comes into it, it opens a new connection with the subscriber?
It will always have an open connection. So if you have a broker, the clients are always connected with the broker.
Okay, there's an open socket.
Yes.
Is it the same with the 0MQ as well?
Yes.
But you said 0MQ will open a new raw socket.
0MQ opens a socket and it starts publishing. So let's say you have the publisher. In 0MQ, the logic is that client can come up before the publisher. Client has opened its socket, waiting, listen, there is no publisher. Then the publisher can come up and publish message. But if the publisher comes up first and the client comes up afterwards, then it will not get the message, because at that point it was not connected. Now if you use something like RabbitMQ, because there is a broker, you can configure the broker in such a way that the message will be stored on the queue. But at 0MQ that will not be there. So the connection has to be open in order to get a message.
Okay. Again, there's the subscriber will have a worker, which I think is a thread pool.
Yes.
All the subscribers, will they be using a single thread pool, or like each one will have their own pool that will be assigned a task?
Each subscriber, okay. So a subscriber works like this. If you use a callback, each subscriber will start a thread and it will have a fallback function. It can be a single thread or multiple threads in a pool, like you said, and it will pick a message and it will invoke the callback. If all the subscribers are in the same process environment, in the same program, then they might be sharing the pool. But if each worker is a separate process, then obviously they have their own pools.
Hello. So my question is like, if the RabbitMQ server or the other messaging systems that you talked about, if I have put my message in the queue and there are like tens and thousands of messages, and something goes bad, like maybe the server crashes. So is there a persistence of the messages, or how does it, like you mentioned maybe Redis has a persistence. What about other protocols?
RabbitMQ is a message broker, proper message broker, so you have options in there to configure persistence. So you could say that each time a message is received, it has to be written to a file. Only then the subscriber you will get the message. Or you could say send the message but write it to a file asynchronously. That is possible in RabbitMQ. It's possible for Redis because it's a cache, and you can put in a configuration persist it to disk for recovery. 0MQ, that is not possible. You'll have to write that logic on your own. Similarly, if you do it using some form of an RDBMS, because it's all transactional, it will be there.
Hi, I have a couple of questions.
Sure.
0MQ, there is no message broker in between, right?
Yeah.
So how does the client and server discover each other? Like the client has to discover the server?
0MQ, as far as I remember, it will discover using broadcast messages. So when you start a publisher, you will start on a port, and then you will start a subscriber using that same port. So it will ping messages between them, and they will figure out. If I don't know the exact logic right now.
Does it use multicasting or something? Or
yeah, they use a bit of multicasting, I think it's a mix of UDP and TCP. Exact handshake I don't remember right now.
Okay. The other question is, you said Radis, right? Like it also supports the publish subscribe mechanism.
Yeah.
So in that case, does it use the message broker style or?
Redis publish subscribe is, you could say, similar to a broker. It's a similar implementation, but you won't find things like like for example, RabbitMQ has a concept of an exchange, where you can say any message coming into this exchange has to fan out into 4 or 5 receivers. That's not possible in if you use something like Redis. You just have to say this is a simple subject. I am publishing on that. If I have 4 subscribers listening on that, they will get the message, otherwise it will be lost.
Any questions?
Any more questions? There's one there.
I have a question on Redis. Does it support transactional mode of say I have a message and I want to process it, but I'm not sure whether it's going to take, it might take some time for me to process it. So what I want to do is I want to keep that inside Redis, but I don't want to remove it. But if another consumer comes up, I don't want to serve that either to that consumer till I say it's complete. Something like that is possible in RabbitMQ, I guess. But is it possible with Redis?
No. In Redis, you have a way of picking a message completely from the queue, or you can do a peek. So I think what you're trying to do is something like a peek. But when you do a peek, there is no way in letting the other application know. But if you do something like this, then you could build another element, this last peek message ID or something, where you pick a message and to update this value. Any client which wants to peek will first go there, look at it, find the next message, and then pick it up. So you'll have to build that guarantee in there.
So what will you say is your favorite messaging system, and what will you suggest somebody to use in production?
Okay, so production. So from this list, if you wanted to do something locally on your laptop, I would suggest you start with Redis. Unless you have a very strong requirement of things like an exchange, routing and all those things. But even then, there are libraries which simulate AMQP on top of this. If you look at the website for Celery, I forgot the underlying library's name, but there is a messaging layer in that which is built by the same author that provides some sort of those things. And for production, you have to use something like RabbitMQ, because there you need message guarantees. But if your production information is something which is like logs, if you're just monitoring your website traffic and doing some sort of big data thing, then if you don't mind losing one log here and there, then you can use maybe Redis, maybe Apache Kafka or anything, all those things.
Kafka, some people are talking about it and it's not there. So what is that giving?
Apache Kafka, I have not used it, that's why it is not there on this list. But as far as I know, it's like a distributed log. So when you write something in an RDBMS, when you insert something, it makes a transaction log in the backend. So Apache Kafka is something like that, but it's put on many servers. So if you have large amount of information, like I was talking about website traffic, then you get petabytes and petabytes every week. In that case, it makes sense to use Apache Kafka because it's into a file. So if you want to open the file in some other application or just Notepad, open the file, work with it.
Right. Thank you, Hari.
thank you all. So thanks for your such a wonderful session. And now we have the lightning talks at 4:45.
Good evening, friends. We're going to start with lightning talks for day 2. The first lightning talk, this group has traveled all the way from Kathmandu to attend PyCon India, so they deserve a round of applause for that first. Awesome. And during the conversations only, I understood that they have a Python user group in Nepal as well, which is of a pretty decent size. So they're going to talk about Python user group in Nepal for the next 5 minutes. Round of applause for them.
So it'll work like this, right?
Yeah. F5. No, F5 is I think for refresh on the screen. F view and full screen. Okay, mode. Use this now. You can use the ODP on also. That will look at view presentation. Okay, that will work. No signal, I know why. Hello everyone.
I am Sudeep Kafle, and I am from Kathmandu, Nepal. And we have just, as you said, we have just traveled from Kathmandu to attend PyCon, Nepal. We have a small group of Python developers in Nepal. It's around 50 to 60 people. We have a gathering of meetups that we conduct every month, and then we discuss all about what we are doing recently. There has been a recent trend in Nepal that people are loving Python because of the language. It's so simple and it's easy to learn, and people in colleges and all those places are switching to Python as beginner programming language. So, currently there are very few Python programs in Nepal, but we see a potential that in coming years we will have a huge number of Python developers in Nepal. Okay, it's very. So let's talk about how big is the Python community in Nepal, and talking about our activities on Stack Overflow that I extracted from the data. So there are around 54 and 38 Python developers based on the number of questions and number of answers in Stack Overflow. So most people are more used to on PHP, JavaScript, all those programming languages, and there are very few people that are using Python as a programming language. So if you see our activities on GitHub, there are at least 101 people that one repository on Python. So, there are very few software companies in Nepal. So most people prefer freelancing through different websites, and there are so that's a very small number currently. But the good thing is that taken the use case of having a huge number of Python in Nepal. So these are all those products and companies that are working as taking Python as a product. So and we are trying to make it more user and friendly. So counting the number of developers, we can say that it's around 400 to 500 that are actually active, counting students and all those developers. So our future plan, why we have come over here, and what we want to do is that we want to learn from the other developer communities, how Python community and all those things grew up in India, how we have stood up to this position where we can organize an event like this, and we want to get feedbacks from all of you on developing similar type of community in Nepal. In all our meetup, we just share our experiences. But as there are few Python developers from Nepal, we have a very few topics to share. So we'd like to. Okay, we'd like to have someone someone just presenting from Skype or Google Hangouts, so that we can interact with you on all those meetups. So if anyone is interested on these type of things, you can just contact us. So that's all. Thank you so much for listening.
All right, thank you so much, Sudeep. Next we have Vineet, who's going to present his project pip dep tree.
How do I drag this one?
Okay, so hello, my name is Vineet. I'm going to talk about this small simple utility that I had built. It's called pip depth tree, and the idea is that it shows you all your dependencies that are installed in on your system in a tree format. So so it's a very simple tool. It internally uses pip itself. What I'm going to tell is how it is useful. Okay, so yeah, so I have this virtual ENV here. If I say pip freeze, so it shows me all the packages, but they are just listed as a flat list. So now suppose I know that I am not using GNU readline anywhere in my code, but is it safe to remove this from is it safe if I just uninstall it? I have no idea unless I check that whether each of the other any of the other packages are using it. So yeah, so instead of pip freeze, I have installed pip depth tree inside this virtual env, and now if I call pip depth tree, then it will print everything as a tree of dependencies. So I see that GNU readline is being used by IPython. So if I am using IPython, I shouldn't delete it. This is one reason. Another reason is, so if you see the warning above, it says that there are possible confusing dependencies here. Now Python in the pip doesn't have a true dependency resolution. It lacks a true dependency resolution. What it means is, yeah. So you install packages using version specs. So when we say pip install, you can say pip install just a package, or pip install equal package equal to 1, it will install version 1, or package greater than or equal to 1, which will install the current version, as long as it is greater than 1. Or you can say package greater than or equal to 1 but less than 2.0. Now, suppose you are having two packages in your list of in your requirements.txt. Package A depends on package C with which should be greater than or equal to 1.0. Package B also depends on package C, but it should be greater than 1.0 but less than 2.0. Now what happens is, if you install package A first, then it will find this package C as a sub dependency of it, and it will just install 1.0, and which means that if the current version is 2.2.4, then it will install 2.4 and package B will break. One thing you can do is to add package C explicitly. So you should say package C greater than 1 less than 2 explicitly in your requirement.txt file. But here, so this is what it does. If at all you accidentally install such a thing, then it will show you. Actually, I unfortunately could not find an example. I had an example before, but it no longer works. So it was I faced this problem with installing Nose 2, which use a different version of 6. So, but now it is fixed, I guess. So I can't show that example. So, but yeah, that's about it. So it is on GitHub. You can feedback or anything. Yeah. Thank you.
Thank you, Vineet. Next we have Ankur Gupta, who is going to present one of his projects known as importpython.com.
Hello, yeah. It's working, right? Yeah. Hey. Hello. It's working, right? Yeah. Oh, it's right. Oh, what? This doesn't have one. It has HDMI. It won't work.
This is mini display.
Okay, I'll take his. I ask him. Vineet, can I get your laptop? Can I borrow it? Can I borrow your laptop? Thanks. Net hai na? Okay. Just give me the browser. That's all. Yeah, that's it. Just open import Python. Enter. Oh, no, there's no net. No.
No internet.
Can anybody get internet working on a Mac? No, you just need to configure it on this machine. It's a.
No, he can.
Okay. Okay, so I get down? Okay. Just ask him if he needs net or what. Okay. He has it.
Okay, meanwhile Ankur sets up his laptop. He needs internet connection. We'll move to a different talk. It's by Praveen. The talk title is PyTest.
Yeah, sure. Hey, is this on? Yeah. Hello? Yeah? Alright. Yeah.
Can I try one thing?
Sure. Yeah, yeah.
Extend.
Extend, right?
No, use extender. It will refresh your. Give me one command line.
Hello everyone. My name is Praveen Shirali. I'm a test architect at Riptide.io. So today I'll be talking about PyTest. This is a test framework to test Python code. I would just like a small vote. How many of you, honest answer please, how many of you test your own code? Okay. First. And how many of you use PyTest? Cool. How many of you have never heard of PyTest or never used PyTest before? Okay, fair one. Alright, so this should be useful. So it's a beginner talk. Since I have a very short time, I'm just going to run through some very basic components of PyTest. Hopefully it should be a starting point for you guys to explore PyTest further. Either you may want to use it or not want to use it, but at least it should give you some idea. So let's get started. So so there are two aspects to PyTest. You can use PyTest as a test runner as well as a framework. So if you have existing tests written in unit test or any other form, and there are a few forms which are supported, you can use PyTest to run those tests. And it's just going to run those tests, and you're going to have a report which is in whatever PyTest supports. So it can output on plain text in a verbose manner. You can also export it as an XML in the JUnit format. PyTest is also available as a framework. This is the part which gets interesting, and this is what we're going to explore. We're going to explore the second part, where we write tests in the PyTest format. So okay, some basic stuff. Are you guys able to see the screen properly? Right. So you can install PyTest through pip using these commands. You can also just check for the version. The latest version is 263. You can do PyTest minus version. Please note the naming convention. It's a little funny. So the PyTest package is just PyTest. If you run it on command line, you need to say py.test. It's just so it can get a little confusing if you're starting. So you can invoke PyTest directly from the command line. You can just say py.test, and there's some options which you can pass, and then you can either pass a module which you want to test, or you can pass a path from where test would be discovered. You can also import the PyTest module and run PyTest from within your code. This is what I'm doing now. And you can actually just make a list of all the arguments that you would originally would have wanted to run with the PyTest. I'm using two arguments here, -verbose and -s. -verbose is going to basically list out all the tests that are running, and it's going to give you a very nice detailed output of what's happening. The -s switch is going to print So PyTest actually suppresses standard output. It actually captures it. So I want PyTest to actually not capture it, and I want it to show up on the terminal. So I'm going to use these two switches. So the way tests are discovered is quite standard. It's very similar to most other frameworks. So all modules which start with test, they are the ones which are picked by PyTest. If you have classes defined in it, the classes have to start with test with a capital T. A note here, classes are optional. So you don't have to, like in unit test, you don't have to subclass from unit test.test case. You don't even need classes actually. And if you are just writing methods or even plain functions, the functions need to start with the word test. And all of these are configurable. The entire discovery is configurable. Fixture. So fixtures are like fairly important components of any test framework. So a fixture is something which lets you set up an environment where you can actually test your code in isolation. And people who test, I mean, you'll be familiar with the terms setup and tear down. So generally before a test you set up certain things, and then after the test you tear it down. And then the next test also sets up something, and then the test is performed, and then you tear that down. So that's a basic fixture. A typical fixture in PyTest looks something like this. So I'll just construct it from scratch. So let's just take a function. One minute. Shit. Okay. I'm just going to run through. Do I have some more time? Just a couple of minutes. Okay. All right. I'm going to run through run through my slides pretty quick. So this is what a fixture looks like. So a fixture is actually self-contained in PyTest. So you have the setup and teardown code within a single function. You can define it this way. And what PyTest allows you is you can have your test functions separate and your fixtures separate. And fixtures are like single units which can be passed in as a dependency. Let's have a look at a test case. So this is a simple test case where you have a function, and then the first argument by position is actually a fixture. So PyTest actually discovers this fixture for you, and it executes a setup code. It then executes your test code, and then the finalizer. There is actually an order in which PyTest finds all of this out and executes. I am not sure if I have a lot of time. Alright, so let me just go to the last slide. So you can actually go to this link and download this very file which I am presenting. There is also a test script. You can just run it with Python followed by the file name. Just make sure you have PyTest installed. Yeah, and that should be a self-guide for you. Yeah, thank you.
Thank you. Is internet working on this?
No. Let me check.
चलो ना PyCon का disconnect to PyCon India. Can you just open the browser?
Looks like the internet is back, and so is Ankur Gupta. He's going to present on importpython.com.
Hi everybody, my name is Ankur, and this is a small hobby site that just out of hobby I've created. Just have a look. It's called importpython.com. It's got two things. One, it's got this book section, wherein it's got a list of all Python books that are out there in the market, irrespective of the publisher, and they are categorized under beginners, intermediate, advanced. So you know Python and you want to figure out which are some advanced books to learn from, so you can just click on advanced and you can kind of have a look at them. There are a lot of people who have actually written Python books which are free. So if you click on the free thing, it will show you books that are actually absolutely free. By the way, this is the mobile version working because there's some problem with the screen, like the physical machine. So you can download these books if there's a PDF, and if it's an HTML, you can just click and it'll take you to that website and you can read that book. So there are close to 54, 55 free books, and they're all listed. And some of these books are really good. So actually, Test-Driven Web Development is a pretty good book, and it's still to come out, and it's completely free. So you can get a look at all those books from here. Do any one of you subscribe to Python Weekly or PyCoders, which is a newsletter, right? So the idea is that it's a single newsletter that goes to the same newsletter goes to everybody in the world, irrespective of what their preferences, the choices are. For example, when I open a newsletter, I mostly look at the GitHub projects that are there and which are trending. I really don't care about events because those events are mostly in the US. So I wanted to do something about it, and what I've done is I've created a newsletter which automatically learns after a couple of subscriptions that what you're clicking on, what articles, or are you clicking mostly on the GitHub projects, and it customizes your newsletter after the 10th or the 15th issue. So this is a sample of the newsletter, and yeah. So first you have a list of all the articles, then you got GitHub projects which are trending. It also tells you the number of stars, how many times people have tweeted that particular project. The spotlight section puts spotlight on a couple of Python developers who have kind of launched something recently or have put out a very good open source package, etc. Conversation picks up Twitter conversations that have a lot of RTs or meaningful conversation happening on a tweet, which is obviously in relation to Python. Audio video section picks up some Python videos that are trending in the last 1 week. And events in your country, the idea is that after 4th or 5th issue you get a button wherein you can click and customize which country you come from. So it will only send you events happening in your country and not US, which is the case of PyCoder and PyWeekly. I'm actually looking out for users to kind of help me test the thing as it goes forward. And so all you have to do is you have to just click here, write your email address, subscribe to the thing, and you can always unsubscribe if you don't like it. And yeah, that's about it. Thanks for your time. Thank you. Yeah. Correct. Yeah, that's what I meant by the link. Oh, okay. So what happens is that I use the Amazon API, and whatever image I get from the API, I use that. So it is yeah. This is so all these free books are okay.
We'll take it offline.
Okay.
We'll take this question offline. Yeah.
Oh, okay. All right. So your question is that is it legally correct to use these books? Is that what you're saying? No. Then? Yeah. So it's legally allowed. It's legally allowed. Yeah. Thank you.
Next we have Vinay. He's going to talk about Python plus GitHub APIs.
Hello. No, that won't work. Okay, so is this visible? Yeah. So a lot of us use GitHub
most of us use GitHub, and even from an organizational perspective, a lot of code bases are on GitHub. The problem that we usually see with GitHub is, unlike any other traditional source control system, it's really difficult to have a lot of pre-post hooks or stuff that we get usually done. Let's say if anybody is using SVN, the olden days, people used to have some initial sort of checks before the code actually gets checked into the main repository. Or let's say you want to trigger some build, but you want to trigger a build. I mean, we already have Jenkins. Jenkins has Python API. Then we have Jenkins GitHub plugin and all that. The thing is, let's say you have incorporated a system in place which gets, which notifies Jenkins to run a build. But what if the code has a problem? So let's say you have a lot of sources, the code has a problem, but then the build is anyway going to fail. Something of that sort can be caught much early, and a remedial action can be taken up. How do we do that? GitHub provides a lot of APIs, and using GitHub APIs, it's quite possible to handle those events. GitHub provides the webhooks plus the APIs. A combination of that with Python, we can put in place a very good solution which can do a lot of work for us. I'm going to show you a quick demo of that. So I just created a junk repo. So in this junk repo I have two branches. Just this. Let's say the workflow is something like people usually have a pull request that they create or something like that. I'm going to create a new pull request. Okay. So this is usually, most of the companies have this philosophy wherein not everybody would have commit access to their main repositories. People will have only a few select people will have commit access. Others are encouraged to send pull requests so that it can actually have a review and then it can get merged. So what we can actually do is we can actually set a hook to work at any of these events. So I'm just taking an example of the pull request event out here. So I can actually say, I'll show the source, just a minute. So what it's going to do is set up a hook. So there will be a notification onto that URL 54.179.6666/gh hook. So if I look at the repo setting, webhooks, this is what got added right now. It wasn't there before, I just created it using this very nifty script. It's fairly simple, just a bunch of simple requests call. I use Python request library over there. And now that implies that at any point in time, every time there is a pull request event, it's going to send a notification to this URL. So all I have to do is put my listener on that. So we can use Flask for that. Now Flask is listening on that particular URL port. Now I get back to my pull request. Let me have any sort of an event on my pull request. So I close it. I put a break over there. So that event is caught. I accidentally catch any of those events out here. Now let's say I proceed. Let's say I reopen a new request. Even that is caught. This is actually the GitHub notifications API and a GitHub webhook notification mechanism sending me a notification which is caught by my Flask plugin, my Flask application, using which I can do any sort of work that I need to do at any given event. Let's say I want to ensure that even before my build gets triggered, I need to run some checks, probably catch some bad patterns if in case there are some bad patterns, or if I see that build is obviously about to fail, I can even stop the build. I can build a lot of logic around simple mechanism, and all of that using just a couple of scripts using Flask and Python. So you can see that there's an automated comment. This comment I didn't post. I got this comment posted via that snippet that I had written. create hook is just this, nothing much. Done? Yeah. That's about it, folks. Just look up requests, Python, GitHub APIs. Thank you.
Thank you, Vinay. Next we have Charul. She's going to talk about how I started with open source.
Hi everyone. So let me introduce myself first. I'm Charul. It's not visible there. Yeah. So let me introduce myself first. I'm a fourth year undergraduate student at IIIT Labat. I've been working with Fedora from quite some time, and I worked mainly on two projects, that was Data Gripper and Shum Gripper. You can see it here. And I did two internships. One was outreach program for women, and then after that I worked on GSOC. So I recently have completed GSOC, and I'll be telling about my project Data Gripper. So this is the first patch that I submitted in Data Gripper. Let me tell about what Data Gripper is. In Data Gripper, it displays historical information about, it collects all the historical information and displays them. So you can have different kinds of queries, and I'll be telling you about them. Like, these are the information that you have about different kinds of data. So what I did, this was the first patch that I made, and in this the Data Gripper already has the API, and what I had to work on is I had to build the web front end of it. And so I had to, this was the first small function that I made, and in this I had to check what the accept header is, and accordingly I have to give preference to, if it's in HTML, then I have to, it returns true, and then it displays the HTML content of it. So after that, I worked on this GUI of this whole message, how it displays this information. So it was all JSON data, and I have to take out important information from it. So images, this topic, and all description. So I use fedMessage.meta functions for it to collect useful and readable information from this JSON data. And I'll be showing how we can do some kinds of queries. So we can filter out the data according to topic, username, or by some package name, or date, time, accordingly. So if I select user Charul, then it will, I think net is not working. Okay, so it displays my that information or historical information related to me. So this was the thing. Then I worked on, this is the odometer that I added on the front page of Data Gripper app, and it's showing the total number of message count, total number of messages that are present in data gripper. After this, I just build this extension for Fedora package. Data gripper is it's a Flask app, and this is a Fedora package, another project, and it displays the information related to packages, different packages. So if data gripper is a package, then what it is showing, this is the extension that I made for Fedora package, and it's showing the historical information related to that package data gripper. So this is the extension that I made, and after that you can have a look at my repository. This is the source code, and if you want to go and contribute, you can, or you want to have some discussion, you can come on Fedora Infra IRC. So okay, thank you.
Thank you, Charul. Next we have Anisha. She's going to talk about Women in Open Source Award.
Hello, everybody please return the feedback form after filling it. There is a bucket outside the gate naming feedback form. Please drop it there. If you have not the feedback form. Yeah. Oh, it is outside auditorium. Okay. Thank you.
Am I audible? Yes. Women in Open Source Award. I'm going to give you a brief introduction about this award. So Women in Open Source Awards recognize the impact that women are making in open source. We want to give recognition to the women who are making important contributions to open source, and we also want to hear from women who are applying the open source principles to or beyond technology. Now you might be having a question, why is it just for women? Community, we have a problem. I see a sad ratio, male is to female, which I can even see in the audience. So we need to encourage more and more women to join our community. Diversity is one of the important factors. Increasing the diversity leads to innovation, and innovation is something that we need in open source. We have two tracks for this award. One is the Women in Open Source Community Award, and one is the Women in Open Source Academic Award. So females who are enrolled as a student can also get file nominations and get nominated for this award. And women other than college or who are not students are also eligible for this award. So there are already a lot of existing outreach programs which have successfully inspired women to increase their contributions in open source, such as ADA Initiative, Linux Chicks, Open Hatch. So these awards, the Women in Open Source Awards, is just a complement to the existing outreach efforts to shine a spotlight on those women who are doing great work in open source, and to encourage more women, to inspire more women to join our community. Now, what kind of contributions qualify? It doesn't have to be only code contributions. You can have different kind of contributions. It can be documentation, bug triaging, quality assurance, UX marketing, and stuff like that. Anybody, so all the women are eligible for this award, but cannot be a Red Hat employee. That's one of the things which is there. So we have awards which includes some stipend, and for any queries or any more details, you can write to us at womeninopensource@redhat.com, or go to the URL and follow the page which is there, redhat.com/about-women-in-open-source. I have a few handouts with me which you can collect and distribute to your female colleagues, so that we see a better ratio at the next conference if we see each other. Thank you.
Sorry. No problem. Okay, here we go again. All right. I have a quick announcement. I think many of you have sort of come by with questions asking about Jessica McKellar, who's been unable to make it. We hope to have her down as a keynote speaker along with Michael and Kushal. As you guys might have heard, she didn't get her visa in time. She really wanted to make it down, but Indian visas, enough complexity. I'm sure Michael was able to work through those hoops really well to make it down here, but unfortunately Jessica couldn't. She wanted to convey her regrets for not being here, to say all of you, she really wanted to make it, but in an effort to sort of make up for her not being physically present here, she wanted to try to do something else with the local community. I've been trying to coordinate with her over the last couple of weeks to see what was possible. It was a little hard since she was traveling to London for PyCon there and she was completely out of reach. I got through to her earlier this week and I spoke to her about either trying to do a tweet chat or try to do a Google Hangout. And she circled back with a couple of dates that work for her. I've tried to sort of space it out a little further away from PyCon because I think I'm sure many people, the volunteers here, would like a little break right after this. And also we have Navratri and Diwali coming up in the month of October, so finding some slots in between was slightly tricky. But two potential dates that have been put out, which may work to do two separate sessions. One is October 15th, 8 in the morning California time, PST, which would be like our evening, 8:30. So October 15th and October 20th are two possible dates when we might set up some Google Hangout sessions. A public link will be shared for those of you who would like to get onto a session with Jessica to interact with her. I am also trying to set up a session with her with PyLadies, the chapter. I'm actually trying to coordinate with Anisha, who just made the announcement now about the Red Hat Award, which I think is fabulous. And I really hope we endorse more such programs which are more inclusive of women. And I really hope we'll see more speakers like Anisha who come forward and present at next year's PyCon. So I'm trying to set up two of these sessions. So the dates are roughly October 15th and October 20th. So look out for further communication on this, likely on the Twitter channel, as well as likely on some of the groups as well.
Thanks, Ravi. Next we have Praveen Kumar, who's going to talk about Python plus Jenkins.
I am audible, right? Yeah. So just quick run. How many people are using your Jenkins for CI CD part? Awesome. So this talk for you, maybe it will help you to parse the stuff and then do something. So actually I'm just talk about where it fits this particular Python Jenkins API. So actually like assume that you have two, three builds, and you want to take a log, and inside the log you have to parse something, and you that parsing thing you have to give to another job, right? So so there you can trigger that job using that particular API and then pass the parameters. So this is a very, very quick example. So this is my local Jenkins instance where it's running. It is a parameter job, and we are building the job. So it has the hook called, when we are building the job, there is something called block is true. So till the job is not finished, it will not return anything to you. So it will actually make sure that once the job is completely finished, then only it will return. And then it will give the results, and you can pass the log and gets whatever output you want. This is quite a big project. Actually, it supports all kind of Jenkins REST API. It has a wrapper for all the Jenkins API. You can create the job, you can delete the job, even you can add the slave, delete the slaves, and all those things. Even you can modify your jobs in the Jenkins using that particular API. You can even get the artifacts and all those things. So this is the URL for the upstream where the people are working, and they have if you have the issue, there is issue fields. You can file the issue, or if you want to contribute, you can just pull it and start working towards it. They also have the very, very small documentation about how these particular things are working. But the document, if you are trying to use it, the documentation, it doesn't help you much. So please go through the code and then figure out, or either just create the object of the Jenkins and then check what all the methods are available. What else? Yeah, I think. And the notebook is whatever I am using right now. It's already on the GitHub. You can try it out and check. Thank you.
Next we have Arun Ram. He's going to present functional programming in Python.
Hi. Yeah. Hi, I am Arun Ram. Yeah. Before we proceed, okay. So I just set a timer in Google. Okay, let's look at a very small snippet of code which is generating a sequence. Something like 1, -2, -3, 4, 5, 6, -7, -8, -9, -10, something like that. It goes on. So how do we generally implement it? So we tend to have two loops, one within another, one for generating the number, and another for keeping the count of negatives. So one negative first, and two negatives, one positive, two negatives, three positive, four negatives. This is how we go. So what we actually do here, we take each number, and then we look at what is the number that I am going to get next, and what kind of operation that I need to perform to get the next number. So this is in a way we are operating on something called variables and objects. So this is a paradigm. So what we call is iterative paradigm. Whereas, let's say, can we look at this a little differently? So we just need to generate a sequence of numbers, 1, 2, 3, 4, means whatever it is. So it's just natural numbers, and then if we multiply it with +1 or -1, we accomplish the job. So you are just thinking the set as a whole. Can we
implement the same in Python. Right? Okay, this is the function where you generate the natural numbers, which is 1, 2, 3, 4, and then you generate the multipliers, which is nothing but 1, minus 1, whatever it is, for which you need the power numbers, in the sense whether it means you get -1 power on which is -1, and -1 power even numbers, it's all 1. So that is generated using this function. So what we say here, if you look at this, it's all means you operate on a set which is a complete set. It's not you are not operating on an individual element. You operate on a complete list. So you generate a natural number, then you generate power multipliers, then multiply it. That's what we do. You do, and for which you use some of the functional tools which are there, which are something like map, then something like lambda function, and if you want a different implementation of the same, which is here. So either you can do it using map or you can do it using list comprehension. Let's say in functional programming, you are given a list. What can you do with a list? You can generate one alternate element for each element in a list. That's one kind of operation you can do. Or you can filter out only certain elements in a list. That's another kind of operation you can do. Or you can reduce the entire list into a single number or a single value. So these three operations form some of the core of the functional programming paradigm. And Python has a library for the same, which is functools. And here you go. When we say you get one element for each element in the list, that's something called map. Or you filter out only certain elements based on some kind of condition, that's filter. Or if you want to reduce it into a single value, that you have a reduce function. And there are a few other things which you can do with functional programming, something like a function composition. Let's say so this is a file which is there in my GitHub, which would convert whatever your source code that you give from one case to another case. Let's say you want to convert it from camel case to snake case, or snake case to train case, or to all caps or all smalls. It can do. So there are about 8 different formats here, and if you want to convert it into 8 other or 7 other formats, you would need something like 56 different combinations of functions. But using function composition, you just need to get those basic functions right, and then combine it using compose. I think the alarm has triggered, so I'll just stop my this one here. But you can look at my GitHub and Twitter account at Arunatma. So that's what it is. Just an introduction to functional programming. You can look up at this particular page, which is how to functional, which is in Python docs.
Now we have Bhargav, who's going to present on word clouds in Python.
Hello? 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 Can you hear me?
Hello. Yeah. Hi, I'm Bhargav. I work at Nextdrop. Today I'll be giving you a demo on a workload library built by Andreas Muller. He's the co-developer of scikit-learn, a machine learning package in Python. So basically what I'm trying to do is collect all the tweets that went out during this conference with this hashtag PyCon India and creating a workload out of it, and can we trying to see what we can get out of it. I use the TweetPy library to download the tweets. It's a very nice library. I had to write only 4 lines of code. Okay. Okay, and the important thing is, let's see what the workload tells us. Opening the workload. So this is the one with all the tweets till 3 o'clock in the afternoon. We can clearly see our keynote speakers and Kushal Das and White Space at the very end. And we had lots of Arduino related tweets. That is something interesting. And then this question of Flask versus Django versus web.py, who is the winner? So basically web.py is at the top, and then Django is at the right end. Flask is there, so we can clearly see, depending on the size, Django in blue clearly wins. I like. So I did not do a good job of clearing out things. They are basically these hyperlinks. So Django clearly wins in this contest. That is something nice. I would like you guys to play with workloads with your own data, and at the end of today I'll be posting a picture with hashtag with all the tweets for 2 days as one picture. So thank you.
Thank you, that was interesting. We've left with just 2 talks, sorry for the delay. The second last lightning talk is by Anand. He's going to talk about Python Express.
So I want to talk about Python Express, a project of, sorry. Can you hear me in back? Okay. So I'm going to talk about Python Express. It's a project of Python's PSSI. So back last year, before PyCon India, we started a small project called Python Month. We celebrated the month of August as Python Month. So what we did is we created a form and asked college. So we thought of conducting Python workshops in colleges across India. So we created a form and asked colleges to sign up if they were interested to connect to Python workshop, and we asked Python experts to sign up if they were interested to connect to Python workshop. And it was very well received, and we conducted a lot of Python workshops across India in that month. So what we did this year is we built small tools to make that process easier. So that's Python Express. The website is pythonexpress.in. In this website, if you are from a college or any education institute, you can go and sign up as an organization, and you can schedule a workshop. If you are a Python expert, if you are interested to spread Python to student community, you can sign up as a trainer, and we send an email when someone schedules a workshop, so you can go and express your interest to conduct that workshop. So far, there are some of the workshops that were done. So the upcoming workshops are the one which are not confirmed yet. The confirmed ones are listed under the completed workshops. So if you see, there are probably too small to see. There are more than 100 organizations signed up on Python Express now, and more than 100 people have trainers have signed up on Python Express. We have not done quite a lot of workshops yet, but I think it's a good start. So here is an example of a trainer profile. So once someone signs up on Python Express, that's Arun Konak Modi. Okay, so he has done 2 workshops recently, and he's about to do another workshop on October 8th. Okay, so there are a lot of, so all this is done voluntarily. Okay, so we try to make sure there's no money involved. So we'll try to make sure the college won't charge any money to the students, so that since the trainers are doing it voluntarily, so we expect the college to also not to charge any money. Okay, and we okay. So and here is a one of the workshop pages. Okay, and here is an here is one of the workshops that's completed. Okay, yeah. So it's pretty. So once someone signs up, he'll get to once someone signs up as an organization, okay, so they can schedule a workshop, and then a mail gets sent to all the trainers. Right now it gets sent to all trainers, but we want to limit it to the same city. So trainers will can come and express interest if they're interested to conduct the workshop, and college gets to select the best trainer. So I would request all of you to participate. If you're a Python expert, please sign up. And if you're from a college, if you are interested to conduct a Python workshop in college, come and register, and then we'll make sure a Python workshop gets conducted in your college. So help us spread Python more, and please sign up on the site.
The last lightning talk of PyCon India 2014 is by Shivraj Patil on Google App Engine using Python.
Hello? Hello? So. Hello? Hello? Can you hear me? Yeah. Very good evening, everyone. This is Shivraj Patil here. Mic on? Hello? Yeah.
So, good evening everyone. I'm Shivraj Patil and I'm a student of MSRIT. And what I'm going to show now is my last sem project it is. And I'm going to tell you how you can use the Google App Engine with using Python. And so, what are tools and configuration you required before starting? You have to have a Eclipse and PyDev App Engine plugin for the Eclipse, and Google App Engine voucher for to deploy the app into the Google App Engine, or you can directly do it by the Eclipse IDE as well. So, and after that, you have to create a API project in the Google API console and add your app ID to the YAML file. I'm going to show you. So the project name is Pop the Query. So this is actually a website which is hosted on the. It's completely running on the App Engine, and the Pop the Query is the website for the basically for the students. It's kind of Stack Overflow for the students, where students can post their subject related questions to onto the cloud, and other students who know the answer for that, they can answer there, and people can vote for them. It's exactly same as the Stack Overflow, but for the students, and teachers can select who is doing better and all, and even teachers can post the questions and as an assignment and tell the students to answer for the same. And I'm quickly go through the. So this is the app ID I have created here. DevApp demo is this thing. And this is a data browser where all the questions were stored in the Google data store. So this is my app.yml file where you have to mention your app ID over here. So this is my app ID over here. You can mention that. And for all your CSS and HTML files, you have to mention that path over under the URL thing. And this is the Python code which is actually running over here. And in data store actually for every database you have to create a separate class for each database, and in data store each row is considered as a new object, and there's no any it's kind of a NoSQL database. And here I have a register, visitor and comments three databases, and I have created these three classes, and the variables under that are the sections of the fields of the data store. So this is the home page, and how actually the App Engine works is everything works on the URL. Okay, so if you want to go to home page, then dev.demo.appstore.com/homepage. If you call homepage, then it will automatically load this class, and the get method will be executed. And in get method, you have to actually render your HTML page. So the template class is used to render the HTML page into directly. And the register is the raise the question means I'm calling it for the asking the questions HTML file, and to return the data and store it into the data store in the HTML form action you have to call only post/post, so it will automatically execute this post method. And inside this post method you have to get the HTML fields which all you want to store, and this one line will actually put the data into a data store. So I tried with using Java, but trust me, for Java the code was around 450 to 500 lines, and by using Python it was around 120 or 120 lines, I guess. So these are all the fields, and so this is how you call the classes over here. So /homepage dev.demo.appstore.com/homepage will be load the homepage, and main page like whatever all URL you have to load, and in the HTML page you have to call the / pages. That's all. And here I'm going to try raise the question. Okay, thank you.
Thank you. That brings us to the end of PyCon 2014 India. Few stats for the closing notes. We've had over 1,200 people who've checked in the venue. We had 1,300 registrations, so just 100 people dropped out. They didn't turn up for PyCon India. That's bad for them. They paid and we got the money, yeah. So that's good for us. But yes, we've had over 1,200 people who've come in these past 3 days, which is pretty awesome. That officially makes it the largest PyCon in India. We've never crossed 1K mark. This year we've done that. Also, the network team just updated with few stats, which are pretty interesting, so I'm just bringing them forward. We had about 900 unique devices getting connected on our network on day 1, and about 800 devices that got connected today. We've transmitted about 125 GBs yesterday and about 110 GBs today. So that's like, and networks were, sorry? Okay, so the guys like Kushal who were trying to download movies, there were 16 of them and we blocked them. Apart from 20 action-packed talks, we had over 15 open spaces and over 20 lightning talks. Don't blame me if it got delayed. Also, it's been a strong effort of 50 plus volunteers from the past 3 days, on-ground effort, and over 60 volunteers, a hardcore effort from the past 6 months all across the country, and few international volunteers. I would request the next 5 minutes for all of you sitting over there to applaud for the volunteers as I call the team names and the volunteers on platform. Thank you. And it should get louder, please. First is the network team. Then we have the registration team. Talk selection panel, come on stage, please, come on stage. Session chairs, video team, miscellaneous, inventory, speaker coordinator, volunteer coordinator, open space coordinator, and all the other volunteers who've done an amazing job for PyCon India 2014. I repeat, all the Thank you so much. Thank you so much. Awesome. Thank you everyone. It was amazing 3 days with you. Thank you very much. Hope to see you next year again. And please fill the feedback form. We've run out of time, so we're not taking open questions. But there are paper on the table there, so you're free to write down feedbacks and submit it. And we are now having AGM meeting, so you're requested to stay down, be with us. You can give your feedbacks over there as well.